Right. So I think we'll start. Good morning, everyone. Welcome to this 156th edition of the Zak World of Façades conference series. This is the third one here in Melbourne, eighth one in Australia. My name is Ahmed. I'm part of the organizing team here at Zak. I'll just quickly introduce the event for those who are attending it for the first time, and also our event partners without whom this event wouldn't have been possible. Yeah. So we've been organizing this conference series since 2012. As I said, this is the 156th global edition. These are the events which we did in 2024 all across the globe, from New Zealand up until Canada. We organize events. This event's taken place in 42 countries as on date. I think by end of the year we should touch 44 countries. One-day events, all talking about facades. The way facades are designed, engineered, installed in different regions are completely different. So we try to adapt the local practices of that respective regions, and then we invite speakers to tell different stories on how they have executed their facades. And this is what we've been doing. I think facades are now become the most important part of the building. They were always, but I think with sustainability and carbon taking the forefront of any good design now, I think facades play a very major role. And these events are courtesy our event partners that like to mention all of them and let you know what they do. All of them have a booth outside, so you can definitely drop by their stands in the networking breaks or during the course of the day. So our presenting partner is NorthGlass. NorthGlass is from China. They are one of the leaders in jumbo glass. I think some of the most complex and jumbo size glasses in the world are produced by NorthGlass. We start with our associate partners, AkzoNobel. AkzoNobel are global leaders in powder coating and coil coating solutions. They've been a strong partner of this conference series globally. So we have Alspec, who's one of the leading Australian aluminium door, window, curtain wall system companies, partnering with us for the first time. CN Terracotta, again from China, one of the leading terracotta manufacturers, again specialty in different glazes and jumbo size terracotta. Climate Ready Engineering, they have a very Australian company. They've got a unique shading solution which they have put it on display at their booth outside. China Southern Glass, one of the leaders in coated glass solutions out of China. Envelope is the rain screen cladding product from DC Tech, which is an Aussie company. They've got membranes and other value-added products for the building envelope. Equitone, part of the ETEX group, so they've got fiber cement cladding solutions, again a sustainable cladding product. Finotech, one of the leading sealing and bonding solutions provider from Switzerland. Frontech, Spanish company, have got ceramic cladding, again some nice finishes and different applications it can be used on. Glass wall systems from India, one of the leading unitized curtain wall producers from there. Golden Aluminium, one of the leading extruders out of China. Kingspan insulated panels, again they've got different rain screen cladding and solutions for the whole building envelope. Larnic is from Spain, so they are a specialist in complex geometry structures, especially free from parametric structures. Lysag, part of BlueScope, again are one of the leading steel producers. So this is their downstream stainless steel cladding product which they are presenting over here. Metz is the distributor of Onyx Solar from Spain. So they've got a interesting building integrated photovoltaic solution. Obex from the UK, so they've got membranes, adhesives, again some sealing and bonding solutions for the whole building envelope. QDP is Quandat from Vietnam, again one of the leading unitized panel producers out of Vietnam. Saint-Gobain Glass, one of the global leaders in coated glass solutions and leaders in sustainable solutions. Sculptform from Australia, they are launching their rain screen cladding product. Trafalgar, who are the distributors of side drives. Side drives are from the UK. They've got cavity barriers for curtain wall perimeter joint protection and rain screen cladding. Technoform, from Germany, world leaders in warmage solutions and polyamide strips for improving the thermal performance in aluminum profiles. Vitro Architectural Glass from the US, global leaders in coated glass solutions. WHTV Glass, again one of the leading glass fabricators out of China, with some jumbo sizes at their facility. And the next few events I'm just quickly running through because I'm cautious of time. Just introducing our bigger event. So New York's our second largest event in the series. So that's in a few weeks from now. Our largest one in the series is London. So London's close to 1,000 delegate event, and we partner with the Society of Façade Engineering to organize their Façade Gala Awards and dinner after the event. So it's a carnival, it's a party there in London. Little bit in the nearer region, Bangkok is our last event for the Southeast Asia region in November. And of course, our next two events in this region, we've got Sydney. We had Sydney in September last year, so our summer edition in February 2025. And of course, my favorite is New Zealand, Auckland, a country which has surprised us the most. So these are our events in the region. So we've got Auckland, we've got Sydney, and of course Thailand, London, New York, and many more other events. We've got 15 more events to go until the end of the year. So as I said, every event is different. The way facades are designed, engineered, installed in different regions are very different. In some regions you talk about carbon, some regions it's all about cost, some regions it's, forget carbon, forget cost, just build. So there are regions like that. I don't want to name them, but we have certain events where things which are from another planet which are shown. I don't even think facades like that are going to be built. But if they do, I think it's going to keep the construction industry going. And it's also going to innovate the facade industry, because what's happened, at least in in developed countries, I think there's been an emphasis on a lot of embodied carbon, which has actually led to facade engineering as a profession becoming more retrofit projects or recladding projects, and the complex geometries and the other engineering stuff which happened on facade has reduced, which means forensics, diagnostics, and other things are taking precedence, which is fine, which is good for developed countries. So I think you need to have a mix of both. And I think with our events, we're able to present a wide spectrum of topics across different events. Today's events is high on everything. So we've got a mixture of glass, we've got adaptive reuse, we've got new build, we've got complex geometry. I think it's a wholesome agenda today. We've recorded today's event, so those who would like to revisit the recordings, you'll get a YouTube link from us a week from now, and you can always refer to any presentations you missed during the course of the day. End of the day, we have a post-event networking reception thanks to our partners, NorthGlass. So please do stay back if you're able to. So that's it from me. I'll take your leave. I'd like to introduce today's event host and convener, Kathryn Walters. She's part of the Facades team at TTW. So she's going to be taking you through until the end of today's event. And I hope you enjoy our speaker's storytelling today. Thank you.
Next. Thanks, Ahmed. Welcome, everyone. I would like to begin with the traditional owners of the land on which we meet today, the Wurundjeri Woi-wurrung people of the Kulin Nation. I pay my respect to elders past, present and emerging, and extend that respect to any Aboriginal and Torres Strait Islander people in the room today. The program today continues the thread of last year's conference in relation to the importance of embodied carbon, but also the increasing complexity of facade design and the industry in general as we look to the future. We will also hear more about the Victorian chapter of the Society of Façade Engineers, so make sure to look out for that one at the end of session 1. And stick around for the panel at the end of the day on present issues facing the facade industry. So a bit of housekeeping. The only sessions today where we'll have question and answer will be the panel at the end of the day. So please hold your questions during the presentations, during the sessions, but feel free to seek out the speakers during the networking breaks. Just also a reminder, please keep your phones on silent. If you need to take a call, please duck outside. And just a reminder for the speakers of session 1 and future sessions that we'd like to take some photos during the networking breaks. So please make sure to stick around. So I'd like to thank Ahmed, Kathryn and the Zak team for providing us this great opportunity to come together as a facade community to share and learn from each other's experiences and think of ways to educate not only ourselves, but those around us to keep growing the future generations and our industry profile. Now I'd like to bring up our first speaker, Oliver Ng, Managing Director of BG&E Façades, to talk about the future of facades.
Thanks, Kathryn. Can you lock the doors back there so that no one can escape this? And in the world of 30-second clips, if you don't like this, you can't swipe left or right or whatever. So anyway, 157 editions. It means 156 times a bunch of people with the same mindset, same things that we're looking for, sitting down the whole day talking about all things facades. So I too would like to acknowledge the landowners of this country, past, present, and the future. Before I start, I'd just like to give you a bit of background. I did architecture, practiced as an architect for a couple of years, got into development, and then got into facade contracting, and then consulting, and I've been doing this for a while. So, talking about the future, I was going, where do I start? And I was thinking, well, maybe we start here, which is my thesis in 1994. All right, so that was 30 years ago, and probably still my best work to date, because I haven't really designed any high-rise buildings since. But sort of the fundamentals of design. That roof there was a PV roof, collected water, drained down, watered the plants into a planter box that shades the building, and had a bit of a weird shape because it was north, south, east, west, and this was I graduated in Perth, so this was a job in Perth, so pretty much same here. They put your course in on the east and west. Now, obviously, we look at a real job and a real architect, right? Cheeky of me to put my thesis there, but this is a building that was in Perth, completed in 1991 by Harry Seidler, and when that came up, they had a lot of talk about this building. 200-year lifespan, passive design, very similar, sort of the basics of engineering, double glazed units those days, separate AC. That was, at that time, 30 years ago, was pretty much a building of its time. Now, before I talk about horrors of facades, why are we still having so many issues on facades? Is it because facades is still not recognized as mainstream? We've had many issues over the years, and somehow, in my opinion anyway, what I've seen is not many people are still taking this seriously, and if they were, universities would be having facade courses in it, and I don't see any of that. There's one in Bath, and even that's disappeared. Not sure what's happened. After services, structures, what's the next biggest item, right? spoke to Greg Skeens, prominent insurance lawyer, and he always talks about the 70% of 70%, and 70% of facade claims, 70% of insurance claims are facade related, and 70% of that is water related. And maybe that's why people are talking about, this FP 1.4 or F3P1, I can never get that right. Now, premiums have caught up, and the payouts are less than what the premiums are, but that's still a big challenge as far as getting insurance coverage is concerned. Now, just one Google, and if have a look at that, it is spectacular, not for the right reasons, but there's a lot of talk about fires, and it looks pretty disastrous. But even before this, don't know if you're aware of this job, and we had to replace, or the client had to replace all the glass. Reportedly cost them $20 million. That's Stefan there. Where are you, Stefan, doing your due diligence in measuring the glass there? This building had a canopy there for what, 2 or 3 years, one of the most expensive canopies. And nickel sulfide, something we've known for years. Ron Ballantyne discovered it back in 1950. And, in this era, we're still putting these things up. Don't want to talk about this too much, but that's become a big issue with the councils, and we had to develop new glare techniques to work out the issues with other buildings, not just road, pedestrians, and whatnot. Well, I think everyone knows these issues. Mold and condensation, 2 very different things, but go hand in hand. And again, we had to, get the WUFI program out and train and start modeling buildings. Early days of low-E, triple low-E coating, cladding issues. I could go on and on. All types of glass issues. Like I said, I could go on, and I will. I don't know if you're aware of this job, but again, speak to Stefan. I know I mentioned his name twice. Maybe he should be up here. Distortion issues, and if we had to measure roller wave distortion, and surprise, surprise, I think it meets the code. Not sure if a lot of people know the issues here, but this is where we learn definitions and limits and different things that work that's acceptable in different countries may not be acceptable here, and it was very costly to the fabricator. When the lacrosse fire happened, Peter Smithson took his uni book out and showed me this, and that's from Melbourne Uni, and you think, what's happened? Where is this book? Have we developed further? What do we consider? So facades, obviously, it's just not consulting. The way I look at it, we're more project managers. We look at risks, budgets, buildability, quality, safety, technical issues. We like to deal with technical issues, but we don't like to deal with contractual issues, right? Consideration, contract value, methods of payment. Variations, we are not really, we don't like to talk about money. Disputes, finishing, completion, handover. We don't close out jobs very well, in my opinion. And I looked at the glass industry over the last 25 years. And just looking at that, you'll see the explosion of manufacturers, float lines. I mean, in Australia, I think we've got 1 float line. Some companies in China have 10 float lines or more. Glass fabrication. So advancement in all types of glass. What am I trying to get at? Soft coat, advanced. online QA. I don't know if maybe I should talk to some glass people. Does it really work? But what am I trying to get at is the result is cheaper prices, more risk. Oops. There we go. So now we can look forward and what are we doing in the background? So we've come up with, sorry. So I'll just quickly go. We've got a glass lab, got a facade tracker, and a facade carbon calculator. We'll start with the glass lab. What do architects ask us most, and what do they focus on? It's usually the glass, and as consultants, they'll give us a call. I saw this building. I like the glass. I like blue, gray, silver, not so gray, neutral. Is that even a color? And then, can we have samples? And then once they like a sample, can we go see a building? I normally say, not in Australia, in France. Yes, lots of it. Just trying to get the trip. But that process, we thought, well, it's got to be better ways to do it. So I will get Lyndon out here, who is some of you may know her. She's an architect, but now become a web designer. And in a very short time. So we've come up with Glass Lab. Now I do encourage, if you got a phone, you can go and search. But it's Glass Lab. So glasslab.com.au and just Google that. I hope it works. This is live. This is not. Just click. Are you on it? Yeah. So I'll just quickly introduce. So the idea is like a search engine, right? But all glass suppliers got search engines. But this is a search engine. So what we try to get is to get all these glass suppliers, and we are focusing on Australian jobs, right? So we've got the glass lab, the glass database, and then we've got, just click that. So let's just search, let's just do the cladding first. So if you click on the cladding, now, caveat, we're not endorsing any products, that's not the idea, but it's a search engine. It's really targeted for architects. You go in there, you see a building or you see a product, you like it, you want to know if it's used in Australia, if it is, where it is. So you can search on, so it started as glass, but then we just went on and added cladding, and then so you can scroll and you got different products there. Glazing, you can select different materials, for example. Maybe change the GRC to. All right. Just go clear filter. I know I'm whispering, but they can hear me. So anyway, and then so that's cladding. We've even added glazing systems. Glazing systems, and so the idea is, we'll try and get as many suppliers as possible, focusing on Australian products, and obviously, if this goes, we can introduce it to other areas. You can search on system types, frame styles, and et cetera. And if you hover the cursor over the photo, you will see I think the system comes up. And then if you click suppliers, we got the suppliers here, and I do encourage the suppliers to come and join our platform. Click on consultants. Well, we hope to grow the consultant list, but right now, not sure why it's only BG&E there. Funny. And more. Before we do that, let's go to more. Let's go to what do you want to.
So with ideas that suppliers later on can
Yeah.
submit their product to us to be added to the database. And
What else?
I think this one is the fun one.
Yeah, I like
Eventually.
this. So if you're, if you want to know, you may have a question about glass. You don't know how, don't know who to talk to. Click on that. 1 hour free. Book now. So let's go to the reason why we started this, which was glass. Let's hope it works. We've obviously got a huge glass database, and we've dumped everything. It's a massive spreadsheet at the back there. So this is just what churns up.
Sample.
Yeah, you can request sample.
Oh, it opens up your Outlook to contact the supplier direct to request a sample. And you can filter.
And if you look at the categories, we've got coating types, location, color, glass sample. You can filter by solar heat gain, VLT, and whatnot. Maybe we'll just play a few things. So it should change immediately as you're moving around. And then if you see something you like, the contacts are all there. You can request sample, it goes into your Outlook, and you just write to them.
And if you hold on.
Yeah, if you hold that over there, the job will come up. Yeah. All right. I think that's good.
About it.
I think that's, yeah. All right,
People
thank
can
you.
play with it.
Yeah, you can play with it now. Not done yet. There's more. So that's something we're working on. Sorry, back to this. Yeah. The other thing that we've been working on for a while, and we kind of started before COVID, and then COVID happened. All got very quiet, and I'm picking it up again. It's a facade tracker, right? So why do we need it? And we've been working with VSS here. Anthony's down there, and he's I call him the sensor man. But we spend a lot of money on facade. We spend millions on facade, and we do a lot of upfront work. And once you test it, you put it on the building, and then we don't look at it anymore until there's a problem, right? So in summary, we've developed a bunch of sensors that we install on the facade that actually gives a building owner a good idea of how their facade's performing. And they can see the performance, they can see whether it meets specification, they can see whether it declines. That's a blurb of what I've just said. They can see issues with it. The idea is putting sensors and mullions in glass. We got a weather meter at the top of the buildings. That takes temperatures and monitor temperatures inside as well. These are just some of the things we can and have monitored. That's just another thing. We can add on, other things to the sensor. Anything we can. What are you saying? Anything we can measure, we can log it. Obviously, sensors are important. Needs to be resilient, self-calibrating, and Anthony's the sensor guy, so he tells me it works. Real-time visibility. So basically, it's real-time reporting. It comes up in your laptop, your app, on the phone. It goes onto a data logger, gets onto the cloud, and back down onto your device. I think the key in what we're trying to do here is real-time, right? That you get your performance of your facade. this is a real, this is an actual job, but it's an issue. We came, client couldn't solve it. We came down, we monitored the whole facade. This is what happens on this job every day. And the developers changed the internal finish, the carpets, everything, and they couldn't work out why it was happening. Architects arguing with a mechanical guy, whatnot, and we came and we measured it, and we worked out what the problem was. And you can actually see the condensation even happening on the glass, right? So this age effect actually is real. Couple of interesting facts is non-thermally broken. So, when you start measuring this, we worked out non-thermally broken frames gets pretty much to the same temperature as the outside ambient air temperature within about 2 hours. Thermally broken, you get about a 6-degree difference in about 5 hours. So you can see it really works. This is a non-coated IGU, and it was pretty much only 2 degrees difference. So coating does make a difference. That's a real reading on the side. And working on what we call the watchful eye, where it's like a traffic light system, right? So if something pops up red, means, so first thing you do when you wake up, you normally look at your phone before you say good morning to your significant other, and then you look and go, oh shit, red, right? So we got to do something about the facades, or specify. I think that's just an idea that we're toying with. And that's just how it works in a life cycle, and that's actually submitted for the patent as well. Facade carbon tool. So the last one I'm going to talk about is the facade carbon tool. And this, there's lots of carbon tools around, but this is purely on facades. And this is, a work in progress. It's not something it's ready. But it's a design tool, right? It's not a verification tool, so you can play with it. It'll give you numbers, carbon, not cost, not price, not cost, not buildability or whatever. It's purely targeted to carbon. And again, it's for architects to use, early design, upfront. It's meant to be simple. But why do we need it? So you pick the type, for example, you play with the parameters, and up there you can choose different materials, different frames and whatnot. And I've got a short video, and this is where I get Anne to come and talk about it. Oh, maybe. All right. Ready?
Hi.
There we go.
Hi. Yeah.
All right.
I don't really support the Britney Spears microphone. So you pretty much just go in there, you begin your design, you pick the type of wall you want, facade system you want, then you pick the type of panel you want, and then in there you can play with the measurements, you can play with all of the different sizes that you have. It just adjusts directly, and it's like of a 3D idea of what it's going to look like.
But look at
roughly.
that. That's the...
It all updates the carbon emissions at the bottom every time you change something. And in the next you pick the frame. So with it, is it timber? Is it aluminium? Is it recycled aluminium? Is it steel? You just pick the different frames you want, and then every time it updates the value live. And then, so every time it updates live, you go into the filling is more like the opaque areas of the facade. You pick what you want it to be, either aluminium, or glass, or obviously there's going to be a lot more options in there. And same for the glazing, you pick the glazing, double glazing, what brand. All is updated live, and there's going to be obviously a lot of different options in there. And then you pick also the type of window you want to have in there, and then you also have sun shading, whether it's internal or external, whether it's mechanical or manual. and vertical or screen, horizontal blade or screen. And then it goes into fabrication. So obviously that's where it's a question of where it's coming from, and take into account obviously the transportation. And then you've got the results at the end, and it gives you roughly a summary of what are the main elements that consume the most carbon in your tool. So I think if you go to the next slide. No. That would be the outcome of it. And then you can, so that will give you roughly where the main elements consuming carbon, a summary of them. And you can then export the data for you, get a report. And this is all live. You can save it. You can, have different projects in there. It's all going to be designed for your project and for you to play around, have a look, see what works and what different options you want to use and what are the best ones from a carbon point of view.
Thank you. So why is it useful, or why do we think we need it? I guess sustainability, and a lot of people talk about sustainability here, and we've got Green Star targets, and I think your federal and state government's committed to sustainability, so we're going to talk a lot more about it. And obviously, we all know this is Façade's a big contributor to a building. So my time's run out, but just thought I'd talk a little bit more about this. This is a job that we're doing now. You want a bit more about it? Talk to Stefan. Is he here? I keep talking about him, but is he here? And this is like maybe the QV1, where this takes buildings to the next level. I think there was a LinkedIn post by Multiplex that talked about it. 40% carbon reduction on materials, and the idea is. That's all PV cells there, or BIPV, dual phase, and you're looking at 20% of base energy from that. 550 Spencer, I think Scala. We've done a job with Scala, and that just looks like a normal glazed facade, and you wouldn't even know that building is cladded with PV cells. And these are just some of the jobs that we're doing. Just a range of very different facades now. Jagged, curved. That's a cold band. These are different materials, and obviously with the fires and energy and whatnot, we're looking at a lot more solid facades. So we have to deal with a lot more. I mean, I don't know how many times we talk about brick snaps and terracotta, this and that and whatnot, but there's a lot more materials. That's a GRC, a couple of old ones, circular sunshades. I guess this is North Quay in Brisbane, Shepparton Law Courts, and I'll end off with the Al Bayat Stadium in the Middle East. I don't know why I put that there, but that's. Thank you very much.
Thanks, Oliver. I think a lot of those horrors in the beginning of your presentation are a little all too familiar to a lot of us. To see those tools that you're creating is going to be really valuable. So I would like to bring up our next speaker, Imogen Lyons, Associate Director of WT Partnership, a carbon management lead, and she'll be doing her presentation on various facade systems and their impact to cost and carbon.
Hi, good morning. So my name's Imogen, and I'm a quantity surveyor. Thankfully, I work in Australia or Melbourne because I've never heard anyone say, forget cost, forget carbon. If they did, I don't think I'd have a job. Clicker. So the company I'm with is WT Partnership. We've been around for 75 years, cost management consultants, some people like to call us. We provide an independent view on a project with regards to its efficiencies, its costs, appropriate procurement methods. We work across all different sectors, and many of these sectors have facades, hence why I'm here today. We get involved in a project from the very, very, very early days. Usually once a client comes up with an idea, they'll start to look at how it fits with their profile, how much value they're going to get for it. And we start to establish some parameters around that. And then we work with them right through to the end of their project, all the way exploring things like life cycle cost replacement and those types of things. So what am I doing here today? Because I'm certainly not a facade expert. I'm going to give you a bit of perspective for what we actually do and our involvement, why we need to be involved and measure things, some of the drivers that we've discovered that influence cost and carbon, and look to some options. So a QS. Often when I tell people I'm a QS, they'll say to me, oh, you're a brick counter. We are. We do count bricks. But if you were to ask this budding little QS here how much this beautiful tower is going to cost, you might be surprised at some of the questions they come back at you with. They might ask you, where are the materials coming from? Are you aware that you'll pay a premium for a purple brick instead of a red brick? Who's going to be involved in building it? Can I invite some friends around? We'll have some ice cream, you know, like there's so many different variables that come into play. And so as part of costing a building or costing a facade, we need to look at things like the team, efficiencies, procurement methods and risk, because a lot of these things can be measured. We'll reference historic buildings, we'll go to the market, we'll speak to suppliers, and we'll often be able to put a fairly accurate figure on what you're trying to deliver. But one of the other really important things that we need to consider along the way is other perspectives. So I'm not sure if anyone's seen this cartoon picture over on the side here. I know I've seen it in quite a few presentations, but maybe that's because I often go to QS presentations. But perspective is really important. You can see here with just something like a simple swing, there's the desire to have the swing, and you're going to have your own idea of what it's going to look like. And then you'll ask a designer to get involved, and there'll be their own specific take on that swing. An engineer will make sure it's very, very strong. There'll be fire protections. And then eventually a builder will get involved and they'll build it. We, the QS, are top second one down just there. And very often the take is that we have budgeted it with not enough money. So just to give a little bit of context around where budgets come from, as I said, they're often driven by things like yield or return. What can we actually spend to make this a valuable product where it's going to fit in the market and where we know that whoever's building it, whoever's paying for it, is getting the most bang for their buck. So we have to weigh all those things up, all those different perspectives up. And then someone will say to us, but how much is it going to cost? And we will say to you, good question. And that is why we measure. So we brick count, but not just bricks. The parameters are set, and as the design evolves and develops, we explore what's being considered, the different options, and we look to put a price to it to understand if it's moving in the right direction so that when a builder gets on board, you can actually afford to pay for this thing. So once we do have a design finalised, we'll then work with a builder, work as part of the tendering process to make sure it's competitive, to make sure it gets procured reasonably and fairly, because ultimately that's what's going to drive a successful project delivery. But more recently, there's been a new focus. You'll have to exclude this slide. I got a bit excited when I saw PowerPoint could do this. And that new focus is carbon and sustainability. So I've been a QS for 17, 18 years now. And in the more recent years, we've been really looking at this because it's what the industry wants. There's quite a variety of different buildings out there that are already existing, and they're looking to change up their energy needs by going to all-electric solutions. So we're working with building owners to do things like that. We work as part of the consultant team to help achieve certifications like Green Star or Neighbours. But what I've been really focusing on as part of the company is this embodied carbon management piece. As I said, we measure, right? So we understand quantities and we understand how variables can move and fluctuate from different changes. And so given that we have this understanding of materials, it's really taking that process, and rather than applying a cost, we apply an emission factor. So we have to do that again right from strategic stage all the way through to exploring how this building is going to end up, where it's going to end. Can it be recycled, or is it just going to landfill? And as you can see, the different stages of carbon management very much tie in with the different stages of estimating. As the design evolves, we can see if the concrete's going to have more of a play versus the steel, or are we going to explore a timber solution? So what does that actually look like on paper? It looks like this. This is a conceptual stage estimate. What we would normally be talking about with our clients is how much it's going to cost them to look at these various different options. We will often receive a set of very indicative plans from an engineer or an architect, and we'll have to try and put a cost to those, which will be very high level, but it will help drive where the next stage of design can go to. And now we're also doing that with carbon. We look at the project all the way through, so along the way, depending on the materials you choose, you might need to replace them more often. You might expect that they'll have higher cleaning requirements or something like that. And so all of those different activities, all of those different additional materials that will come into play, they all need to be considered because they all cost money and they'll all have a carbon impact. So you can see here, I'm not sure, I imagine most of you have seen this embodied carbon graphic down the bottom here, but the blue is the emissions that come from when you first build a building, and the blue line on the cost graph is reflective of this is how much you're going to have to pay at the initial stage. But then we also have to look at this red in use and then the end of life, and that's how we can track both variables. So why is this only coming into play sort of like fairly recently? This is a great graphic that is from the Green Building Council Australia and Think Step ANZ. I've attended quite a few talks from them recently, and they've got a lot of great things to consider. But my take on it, and again, apologies, I got a bit excited with PowerPoint, is as the grid goes greener, as we have availability to more environmentally friendly forms of energy, our operational emissions are going to reduce, and so there'll be a heavier focus on the emissions that we are creating as part of the built form. So, now more specifically to facades. So I'm not a facade specialist in any way, shape or form, but if someone was to put you on a pedestal one day and say to you, I want you to forget everything you know about facades as you currently know them. And now what I want you to do is picture yourself on that pedestal, and I want you to put something around you that's going to be strong and stay there for a really long time. It cannot be combustible. It has to be beautiful or even iconic, because everyone's going to see it. You need to be able to keep it clean and well maintained. It needs to let in a lot of sunlight, but it also needs to afford privacy. And if you're standing inside of that box and you're banging drums, or I'm standing outside of the box and banging drums, I don't want to be able to hear you. So imagine you don't know anything about facades. What's this actually look like? Now let me throw in some more variables. It has to be cheap or cost effective, and it has to have as low environmental footprint as possible. So there are ways that you can make this unique structure efficient. And the opportunities to do this are quite broad. You can take a look at the overall footprint of a building. And for example, on this picture here versus this picture, they both afford that sort of indentation. It's letting in light. I'm sure that there's a variety of different reasons why footprints end up the way that they do. But on this first one, you're actually adding more facade area. On this one over here, it's not. So things like this are the things that we'll look at, and we'll ask the question to the design team, like, do we really need to do this? And if we do, great. But if we don't, well, can we look to value manage it or carbon manage it? There might be little tiny details that can change, things like the extrusions. I read an interesting article the other day, and it was saying that you can significantly reduce the weight or the volume of aluminium in a building just by exploring different mullion types or transom types. So I'm sure that engineers are looking at all of this, but this is what we'll also explore as part of that efficiency piece. The other thing with facades is they're so big, it's such an opportunity. So I know that there'll be people here today talking about solar facades. I think that's incredible, such interesting technology. But there's other ways as well that we can make use of this thing that we're building. So the bioreactor facade by Arup, I know it's been around for a while, but it's super interesting, creating energy, warming the building. And then this one here at the Brisbane the airport car park, Nedcarn and Urban Art Projects. It looks like a wave going across the surface of the building, and as it moves, it's creating kinetic energy. Really, really cool. So something like this, of course, it's going to cost a lot of money when you first put it on a building, but over time, as these innovations develop and become more available, which will make them more cost effective and more competitive, it's likely that this will start to pay off in the long run. So procurement, logistics and installation, it does have an impact in terms of cost and carbon. We probably see more of an impact from a cost point of view with different procurement options, but it also has an impact with carbon. So you can see here on this graph, anything via air has a big footprint, rail and shipping, not so much, and roads kind of like, you know, in the middle a bit. What's driving this? It's really just fuel usage and efficiencies. So with shipping, with rail, you can move a lot of stuff with one shipment. And so the fuel that gets used is spread across all of that. Aeroplanes are obviously much smaller and can't carry as much. So just to quickly touch on materials, I've only really put up here the most common ones that we typically see. The graph to the side here is for 1 cubic metre of material, and it's very, very indicative, right? Because obviously manufacturing, all of that, it all comes into play, but this is just to give a little bit of context, really. So steel, it is expensive. You don't need as much of it because it's strong. It has a fairly high emission, but again, you don't need quite as much, and it's likely to stand up for a long time. And in terms of weight, you can see it's a heavy material. Timber, bricks, they're pretty low in terms of a cubic metre. So again, when you start to explore various quantities or requirements, that can move significantly in terms of cost. But with your carbon, it's fairly low, and it's generally a lightweight material. Aluminium is one that we see has a very high emission factor. It's a lighter material, so it's very often used, but it can also be fairly expensive. In saying that, this doesn't consider, as I mentioned before, the grid going greener. We are starting to see newer materials hitting the market, like low carbon aluminium. So that will almost halve the emissions associated with this. And then glass, it can be expensive. It's considered to be an influencer in carbon. That's really driven by the quantum that's required of it generally. So we've been working with a few clients to understand their impacts. And one of those key clients has been Scape. They do student accommodation, and they're really driven to do better from an environmental perspective. We've looked at, they've got various towers around Australia, and we've looked at quite a few of those to compare them really and understand what their options are, what their baseline should be, and how various different specifications will influence what they're actually trying to do. So this is a real case study. There was a business as usual approach taken, which was from the basis of previous developments. There's a reference design, so that's actually the Green Star reference design, and then there was the actual project specification. So what we did with this, the design was already fairly well developed, so we were able to measure all the different variables, all the different materials, and help them understand which way they want to go moving forward. We measure cost and we measure carbon, so they're able to weigh that up and understand from a business perspective how much do they want to actually pay to reduce that carbon, and then they can also start to consider what the likely impact of their feasibility models is going to be when you start to consider things like offsetting. So these are just a few little snippets I've taken from some developments, just to kind of talk to the layers, I suppose. We've got just a typical precast facade. You don't see it very often because it's not that pretty. But from a cost perspective, very efficient. From a carbon perspective, also very efficient. You start to then see things like aluminium claddings being put on top of those, or as Oliver touched on before, rain screens. When you start to add these different layers, you're adding more material, you're adding cost, and so you're adding carbon as well. The third one across is just a glazed facade, very typical of what we would usually see. But when you start to actually look at the detail behind that glass, there's probably an aluminium backpan or something like that. And as I touched on before, aluminium has a high carbon footprint. So that will start to have an impact. And then things like sun shadings or fins, or sometimes they're just added on to make facades look really pretty. We recently had a project that it was a requirement from town planning that they add on things like fins. And despite the team telling them, well, it's going to have a big carbon impact, it was still a requirement. So I took those 3 little facade types and the fins, and I just did a very quick sort of back of the envelope calculation just to demonstrate the impacts for carbon and cost. So this is a square metre of the facade area, and you can see as you explore the different typologies and different ways of constructing, how much it's going to actually impact you. And then if you're a client, you can take this information and run with it, discuss the best way forward. Where do you want to put your money? What do you see your priority being, and what do you think is actually valuable? So yeah, that's sort of what we do. And we'll look forward to seeing where the industry goes with this new focus. Thank you.
I keep forgetting I can roam around, so I'm coming from the other side this time. The next, and just on Imogen's presentation, I think we all know that efficiencies and rationalisation will really help with that carbon reduction before we even get to any of the fancy products that are on the market. And I hope we all had a good think about that protective shell we would build if we weren't all facade engineers. So the next one we have up is from Dinesh, Kumar and Bill Segaert from Saint-Gobain Glass. Their presentation will be on moving towards carbon neutrality with the first low carbon glass.
Good morning, everyone. I'm Dinesh. I'm the head of the business at Saint-Gobain Glass International for take care of the Middle East operations and as well as the Australia and New Zealand. And I have with me Bill Segaert. He's our agent for the Australia and the New Zealand market as well. So normally there's a pointer. It's here. Thank you. So the world in the last few years, we all know we have had record-breaking heat waves across the world. We have devastating wildfires. We have witnessed even in here back in October 2023, here in Australia, the bushfires. Flooding and extreme rainfall. You've seen Typhoon Yagi a couple of weeks ago. Melting polar ice caps is disrupting ecosystems across the world. Oceanic changes you'd see happening in the Great Barrier Reef. And all of this means that we need to act today. We need to do things which are sustainable to the planet, and we need to do our bit. So Saint-Gobain, our purpose is making the world a better home. This is something that which we have taken up and as our purpose, and everything that we do it for this purpose. So a quick video on what we do at Saint-Gobain.
Build to make dreams come true. Build to provide shelter, to protect the ones you love. Transforming materials, shaping them, giving them form. Build with care. Build for the long term. Build for change. For over 3 centuries, Saint-Gobain Glass has been bringing extraordinary dreams to life, constantly innovating to offer the products you deserve for your project. Now present all around the world with 13 manufacturing sites and a strong international collaboration. Wherever you are, our experts work with you to facilitate the shift towards sustainable construction with glass solutions that deliver sustainability and performance. A solar and heat control range allowing the perfect combination of temperature and daylight. The world's first low-carbon glass with a verified environmental product declaration. A temporary surface protection on to-be-tempered coatings that eases its processing and increases productivity, reducing the environmental impact. A full range of exclusive solutions to meet the growing demand for bird-friendly glass and glazing. Saint-Gobain Glass supports you and your customers all throughout the project, even from the start when it's just a drawing. Our digital solutions help you find the right product and bring your dreams closer to reality. Dream, transform, impact. Saint-Gobain Glass cares about building better for people and the planet.
Yeah, that's a little bit about what we do at Saint-Gobain Glass. So one of the key things that we have taken about carbon neutrality as a core of our strategy is to set goals for ourselves. So we have set goals of how we are going to move from 2025 till 2050, which is nearly zero carbon emissions. In 2025, our goal is to reduce our carbon emissions in Scope 1 and Scope 2 basis 2010 by 20%. As we move into 2030, we have also taken into account the Scope 3 as well, and from 33% reduction in Scope 1 and Scope 2. And by 2050, we would like to be nearly zero carbon emissions. So here I'm going to talk a little bit about the embodied and the operational carbon, as most of you are very familiar, but typically looking at the building glass life cycle. So you have raw material extraction, the production of the flat glass, the glass processing, the construction per se, the utilization of the glass in the building, and then the end of life cycle. So you have carbon emissions happening across the life cycle of the building, of course, from the raw material till the end of life. So embodied carbon basically is happening at all these processes, starting with the raw material, production of the flat glass, processing glass, and the construction, and the end of life, which is highlighted in the green. Operational carbon is primarily what we see in the utilization of the glass in the building in terms of heating and cooling loads. So just before I move into the next slide, I have a question for all of you. I have in fact two questions. What percentage of buildings account for the total greenhouse gas emissions? Can anyone answer? Buildings in terms of the total greenhouse gas emissions that we see. Any guesses? It could be any wild guess. Buildings, only buildings have the total greenhouse gas emissions. Who's that? Excellent, very close. We will see that, excellent, very good. Okay, the second question. In the building life of the cycles, what would be the percentage between embodied carbon and operational carbon as we are today, let's say 2024, 2023? What do you think is the percentage split between, if 100% is embodied carbon plus operational carbon, what is operational carbon and embodied carbon? Anyone? Any guesses? Just rough. 50-50, okay. 50-50. So we will get there, but we are not there yet at 50-50. We will see that in the next slide. Okay, so 40%, you are really very close, it's 39%. 39% is the buildings account. So it's very important for us to look at the total carbon emissions because buildings account for almost 39%. And as of now, in terms of operational carbon, it accounts for about 72% of it, and embodied carbon is about only 28%. But we are, as you all know, working towards, in terms of products, we are working on operational carbon. We are having regulations all across in terms of the U value of the building, U value of the glass or the configuration, and also in terms of solar factor. So we are working on it, and hence we will see that the operational carbon will reduce significantly from 2020 to 2050, and it will get to 50-50 by 2050, and the embodied carbon will play a very crucial role. So it's very important that all of us as manufacturers work towards the embodied carbon, because that will become very critical for us to reduce it in the future. So embodied carbon of a building. Okay, we have done a study with Arup, and I'll go into those slides in the coming. We will look at it in a couple of minutes. But Façade accounts for, in terms of embodied carbon, only embodied carbon, Façade accounts for about 10 to 20%, right? So can anyone guess what would be the contribution of glass in this 10 to 20%? Any guesses? 30? Someone said 30? 30%. Okay, so let's see. So you are close, but somewhere very similar. So we've done a study with Arup Façades in 2022, and we looked at embodied carbon in several types of facades and glass contribution. So we looked at about 16 facade typologies and 18,000 design simulations. Okay, and this particular report is actually available on the Façades website of Sangoma Glass, and that report is downloadable, and it's available for everyone. And we looked at all the 16 contributions, okay, and then we looked at unitized systems, we looked at curtain walls, we looked at various which are prevalent in primarily in European and the United Kingdom, in the UK markets, okay, and glass accounts for about 24 to 60%. The one in red you see here is the contribution of embodied carbon in the total system, the facade system that you have. So it ranges from as low as 20%, 27% here, to as high as 60% in a double skin cavity curtain wall. So this is the kind of a study that we have done across, and it accounts for about 24 to 60% of the facade, which one of the gentlemen is it's 30%, so which is there, but it varies from 24 to 60. So if you look at glass as a contribution, it contributes from about 40% to as high as 60%. So 4 to 12% of the total, whereas if you look at only the facade, it's about 40% to 20% in terms of this. So hence, it's very important for us to work on the embodied carbon of the glass. It's very, very important for us. So from here, I would like Bill Segaert to explain to us as to what we are doing in that particular stream.
Thank you, Dinesh. So the mission for Saint-Gobain is to strongly decrease the carbon footprint while maintaining the same performance, the same aesthetics, and the same quality that we all enjoy with the Saint-Gobain glass substrates today, and doing so at an industrial scale. So we introduce ORAE. It's the world's first low-carbon glass, now made in Europe and India. So the name ORAE, it's derived from Horae, which in Greek mythology symbolizes the change of time and seasons. Saint-Gobain chose this name in belief that its new product is a genuine game changer, heralding a new era of sustainability and leading the market towards decarbonisation. So what is ORAE? How is it achieved? Okay, we see recycled content move from about 20% to up to 64% in recycled content, but while combining renewable electricity throughout the production process. This results in a CO2, it was 6.64 kilograms of CO2 per square metre. This is a 42% reduction on a 4 millimetre clear substrate. And again, while maintaining the same aesthetics, the same quality, and the same performance. So the offer for facades. We can now offer ORAE, the low embodied carbon substrate, with Coolite Extreme, which is the triple silver family of coatings within Saint-Gobain, and now also on the Coolite SKN, which is the double silver family of coatings. This is where we're providing excellent energy efficiency, reducing the operational carbon, with low embodied carbon substrate. It's where performance now meets sustainability. And in 2025, we see a service charter. It's a commitment to supply from Saint-Gobain. We will see 6 millimetre coated ORAE substrates, maximum lead times, of 2 months. We will see campaigns in Europe. So we will see in Avil 3 campaigns next year, in Ports 2 campaigns, and both Nice and Pisa 1 campaign each. and we will see repeat campaigns at Saint-Gobain India factory next year. So now for our part of the world. We see a deliverable supply chain capability for RAE, whether it is coated glass substrates, RAE coated glass substrates to our processing partners, or finished double glaze units capability out of our Saint-Gobain India factory. So for your project, where do you want it to go? We can deliver to China, we can deliver to Thailand, we can deliver to Malaysia, we can deliver to New Zealand, we can deliver to Australia. And so for the offer for the facade is available to meet your most demanding project specification. It's only limited by your own imagination. So what do we see? We see a reduction in carbon footprint emissions. We see on 4mm substrate, we see a 42% reduction in embodied carbon. On a 6mm triple silver substrate, we see 41% reduction in embodied carbon. In a standard triple silver DGU, we see a 38% reduction in embodied carbon. And in a complex triple glaze laminated triple silver DGU, 34%. So Saint-Gobain is delivering RAE projects successfully now in Europe. We are seeing fantastic project references in France, Sweden, Germany. We will see the first RAE projects to be delivered in India in Q1 of next year, internally within India. We have partnerships and commitments with some of the major stakeholders within our industry, some of the names and brands that you are familiar with here at the bottom of the slide. So to know more, please come and visit us at the booth outside to discuss how Saint-Gobain can help decarbonise your next project. Thank you.
Thank you.
Thanks, Dinesh and Bill. It's great to see Saint-Gobain pushing the boundaries, as always, with a high-quality, low-carbon glass, which will have a huge impact to the facade carbon footprint. So next up, we have Dr. Teodosio del Caño from Onyx Solar Energy, and he'll be talking about the energy-generating photovoltaic glass for building applications.
Hi, good morning all. I will go straight to the point, but the most important thing is that I want you to have two things clear from today. First of all, this is not about PV panels. This is about materials that can be used as a primary element within a building, generating energy by means of photovoltaics. A PV panel is not a building material, cannot be integrated anyhow in a building. Secondly, the most stupid thing to do is to put photovoltaics on a roof. And this is something that we all have in our heads, but it's the most stupid thing to do. If you just put a PV panel on a roof, what you are doing is wasting the building surface, and especially you are going to get the 80% of your production in summertime. So then you will have to go storage, spend huge amount of money in lithium batteries, or you will have to get into a management of energy that is meaningless in some countries due to the grid conditions. So what it should be clear is that we have an object that is a building, and this object is a baby, highly demanding, and he's demanding all the time, not milk, but he's demanding energy. Why don't we change our mind and we transform this building, instead of an energy demanding object, into an energy generator object in a beautiful manner, in such a way that we have a distributed energy source within the building. Another concept is that, okay, why shall we put photovoltaics on the roof? Let's think for a moment. If I do that, all production is in summertime. What happens if we are in the North Hemisphere and we put it on a façade? South façade. We are going to have a wonderful production in December, We are going to have a wonderful production in January. Maximum production is going to be March and October. What happens if we put in the east facade? We are going to generate energy in the morning. If we put it in the west facade, we are going to generate energy in the afternoon. This means that if I get my building and I put it in the north hemisphere, south facade, west, and east, I am going to have a slope of production that can be adapted to the daily needs of the building and the monthly needs of the building. So I have a perfect overlapping of my energy demand and my energy generation. And this is a clear concept. So since it's a real concept, wherever you as consultants, facade specialists, building owners, whatever, have clear that the most stupid thing to do is to put PV on the roof. Secondly, you cannot put PV panels on a facade because it's not a building material. You have to be crazy. It's like if you put just a monolithic glass with a vinyl as a rare sheet and you put it in a building. Wow. What about fire protection? What about waterproofing? What about mechanical resistance? And you go and you put it. You have to be crazy. We are talking about building material. A building material with the same passive properties of glass or any other type of cladding, but at the same time showing the property of generation energy. And this is very important because we are talking all of us about carbon neutral. Imagine that you are putting on your building something that will generate the energy that was used in its production in an energy payback time as short as 2-3 years. So from year 3, you are going to have a carbon neutral material. So it is more important, not only the return of investment, but the energy payback time. And also, this is nothing that is highly innovative, it's a technological age solution, whatever. Yeah, it's true, but it's really robust. We have been doing projects for the last 15 years. We have some building integrated solutions that we integrated in year 2009. And the added value is that per today, these solutions are beautiful. So at the end of the day, what you have to give to the client is something he needs in a holistic manner. Robust technology, aesthetical added value, and business case. And by building integrated photovoltaics, you can actually do that. So this was a brief introduction, and now we are going to go through buildings that we have carried out worldwide. So Onyx Solar is a proudly Spanish company. We are in the middle of nowhere, center of Spain, but we have carried projects in 400 projects worldwide. We have done projects in Bangladesh, Nigeria, Australia, the States. 50% of our turnover comes from US. We can produce 20,000 square meters of glass per year. And as we said, this is just glass technology. It's exactly the same thing as any other type of glass, but we laminated our glass with photovoltaic cells. So whatever you can do in glass can be done as PV glass. So again, it is not a PV panel, it's a glass, architectural glass, with all the added value of passive added value properties of glass, plus the active property of generating energy. In this sense, we can play with amorphous silicon technology when you want to have a really nice vision glass, or you can go to more efficiency solutions as crystalline technology. There you have glass of 4 meters. And what we do is a continuous innovation in the sense that we have developed products in short-term basis, fast track. We are leading the market because we spend almost 1.5 million euros in R&D for a small, medium enterprise. This is a crazy amount. And what we try to put is to put as many products as possible in the market. For instance, there you have a curtain steel glass. And let me tell you that this is PV. And if you see it installed, you will never tell that it's PV. As a clear example, we have white, we have curtain wall, we have gray, we have gold. And in photovoltaic applications, you can put it anywhere in the building. Curtain wall, scramble, rain screen system, ventilated facade, fins, skylights, canopies, walkable floors, any application. So here we see some projects. This is Miami Balenciaga store in Florida. This is a project in Mexico. This is a project in the States. This is a project Boston Logan Airport, fully integrated. All the glass that you see there is PV. This is a project, Meridian Capital, is a residential house, amorphous silicon solution. This is a combination of two technologies, opaque blue glass, photovoltaic, and amorphous silicon colored glass, transparent. This is Georgia project. This is the most sustainable office building right now in the world. This is typical modular construction. You can install 80 square meters. Just you assemble it in the warehouse. You just go with the crane straight to the building and you install it. It was done in collaboration with Elissa. The designer is Pelli Clark Pelli as an architect. This is another nice project that we carry out in Barcelona. All the glass that you see there is PV, really opaque for the slabs, then the vision glass. And this, what you see here, all the white glass that you see there is PV, is photovoltaic. This is an active facade. It's installed in the same way as a facade, and I trust me that if you are there, you would never tell that it's photovoltaic. This is the glass. Here on the left side, we have an efficiency there of something like 120 watts per square meter. These are over 12% of efficiency on a color material. And this is how it looks once installed. This project is in Israel, and it's a pretty nice project. Here, another example, how you can combine. Obviously, if I tell what is photovoltaic in this facade, you will say, obviously, where you have the cells. Yeah, this is a curtain wall system. This is almost 4 meter long glass. But the glass on the right side, that gray, is also photovoltaics. And it's fully integrated. There you have the picture, and this is Genentech project. This was done last year in Genentech campus in California. Projects can be done anywhere. This is the Stirling Bank project in Nigeria, Lagos. It was an awful building, white concrete facade, and we did a full envelope with blue glass. And the building looks really nice. Keep in mind that we have there installed 1 megawatt of energy, and the system is fully off-grid. In Nigeria, they have some issues with the grid, so they decided to do fully off-grid, and it's 1 megawatt of power installed all over the facade, none on the roof. This is a data center, and usually data centers are awful buildings, and this is a data center from H, which is one of the biggest promoters of data center in the world, in collaboration with Merlin, that is one of the biggest property owners in Spain. And we have there 5,000 glass pieces integrated all in the facade. Again, we are over 1 megawatt of power installed. This is another data center for the same joint venture in Barcelona, fully integrated. This is another project in Orlando Utility Commission. This is not really high-end, but we see a facade, and then we see a typical canopy that can be done with PV. It looks very, very nice. This is Acciona project. This is a project on a ventilated facade. This glass is over 3 meters long, and it's integrated in Madrid. This is a typical fin application. This was done in the University of Washington in Seattle. And think about it. We have a building, and we have to put fins in order to project shadows. But imagine that it's an element, that is architectural element, and you decide, okay, if I have to put a fin, why do I not make these fins that can generate energy? And this is done by amorphous silicon. This is, again, 4 meter long glass. We have the wires running on vertical all through the framing system, and it's fully integrated. So we have a fin that is providing a passive properties in terms of providing shading, but at the same time, we make it active, generating energy, to be used within the building. This is another alternative. This was done in DIWA, Dubai Electricity and Water Authority in Dubai. And you have there 500 pieces, 200 of them are totally unique with all the corporate colors of DIWA. And it's based on amorphous silicon technology, and also is a really nice integrated solution. Well, this is in Dubai, and this is the 5 tower. 5, as you know, is the biggest entertainment company in the world. They bought just Pacha, which was all these discos of Spain to have fun, and they bought it for 500 million euros. So they are providing right now a big entertainment resort in Dubai. And on the logo of the company is just a square. Half of the square, a triangle is white, the other is gray. So they are installing this glass all over a facade. These are 8+8 laminated glass, and again, it is photovoltaic. We are going to have something like 800 kilowatts installed in that facade. This is a project in Philippines, Video Bank, and this is a project that we are facing downtown New York. This is the 262 tower in the 5th Avenue, and we are going to install in all facade that solution that there. You can see the cells, but actually when it is fully integrated, since the front glass is made, it is, as it ages the glass, it will look really continuous and homogeneous. And we believe that we are also right now in a 40-45% of compilation in this project. So we are doing it in collaboration with Walini. This is very important because we are not dealing only with facades, but here we are in a skylight. This was a land market protected in the Bell Labs in New Jersey. The skylight was done in the 70s. It has waterproof issues, so they decided to change it, but it was mandatory to keep it exactly the same, preserving all the same aspect as before. This is the skylight before renovation, and after, it looks exactly the same. You just see a little junction box there. This is another example of projects that you can do. This is with Foster Partner, another skylight in amorphous silicon. This is a project of a canopy that can be integrated. This is in Nigeria, in Kenya, in Nairobi, AM Bank. This is the full renovation of the convention center in Edmonton. All the glass there is almost unique. This is a lit platinum McDonald's. This is in Disney World, Florida. So if you go there and you want to have something, you can go. This is a project in Canada, in Australia. This is a project for walkable floor, Foster Partners. And this is a project that we have carried out here in Australia. This is the Westmead Sydney project. It's a fully customized glass, a small project, 90 units, but it's unique in terms of color. It's 2.7 per 800 millimeters. The output is really nice. It's almost 12.5 watts per square meter. It contributes to the sustainability, but here what I want you to see is how good it's integrated with other materials that we have there. And this is the view. So we have some smashed golden color, and all the terracotta that you see there is photovoltaics. If you don't believe it, it is photovoltaics. And this is how the glass looks like. This is how it is integrated. And this is a video, so you can see really nice facade, looking awesome, really integrated. The visual aspect is great. You don't see the cells at all. And suddenly, we were talking about horror in facades. Now we see horror on roofs. This is how PV panels are, and this is how building integrated photovoltaics can look like. We can do projects worldwide because we meet all the standards worldwide. Market constraints means but the local regulations. Meet local regulations, you can do projects wherever. Thank you very much for your time, and welcome to Building Integrated Photovoltaics.
Thanks, Dr. Teodosio. I think that gives us a lot to think about, putting PV in our facades. So next up, not in our program, but we're going to have a quick presentation on the Society of Façade Engineers from Robert Buck from Arup.
Okay, so I'm here just to discuss about Society of Façade Engineers. Now, a lot of things happened in 2004, a lot of world impactful events. There was the catastrophic Boxing Day tsunami. There was the launch of Facebook. And on a slightly lighter note, there was the foundation of the SFE. Where's next? Excellent. So the foundation, the SFE was formed because there wasn't really a society that combined all the particular skills that a facade engineer has. And this, because I've only got a couple of minutes, this was the objectives that were part of the SFE. And part of it was about accreditation, part of it was about promoting facade engineering. But one of them was sharing ideas, sharing best practice, and doing the sort of things we're doing here today. So the SFE was formed in the UK, as I said, in 2004, but we started the SFE in New Zealand, in Australia, at the start of this year. And there's, if you want to find out more about us, come and find us later through the breaks. But the people that are here that are also part of the committee, we've got Kathryn, who's obviously promoting. We've got Elissa, myself, Nick, and Tom, who you'll probably find as you walk around. And actually, Tom looks as young as he looks in the photograph. Right, in terms of membership, there's 5 different grades, and it depends on your years of experience and your capability. And you can join as an affiliate, and everyone's available. Matt, even you can join. You don't have to be an engineer. So, but if you want to have some names after your letters after your name, you then have to go through a competency evaluation. But it's relatively simple to do. And the price, $308 for the year, and which compared to the normal SIBSI rates are significantly cheaper. So if you want to, if you enjoy today and you think that actually we should do this more than once every 2 years, and you are passionate about facades, and I presume you are, because otherwise you wouldn't be here. You spend a lot of your life thinking and doing facade engineering, and you want to learn about best practice. If you're towards the end of your career as well, and you want to mentor younger people coming through, then this is society for you. So please have a chat with us outside. We've got a little banner. There's a couple of IQ codes here. One, if you're really sold on the idea, you can join straight away on the left. If on the other hand, you're a bit undecided but want to know about events coming through, link the one on the right, because that will allow us to send things to you and in terms of events. Okay, thank you very much.
Thanks, Rob. The SFE is a great initiative and I really encourage everyone to get involved. So we're about to head to the networking break. Thanks, everybody. We can head to the break. Okay, so welcome to session 2. I hope the stragglers are coming in, but so we'll get started. So I'd like to introduce Elissa Stirling, Regional Manager of Victoria for Inhabit. She'll be presenting on the future of facade engineering and opinion.
Good morning, everyone. My name is Elissa Stirling and I'm the Victorian Regional Manager at Inhabit. And I'm also recently a founding member and Vice Chair of the ANZ Hub for the Society of Façade Engineering. I've been invited to speak with you today about what I believe the future of facade engineering might look like. There are a multitude of different ways I could have taken this topic, However, what I decided to focus on is recognition and skill and adequate training in our industry. Firstly, why do I love working in facade engineering? It's a discipline that brings together art and science. I love the complexities and daily challenges that are integral to the designing of facades. I enjoy working with interesting and emerging materials. Facades are iconic in their nature, and I get to work alongside some of the best architects and designers in our country. Now, although I've been working in facade engineering for 18 years, I'm not a facade engineer. I studied a double degree of architecture and construction management at university. Therefore, I'm not a qualified engineer. And I'm sure my architects friends here today would not appreciate me calling myself an architect, as I am not registered. Over my 18 years of working in facade engineering, I've had the opportunity for working for two of the best facade consulting engineering practices in the world, spreading my time in Melbourne, Sydney, and London, and have been mentored by some of the pioneers in the facade engineering field. Oops, sorry. Sorry, I'm having trouble with my slides. I now very proudly lead a 35-strong facades team here in Melbourne that have expertise across all areas of facade design, building physics, structural certification, detailing, quality control, remedial work, and connect with a network of experts across the world. And in terms of recognition, my studies and experience in the field of facade engineering has allowed me to achieve absolutely nothing. Now, don't worry, I'm not here. You don't need to get me tissues out. That's not why I'm sharing my story. I've always been interested in developing my knowledge and skills in the field of facade design and not having to sidestep my career to take the sake of qualification in an adjacent field. I did, however, attempt a while back to become registered as a building designer under the VBA so that I could sign off weatherproofing performance solutions as a registered building practitioner. I wrote the however many thousand-word report. I submitted information on the buildings I've worked on, provided evidence that my 2 degrees were of equal value as the diploma you require as a building designer, and provided my CV with experience. 4 months later, I got a rejection letter from the VBA stating that I had not passed their competency framework as I could not demonstrate I'd worked on a Class 1 building, nor had I produced a building permit submission. Now, this is not an attack on the building designer competency framework. I believe building designers are an important and vital role in our industry. I'm trying to highlight that other than structural engineering, we have a major gap in our industry in recognising the different skills and competencies required in the field of facade engineering. However, I did recently gain the following qualification. No, it's not a Master's of Science in Financial Economics, which is what Google will tell you. Oops. I've received member grade in the Society of Facade Engineering. To achieve this, you must be able to demonstrate competencies across facade design, material design, selection, facade building physics, construction, testing, quality control, facade structures and manufacturing. But unfortunately, this qualification is yet to be recognised widely within our country. But moving on from me, let's now look at our building construction industry. What are some of the big issues we are dealing with right now? Health risks and damage to property due to condensation. Systemic issues of water leaks and associated damage. The health and human safety and the financial fallout of the combustible cladding catastrophe. You'll notice there's a bit of repetition in today's presentations. The risk to human safety, the airtightness and our leaky building syndrome. Structural failure. No, this building is not located in Australia. It is located in Vietnam. But this incident occurred only 2 weeks ago. I'm showing you this not just because we all find it fascinating, and very troublesome. But my colleagues in Singapore were asked to price this project. The client came back and decided, based on our fee, he couldn't see the value in appointing a facade engineer on their project. He decided to proceed without one. Although thankfully we rarely see catastrophic failure of facades here in Australia, we have in the past, and the perception in the market of the value of a facade engineer varies, as currently you only require a structural engineer's input right at the end of the design phase, and in some states, there's no requirements at all. But we can solve all of these issues with competent individuals in the facade industry. There needs to be onus put on developers to create a team of competent professionals on their projects. So with our current industry engineering structure, how do I find someone to help me solve these problems that our facade industry is facing? Let's start by looking at the current fields of engineering in Australia and requirements for registered professionals to certify design. Aerospace, amusement rides, building services, civil, electrical, fire safety, mechanical, structural. Where is the facade engineering area of practice? How do we ensure the design of our facades meet minimum standards? And how can we ensure we have a minimum benchmark for facade design if we don't have a recognised area of practice? Let's bring economics into the discussion. Building facades cost between 15 to 40% of the overall construction cost, and the cost of maintenance of the facade can be in the range of 5 to 10 times the initial cost over the life of the building. We are talking about billions of dollars every year of new facades being built, yet we don't recognise facade engineering as an engineering area of practice or have any large amount of formal regulation in our industry. Why are we in this position? The complexities of facade design requires many skills to be able to design a holistic facade system. Structure, thermal performance, comfort, weatherproofing, airtightness, materials and carbon, durability, condensation, reflectivity, architecture, heritage, fire, acoustics, security, lighting, and more recently, integrated photovoltaics. It is probably the most complex element of the building. Rarely can a single person have the skills to deliver holistic facade design solutions, as the skills often come from different areas of education, and not all in engineering. While core engineering skills come from structural and mechanical engineering, many of the skills required to deliver facades solutions come from architecture, material science, and building physics. All this adds complexity to the term facade engineering. But to make this even more complex, as we know, engineers do not deliver facades in isolation. We are part of a bigger industry who are also challenged by skills and quality issues. To deliver a facade, there is a whole process to go through that includes developers, estimators, principal designers, main contractors, material and system manufacturers, specialist subcontractors and building surveyors, and there's many more. The level of skill in facade design is required by individuals in all of these fields who are tasked with decision-making, procurement, and quality control. We also need to make sure we are not just focused on the top end of town. We have the same systemic issues across Class 1 buildings that would benefit from skills, competency standards, and training opportunities. So how do we organise ourselves to bring meaningful change and improvement? To be honest, it feels impossible. Luckily, or unluckily, depending on how you look at it, we are not alone. Facade sectors across the globe are grappling with the same issues. Therefore, we can be guided by work already being done. The Joint Competence Initiative, the JCI, was established in the UK in response to the Building Safety Act, which was enforced in October 2023. It is considered the most significant change to health and safety legislation affecting the UK construction industry in the past 40 years. The JCI is an association of associations providing guidance and support to move forward industry standards and raise the bar higher, along with representatives of leading contractors, subcontractors, manufacturers, suppliers, and education providers. The JCI has written a white paper called Achieving Competence in the Building Envelope Sector. The paper provides a benchmark standard for relating to competencies for all individuals, both domestic and foreign, working for consultants, material and system manufacturers, and specialist subcontractors that operate and deal in the building envelope sector. It defines the scope of the building envelope sector from windows, cladding, bolt-on balconies and balustrades, roof and roof systems, steel frame systems, concrete facades, and many more. It also provides main contractors, principal designers, and developers with a means of measuring what good looks like. The building envelope sector was highlighted as one of 13 working groups set up by a larger piece of construction reform. At each of the 13 working groups will rely on a trade sector body to develop and lead the application of the competency frameworks. Each of the frameworks are created to develop and maintain the benchmark standard for the building envelope sector, provide appropriate training, interface with regulators to ensure laws and regulations relating to competence in the building envelope sector are proportionate and can be applied in a practical manner. The competency framework is set up in 6 departments: sales and estimating, design procurement, manufacturing, commercial, and site. Each department is assigned roles and functions so it is clear the competencies individuals must meet, with a phased approach to give the industry time to get up to speed. Competency levels, experience and qualifications are outlined for decision-making abilities, as well as capabilities and ongoing CPD hours to maintain and improve skill. Each department outlines suitable qualification to meet competencies. The paper suggests that training may be required for between 5,000 and 10,000 individuals, which in itself is a momentous task. But there is a refreshing quote from Dame Judith Hackett, the chair of the Independent Review of Building Regulations and Fire Safety, which was commissioned in the UK by the UK government following the Grenfell Tower fire. Her quote in response to this paper was, "By suggesting a phased approach, I think this white paper enables people to get started on the journey which, at the moment, just feels like a big hurdle that is all too difficult. I can see how your paper gets people from where they are today, i.e. not competent, to a position where they are competent in today's methods of building facades and roofing." So who are the industry leaders in the UK driving a building envelope trade sector body to develop and lead the application of the competency frameworks? Many of you sitting in this room are already represented. I note this list was published in April 2023, and others have likely to have joined. So where do we start here in Australia? I would love to see a similar body such as the Joint Competence Initiative established here for the building envelope sector. But something at this scale needs to come from the government with appropriate funding to achieve this scale of reform. In my opinion, we start with creating facade specialist technical committees, starting with areas of compliance that needs reform and recognition of competency. NCC Section B, structure with a focus of the unique skills to the facade industry. Section F, health and amenity with a focus on weatherproofing, condensation management. Section J, energy efficiency with a focus on thermal performance, air tightness and occupant comfort. And adding a 4th in materials and carbon reduction. Over the time, I would hope these facade specialist areas will grow. The specialist technical committees I could see being set up to include members from design professionals, industry experts, academia and training providers, regulators and authorities. We task them to connect us with relevant and like-minded organisations, develop competency frameworks, review registration requirements and develop skill recognition pathways, promote skills training and connect with training providers across design, manufacturing and installation, establish requirements for material and system suppliers to provide training to everyone they supply to, and represent the skill areas on standards and code committees. For this to be successful, we need to come together under a single body so that our industry has a central point to collaborate and thrive. This is why a number of individuals in the facade industry have come together to create the ANZ Hub for Society of Facade Engineering. Is the Society of Facade Engineering the body to achieve all this? I'm not sure. I hope so. It is only in its infancy here in Australia. However, it is at least a place to start to get everyone together. Here we can start the conversation on how to make meaningful improvements in our sector. However, it can't be done by engineers alone. We need to come together as a holistic facade industry. Every single one of you in this room can help. You might be able to provide support through specialist expertise, connect us with other societies where we overlap, sponsor pieces of work that specialist technical committees undertake, look at partnering as a training provider, request and fund training programs to help upskill your teams, or help us form meaningful regulation around competencies. We have some amazing groups and individuals right across our facade industry in design, manufacturing and construction. We need to organise ourselves to create a central framework to provide them with the recognition they deserve and build up the level of expertise in the facade industry to meet them at a standard that will benefit our industry and the society we serve. Thank you.
Thanks, Elissa. I can definitely identify with the challenges of having an architecture rather than engineering background. And congratulations on getting the membership level of accreditation for the SFE and also championing the recognition and accreditation of the facade engineering discipline in Australia. Next up, we have Candice Zhao, the project manager from NorthGlass Process Glass, and she'll be presenting on the aesthetics of architectural glass.
Hi, good day, everyone. Thanks, Zach. I'm so glad to be here to share our experience on glass processing. My name is Candice from NorthGlass, which is a company in China. Okay, the next one. Today, I'd like to share our technology on two topics: how to control the glass furnace and curved glass. Firstly, I want to show you a video shot in Hong Kong. This is Taikoo Place. Some buildings located in there, including the Red One building. We supply glass to the Red One building, both tower and podium glass. A client is satisfied with our quality, so we get more projects from this client. We can see from this video, there are some different furnace, glass furnace. The good furnace will make the glass, the building, more beautiful. In fact, our client always more concerned about glass furnace, especially for tower. This is Beijing Library. The glass is 15 meters high with limited IGU glass. The glass outer panel is 5 pieces of 15 millimeter laminated glass, and the inner panel is 2 pieces of 15 millimeter laminated glass. The glass total thickness is 135 millimeter. For such kind of big size and multi-glass, we all know it's difficult to control glass furnace. During building stage, we made a VMU glass. The middle one is from us. The left one and the right one are from other company. We can see the flatness was better, so we get the case finally. According to our experience, temporary stage is the most the key point to control glass furnace. Actually, we started as a temporary machine builder. We have capability to make the temporary machine. We have world-leading temporary technology. So our temporary machine was sold to all over the world, including Europe. Because of this background, we can customize glass machine for a real case. And here is our top series tempering furnace created by ourselves for Hong Kong project. And with this tempering furnace, we can control the glass furnace bore tolerance and roller wave tolerance better than ASTM and Yin standard. Actually, the cooling stage is most important to control glass furnace during tempering. Here is our new technology for tempering. When the glass moves forward, the quench, both top and bottom, will also move from left to right, like this. So it will make the wind on the glass surface is more uniform. The more uniform means good flatness. After tempering, firstly we will check the glass furnace to check the reflection indoor with the cross grid. We can see the reflection, the street is more better. Then we put glass outside and also check the reflection with real building. The good quality will be like the red one. The reflection is straight. We also have scanner to check the glass distortion and anisotropy on the tempering furnace. The top one is distortion scanner, the bottom one is anisotropy scanner. We bought the distortion Osprey 10 from America. The scanner can check all position of the whole panel. For example, with the traditional method, we can only get a total tolerance value from peak to valley for roller view, but with scanner, we can get more details between the peak to valley. After scanning, we will get a report with 3D image. It shows the glass distortion with different color. The green is acceptable. For anisotropy, we get the anisotropy scanner from Germany. The scanner can check the light anisotropy, cannot be found by naked eyes. It's more strict for us. And it can show the anisotropy as a value. This is anisotropy report with 3D image. We can adjust a temperature and heating time based on this report. In Japan, architects always like float glass because they think float glass has no distortion. For this, we did a test to compare the flatness between float glass and tempered glass. We put a cross grid and glass on the outside. The distance is 100 meters. The viewer stands in the middle, the 50 meters position, to check the reflection. These two glass are a single panel. Float glass, we can see there is distortion. We compare a single panel glass distortion between the float glass and tempered glass with zebra crossing. The reflection shows the tempered glass has better quality. After 10 years of development, tempering technology has been improved a lot. With good tempering technology, the heavy distortion on float glass can be improved with a good tempering technology. According to the scanner report, the tempered glass also has better quality. The left one is float glass with laminated. The right one is tempered glass with laminated. We can see the reflection. The tempered glass has better quality. We check the laminated glass transmission and the reflection. The tempered glass also has better quality. Market always has special request for curved glass. Architect also always like curved glass to make a special design, like small radius, big arc length, and 3D curved glass. And that's also what we are good at because we have world-leading tempering technology machine. We can customize tempering machine for rookies. Next, I'd like to share some project reference we have done. This is a special design project in Australia. This glass is larger size with concave and convex. The glass height is 7.5 meters. The glass width, arc length is 3.3 meters. The radius is only 1 meter. It's actually a half-circle glass. For such kind of small radius glass, the smoothing of curve is very important. We can see the curve is smoothing from the photo. The glass is made by our special design tempering machine. Actually, when we make the visual mockup, we can only do 4 meters high. Then we design and build a bigger one for this project. Finally, we can do the 8 meters glass as a real job size. This is a special design project in Washington, D.C., named M2050. The glass is laminated and insulated with coating, and all glass is concave. Yeah, this picture can clearly show the glass is concaved. In this job, we make a real size control sample. Every piece of the glass should be compared with the control sample by the owner to make sure the experience exactly same after installation. This project is in Shanghai. All glass is 4 meters long with laminated glass. It has a small radius. The radius is only 175 millimeter. It's a half-circle glass. Actually, we can do minimum radius is 100 millimeter radius. Right now, the glass is 6 millimeter thickness. All the glass is heat strengthened to avoid the thermal breakage. And this is a big arc length project in Shanghai, China. The top middle glass, the arc length is 15 meters. The radius is 18 meters. Because of the big radius, we made it with cold bending. This is a research center of Huawei in China. It has a special design called red bean because it looks like a bean. The out glass is 3D curve glass. We can see from this photo, the building from glass is convex. It's convex, but it's 3D curve glass. Yeah, we can see from this photo the back on the building. It has convex and concave glass, but all glass is 3D curve. Here's a photo after installation. The curve, we can see the curve is smoothing. It has a pretty wheel appearance. It's another photo after installation. Yes, because of the good accuracy of the curved glass, each panel can match well. This is another amazing design project designed by Zhao, the Oppo headquarters in Shenzhen, China. This project might be the largest double curved glass in the world, because the quantity is more than 40,000 square meters. This is Oppo headquarters VMU glass. Before a few days ago, the client came to our factory to check the VMU glass. We can see the glass every piece is different shape. All the glass is 3D curve. If you have a good idea, please contact us. Maybe we can build a new machine for your special design. Thank you.
Thanks for that, Candice. Some amazing glass projects there. I think all of us are keen on less distortion in glass, so great to see that you're working on that even more. The next presentation will be on adapting facades from heritage to high performance by Ed Daines, Director of Wilkinson Air.
Good morning. Yeah, okay, good. So when contemplating what sort of projects and what I might be talking about today, it's It's a very interesting time to be designing facades at the moment, just as the technology comes on board, as that previous talk was elaborating on, to create some really amazing advancements in glass and in facade technologies. We're asking so much more of our facades, both in terms of environmental demands, but also as part of that, increasingly working with existing buildings. So I'm going to run through today a few of our projects that we've done as a practice that go through and address some of those concerns and issues that arise from that. So 8 Bishopsgate on the left there is a recently completed tower in the City of London, effectively a brand new building that is incredibly environmentally friendly, despite being, and you may well spot it, a glass building. Battersea Power Station couldn't be more different. It's working with an existing heritage building in an entirely incredibly sensitive setting, and a number of very difficult challenges that had to reconcile environmental criteria and the sensitivities of the heritage facade and envelope. A slightly more experimental project that we did actually with Eckersley O'Callaghan, who are here today as well, Tom, at 63 Madison Avenue in New York. And then finally, if I have time and I don't overrun and that big intimidating clock down there doesn't start pinging at me, I'm going to briefly talk about what we've got hopefully coming to Melbourne on a street very near you, in fact, just further down Collins Street, hopefully in the coming months. So 8 Bishopsgate, London, first of all. It's a new 204-metre high commercial tower in the City of London. I'm going to try the little pointer, see if it... Cool, yeah. It's very close to being the world's first semi-detached skyscraper in some ways. The cluster of towers in the City of London is incredibly dense, and it sits just at its closest point some 3 metres away from 22 Bishopsgate, the tower next to it, which is quite a phenomenally small distance for such a tall tower. The reason that is happening in the City of London is that all the tall buildings are being corralled into a very dense cluster. The city is crisscrossed by a series of protected view corridors. Overlaid onto that, you have heritage protected areas, conservation areas, and so the actual spaces where you can put tall buildings is incredibly limited. The existing building on the site before we started the project, just about make out in the foreground, this little fellow there. And interestingly, considering we're now very much talking about retaining existing buildings, a decision was made early on that was, given that it was a site for tall buildings and was obsolete in a number of ways, that it needed to be replaced. The site was actually 2 buildings previously, 150 Leadenhall Street and 6 to 8 Bishopsgate, and as is usual in the City of London, it was a ridiculous-shaped site. It was right in a key view corridor. Those who know London knows that views of St Paul's, past St Paul's domes, etc., drive a lot of what gets built at height in the City of London. The view that was key for us was the view along Fleet Street. We could not build anything tall that would interfere with how the dome of St Paul's was perceived at the end of the street. This is reflected on a number of buildings in the area which have inclined facades as they all sort of lean back out of the way to try not to interfere with that historic view. We were keen to take a slightly different approach to that, so this sort of evolution of a series of set black blocks was what evolved for the design of the building. Put in within the cluster, each block would then start to relate to a different element of the city experience, be that the street level experience, which is still predominantly stone and opaque, getting it progressively lighter as it reached up towards the higher elements. So each block would become lighter, more glassy as it reached up towards the sky, finishing in a public viewing gallery at the top of the tower. And that developed into a series of articulations, so stone or recast stone at the bottom there to an express facade integrating external fins at the mid-level and a very light CCF or double skin facade at the highest level. And that image shows a little bit of what the intention was for how that responded to those different levels. It also incorporated, each of those blocks was actually cantilevered over the street to Bishopsgate to the western side, and that was partly because the site ownership line actually ran down the middle of the street, and so because we had to step back to stay out of the view, losing area, we had the ability to actually step out on the west and actually gain a little bit of area over the street without narrowing the public realm at the base, and creating quite a dynamic effect as a result. So the system selection, as I mentioned previously, we looked at a double skin, a CCF type system for this, working with Arup facade engineers. I feel I should name drop them as they're here. The criteria for these are all the sort of criteria you would expect. We're looking for quality of light, quality of views out, and all without compromising the environmental criteria. And increasingly as well, embodied carbon. It was very important to understand how putting a double skin facade on board was going to affect the embodied carbon content of the system. Also very pertinent, and this is something that I know that a lot of people have had experience here in Australia. There's a very strong perception issue. If you're in a building with a CCF facade, what happens when the blinds come down? Are you suddenly sealed in a box? You're on the 14th story, you've got an amazing view, the blinds come down, and you're stuck in a box. So big perception issues that come with that. So a lot of work was done on understanding just how the blinds would come down. Would they need to be fully closed? What would they look like when they were? And how often would that actually happen? And making sure that the blinds weren't flapping open and closed every time a cloud passed. Looking at the performance of the system, the implications of adding a double skin facade enabled us to reduce the target solar gain from 100 watts per meter squared, which is what the MEP systems at the time were based on, down to 50 watts per meter squared. And that had a number of benefits, not only in the operating cost, but actually meant that a lot of the kit that was inside the building could be downsized as well, further reducing the amount of emissions during operation, but also the embodied carbon, and there was a little bit of money to go into the bank as well. Good, that's working. This analysis was done by this is looking at comparing the two systems, the G value associated with a single skin system across the facade of the building, and then understanding that when you vary the G values of that, exactly how much glazing to solid would you be allowed to have on the various parts of the building to achieve that target solar gain of 50 watts per meter squared. And what this basically shows that for a single skin solution, we were looking at getting really quite low proportions of glazing at high levels, somewhere between 30 and 50%. So largely a very solid building, as you would intuitively expect to get solar gains and energy loads down to the levels you would want to be achieving. However, when you went to a double skin solution, which hopefully it'll do in a second, the mouse is pre-waggling, this isn't me. That G value can drop from 0.28 down to somewhere around 0.12, sorry. And you can immediately see the effect on the facades at the different levels that takes place. All of a sudden, certainly at low level, you're getting almost entirely the ability to entirely glaze the building, and even at the higher levels of the building, you're getting sort of 70%, 80%, that sort of level, even on the south facade, which by the time you designed in spandrel panels is effectively a fully glazed solution using a double skin strategy. Okay. This is a slide very easy to get bogged down on, but in short, we did a series of analysis of double skin and single skin, and I think everybody came out of this happy, probably except for the QS. So the double skin facade really did give a lot of advantages in terms of light penetration and environmental performance at the slight cost of cost, but that was again slightly offset by the quality of the product that we got and other elements such as the MEP in the building. A little bit about the embodied carbon. So we modeled a whole variety of different systems and analyzed where the embodied carbon sat. Again, many of these people in the room will know, but of course, aluminium is often the biggest enemy in this particular type of study. So going through the various systems, you can see but by far the largest component of embodied carbon is in the aluminium elements. It's in the frame. Second is then the glass, and then third is things like the external fins on the outside of the building. So the solution to this really, well, I'll come on to that, sorry. So comparing a single skin and closed cavity facade, even taking those all into account, the closed cavity facade still had a higher embodied carbon than the single skin facade, even assuming the external fins and all the rest of it. Again, not necessarily surprising, but given that aluminium was the biggest component, the answer here was to increase the size of the glass by simply going from putting the mullions at 1.5 meter centers to 3 meter centers. The level of embodied carbon within the system then dropped below what we were getting on the single skin solution. It used to be sacrosanct in the commercial world back when I was young, if you like, to have the mullions at 1.5 centers to allow the immediacy and the ease of fitting out the internal space. But the 3 meter mullion centers enabled us to get over the line here on the embodied carbon, as increasingly taken in the stride of people fitting out these buildings. The result of the tower, it's the UK's tallest BREEAM outstanding building. It's one of the most sustainable skyscrapers, certainly in the UK. Be careful not to spread the net much wider than that, but it has ended up as an incredibly efficient building. It's the tallest EPCA rated building in the UK. The environmental performance is 40% better than the current, I believe, building regulations, not just the building regulations when it was completed, and it's the tallest BREEAM UK outstanding development. It aligns with the UN sustainability goals and the REBA 2020 challenges in terms of sustainability as well. So it's been very successful in that regard. Getting the quality control right, mock-ups, and more mock-ups, all through the process, detailed mock-ups. This here in the factory of Schelderbau, testing all the possible options, glass, blinds, again, getting reassurance on the blinds, looking at different types of blinds, perforations, open, closed, making sure everybody was happy with it before it went into manufacture and came to site. Hoiking it up on a crane, seeing what it looks like when you look up at it. Fortunately, in Holland, they have very similar weather to the UK, so grey skies, you can assess it accurately. Something Melbourne's a bit familiar with. And the result, look, we're very pleased with the result. Certainly the flatness of the system is flat enough to shave in, I think. It's all the things that architects like. We're getting a lovely neutral tint, lovely flat glass. The quality of the light inside the building is fantastic. It's been very popular with tenants, most importantly. That always makes the client happy. The blinds haven't upset anyone that we know of. So it's all gone very well. A couple of images here taken in different lighting conditions, really sort of highlighting just how crisp and minimal that top block in particular ended up looking. The reflections are pretty smooth, not a whole lot of ripple there. So very happy with the result. And the overhanging cantilevers on Bishopsgate looking suitably dramatic. But I think most importantly, it's the environment and the quality of the experience inside the building that I think we're most pleased with. Those big glass panels and the quality of the light coming in. These are the CCF units. You can just about see the blinds actually retracted in this situation up to the top, as it is a typical London day. And the views out, you can really connect to all through the day. You probably spend more time in the office doing this sort of thing these days, don't you? And at night as well. You can't argue with the views. I mean, if you're in a tall building to get these views, the last thing you want to do is be behind a solid wall and have the blinds down. And we're pleased to say that the proof of the pudding is in its occupancy. There's, I think it's currently just over 90% let. It was built speculatively, went through COVID, went through that whole dilemma, is anybody ever going to come back to the office? And it is very well occupied and very popular. Although some of my colleagues will be recognized in that picture. That is actually a bunch of architects, but it is full of real people. A very different project, Battersea Power Station. Some of you may know this in London, huge power station. It's built in two halves, a game of two halves. In the 1930s, pre-war, it was very much a heroic industrial age building. In the 1955s, a second half was added, 2 more chimneys in an age of austerity when the money had run out in the UK, and glass roof lights were out in case they helped guide in the Luftwaffe. We very quickly mocked this up. Apologies, it's not the MCG. I was really hoping I could say with a straight face that the Sydney Opera House fitted inside the building, and it just doesn't quite, but it's close enough that I thought it was worthwhile putting up the comparison. It is an absolutely huge building. When it was done, I believe it was one of, if not the biggest brick building in the world. There's something like 7 million bricks included in the building. Half of them were falling out by the time that we got there. The architect that did the original building was this fella down in the bottom there, with a matching hairline to my own, Giles Gilbert Scott, famed perhaps most for his red telephone boxes in London and a variety of other buildings of often unpromising brief that he really brought a bit of Art Deco sort of pizzazz to. We, interestingly, were involved in the building in the bottom centre there, which is the Bodleian Library in Oxford, which he did in the early 1930s. And I think that was part of the reason that we went on to be involved in Battersea Power Station. So a little bit about what's going on inside. 1930s turbine hall, as I say, this was the age of heroic industry. So you can see that beautiful sculpture down at the bottom. Now, that's what you want in your factory. You don't do that anymore. It's such a shame. But even the control rooms with amazing glass Art Deco ceilings, real sort of, it's a power station, let's celebrate it. The photo in the top left shows the state it was in when we arrived. It had completely fallen into disrepair, been partly demolished, and was in a right mess. 1950s, post-austerity, a very different turbine hall on the other side of the building. The control room in the top right there, actually, in some ways I prefer, feels it wants to be filled with James Bond villains or something out of Return to the Forbidden Planet. Really fantastic space in a completely different way. But austerity Britain, no roof lights, all very solid and enclosed, etc. And the big boiler house in the middle, and this was what was left of it by the time we got there. There have been several attempts to convert this building. It was a protected heritage building. Nobody knew what to do with it. It had several years, several attempts, had been partially demolished as part of an attempt to turn it into a theme park, I believe, before that developer went bust. And so this is what we inherited it. It's in a bit of a state, to say the least. Open to the sky. What hadn't already collapsed, you can see the large wall on the left missing, and the one on the right propped up by steel. What already hadn't collapsed wasn't going to be far away. The master plan that finally got it underway was by Vignoli Architects, and it was the power station was to be the centerpiece of a large, quite dense residential-led master plan. And fundamentally, the economics of it is that that entire master plan is what pays for the work on the power station, and the iconography of the power station is what makes those residential units valuable. So that was the synergy of the master plan. We won the competition in 2012. The brief to put inside it, such a huge volume. It is basically a small town. The green elements there is a 3-story retail element that extends across the extent of the power station. There's a series of large event spaces above that, wrapped by residential, and a large office component at the top, which later on became the headquarters of Apple in Europe. The retail bit at the bottom is a bit the public can get into, so rather gallingly, we often have to hear that it's been turned into a shopping centre, but there is more to it than that. First issue was finding out what we were dealing with, and this really kind of appealed to my geeky side. I think this is the biggest, most detailed point cloud survey we've ever come across. Every time this got opened up into the office, the lights would dim, computers would crash. It was ludicrous. We had to buy the guy who was in charge of it a bigger computer just so he could use it. But it was just, I mean, it was just such a glorious thing. It was done in such detail, and it needed to be. You know, every single bolt, every single brick, every single beam needed to be justified as to what was going to be happened with it. Was it going to be chucked out? Was it going to be replaced? Was it going to be repaired? I love the fact that it's even picked up the fire exit sign down at the bottom there. But that proved to be an invaluable tool. So how do we grapple with the idea of how do we get the facades to work in this? How do we make this an environmentally performing building, knowing that we're going to have to take that element by element approach to assessing how we dealt with it? There was an overall strategy. We were going to aim for an environmentally friendly building, quite aside from the fact that we were reusing it. The office elements were going to be naturally ventilated. The retail elements, as far as possible, were going to be unconditioned, etc. And so there really was a strategy that approached each element use by use. So I'm not going to read through this list, don't worry, but the retail element is probably the most important one. The strategy to make that effectively an unconditioned space gave us a lot of freedom to deal with the heritage. So the 2 turbine halls I showed you earlier were part of that retail environment. It basically reflected the entire plans at the lower levels, and a lot of the main facades that were under danger to the north and the south where the main entrances into the buildings were. See if the pointer works. So these are the main entrance points here, in between the wash towers and the chimneys, represented on this plan by the little pink squares. So this basically sort of describes the environmental strategy there. So the main turbine halls, we made use of their volume to naturally ventilate the air out the top, draw fresh air in, and have a whole sort of natural ventilation or an augmented ventilation strategy across the building. And we were very keen right from the outset that in filling up the building with all these uses, you didn't lose a sense of the scale of the building. You didn't lose the opportunity to understand the volume that you were within, and that you had opportunities within the building to visually connect up to the chimneys, which were the main sort of identifying element of the building. So by doing this sort of strategy as well, that enabled us to do that. So the facades above the main entrance, again, this is the state that we're in when we arrived on site. Again, point cloud survey comes in, deal with every single element, get up close to it. Is it about to fall out? Does it need repairing? Can it be kept as it is? Does it need to be replaced? And the strategy that we evolved with this was as far as possible to leave that as is, replace the windows, nice new double glazed windows to look like the old ones. But generally speaking, because this was an unconditioned space, didn't need insulating, etc. So a lightweight bowstring truss structure just to keep the whole thing stable. It was so tall and so vulnerable that it would need stability, and do that in the lightest possible way. So we went back to our beautiful high-tech roots and designed a beautiful bowstring truss system. And that ended up looking like this, and we think complements the structure rather well. And there's existing sort of structural beams and everything still embedded in the facade there, all integrated into the system that resulted. And I think you still get the reading of the volume. And I love the opportunity to use the word palimpsest in polite conversation. You get this sort of reading of what the building was there before. So you get ruined stairs, you get old beams sticking out through the facade. So it's been tidied, it's been made safe, but it's still, as much as possible, the old ruin still left express, and the new additions left very clear. The turbine halls, Turbine Hall A, the 1930s one. Again, sorry state when we got there. how it is now. Quite a transformation. Again, you can see the roof lights at the top there, cleaned up from the previous image, and an inherent part of the ventilation strategy, and also those large black circles up there, smoke evacuation strategy, etc. But again, as far as possible, the structures and the fabric that was there previously left in touch. You can see the big old crane gantry at the end there, for example, has been pressed into service to suspend a little new pedestrian bridge that we designed. And just a close-up there of some of the restored fabric. 1950s, again, before, and how it looks today. Again, the gantry crane left there with our new little floating bandstand, as it's called, rather unfortunately sponsored by Adidas in that picture. Just to give you a sort of a snapshot example, this is a little control room overlooking the 1950s turbine hall as it was. And this is a snapshot of the process that we went through thousands and thousands of times over, literally looking at every single beam, every little junction, what can we keep, what needs to be replaced, element by element. And this is how it ended up. The residential around the edge was a far bigger challenge because it basically came into contact with the perimeter of the building to a far greater extent. Again, there was, this is a modern residential product. It still had to conform to the highest environmental standards, but it touched the existing facade to the greatest degree of all the elements. So quite a large exterior proportion of the facades and at a very visible level. So the image up there in the top left was one of those facades as it was. Again, in a bit of a sorry state, but also the key problem we had with that, obviously, was no windows. Let's just say it's frowned upon to put housing in with no windows to the outside world. So we had to cut additional holes in the facade. Now, you can imagine that was a fairly interesting conversation, that we're going to start chopping holes in this heritage-protected building. But we managed to persuade them that we could do that in a way that was going to be in keeping with the architecture of Gilbert Scott and would do right by the spirit of the building. And the image down in the bottom left there shows that same view, as close as I could match it, as it is today completed. Sourcing the bricks was very important. I mentioned before there were between 6 and 7 million bricks in there in the first instance. Over the course of the project, on this half of the building alone, we needed to provide another 1.3 million bricks. These are handmade bricks. We sourced the same company that had made the original bricks, a company in Gloucestershire, originally, I think, owned by a cousin of Winston Churchill. The amount of sort of connections and heritage things, and this is mind-boggling, and got them to work. They got very busy. But we think the result is remarkable. Blowing own trumpet, but nevertheless. This actually does contain new bricks and old bricks, and if you look closely, you can see the difference between the two. I don't think, honestly, if you were to go along today, you would be able to spot them. I think they've matched really nicely here. But these inserted windows are new double-glazed, low-E windows. They're as high environmental performance as possible. So these residential units are acting as you would expect a modern residential unit to act. Now, interestingly, where you do come into contact with the heritage facade on the inside, heritage trumped the need to put insulation in, strangely enough. So here, the analysis was a lot more about, are we going to get cold bridging? Are we going to get condensation? All those lovely problems we saw some rather horrific slides of before. And then making sure that overall, in each individual unit, the insulated values were compensated for elsewhere. But the importance of being connected to the original heritage within these units was seen as absolutely prime. A residential lobby there communicating the same. The office element at the top, fortunately, it's probably not the right word, but the facades on this were in such a state of collapse we could do these again. We wanted the offices to have a natural ventilation strategy. They were set around a central atrium that supported that. And when Apple were brought on board or came on board as a tenant, said, we'll take the lot, which is the sort of thing you like to hear, they were absolutely embraced that approach. They came with their Foster and Partners, who were doing the fit-out for Apple, just done the Cupertino job. Just goes to show that architects can play nicely together, but they also embraced that strategy and really went to town on it. So it can run as a fully naturally ventilated building. And those elevations have been entirely rebuilt. This is like George Washington's axe, isn't it? What's new, what's old. A lot of these are the old bricks because the one facade that was rickety was taken down and they were recycled into this, but they were rebuilt using the latest in MMC approaches. So big precast systems, craned into place in as big a chunks as we could manage. Otherwise, you'd have had bricklayers up there for so long, tying up crane time, etc. So this really is an entirely modern construction, masquerading as an old construction using the original bricks. Just a rare image inside there. Apple are very guarded about images you can use. This is inside the building, looking out through some of those windows where these atrium space is now cut to the facade. And it's a rather striking space in there. And then the final result from the outside. And we think it hangs together rather well. But it's been interesting just how much you can be flexible about how you approach what was culturally almost a sacred cow and very, very important as a heritage building to a lot of people in the UK. Not all buildings are that glamorous. This is poor thing, I feel like I'm condemning it, but this is a rather more, how do I describe it, ordinary example of a building, 63 Madison Avenue in New York. And this was a competition we did with Eckersley O'Callaghan called Second Skin. And this was understanding what do you do when you want to give a building like this new lease of life and you're not knocking it down. You know, the facade on this was shot. It wasn't working well, so we did a competition about how do you bring this back to life and make this, you know, a product that competes with a new build in the market, in demands of the current market. So our proposal here was for an adaptive net. So the idea of that was that it was a complete visual transformation with a very minimal intervention. So the aim was to reduce the carbon emissions, improve the energy performance, improve light penetration, improve connection to views, and basically improve the environment with a minimal external addition. And we analyzed the whole building square by square, window by window, for a series of all the sorts of criteria that would be important for the occupants of the building. So solar radiation throughout the year, the amount of sunlight that got in, how much wind was fitting the various parts of the facade, what was the air quality of that particular facade, more polluted closer to the traffic, less polluted as you got to high level, as you'd expect. Noise, fairly closely tracking air quality for the same reasons. Wellness, a little bit of a sort of an abstract quality, but where do you get views out? Where are the good quality views? Do you get a good view of the park, a view of the water from that sort of situation? And mapping those across the facade of the building. And then developing a system that then responded to that as a lightweight series of components that could be attached to the existing structure of the building. Within that grid then would be a series of components that responded to that. So you'd have a light shelf if you needed to get more light in. You'd have a brise soleil if you wanted to keep heat out. And you'd vary that depending on where on the building it is and where all those things would be deployed across the facade. The facade, as I say itself, was a very light tensile net of cables supported off the building's primary frame. And the idea of also because it was a buffer, it also enabled us to address the inner skin and introduce ventilation panels and relook at the facade there as well, introduce more transparency and deal with the existing facade fabric on the building as well. There's also a wellness component to that. By creating this second layer, we create this interstitial zone that could be occupied, creating new terraces, breakout spaces, Juliet balconies, or just small spaces you can get out there in amongst the planting. Close-up detail here of the facades. As I say, we're able to introduce more glazing to that building, improve views, improve light quality, improve the interior experience. Even the planting program was varied according to the, I guess, the ecosystem or the environment that would occur on each individual part of the building. And the result, I think, was it was kind of a conceptual framework that you could apply almost to any building. This was a competition, and it was a winning competition. Unfortunately, it was completed in 2020. No prizes for remembering what else happened in 2020. So as of yet, this hasn't actually moved forward. But we thought this was a really interesting framework and quite a fun, sort of jazzy way of bringing new life to an ordinary building with a minimal impact. And then just finally, as I can see the intimidating clock slowly changing color, I think in the film industry they call this a teaser. So we're hoping that we're going to be able to take some of these lessons through to a new building. We're looking at down at 600 Collins. Here we're doing a 180-meter high tower for Hines, and with our lovely colleagues Architectus, who were here earlier, so I have to say they're excellent colleagues and incredibly good looking. I don't know if they're still in the audience. But Hines have very strong environmental aspirations for this building, state-of-the-art amenities, Neighbours Green Star, Neighbours 6-star, Green Star 6-star, that's a lot of stars in a sentence, Platinum Well, an all-electric building. So very high aspirations for the type of product this is going to be. Very simple plan enabling an environmental diagram of a largely solid north-facing elevation, and a light, clear, open south elevation facing all of the beautiful views towards the water. We're hopeful that the northern elevation will include an element of BIPV within it as well. I'm not going to mention the products because I know several of you are here today, so I'm going to gloss over that. A sort of a low-level elevation facade entrance that reflects a sort of, there's a new laneway included, reflects the tighter grain and the gritty character of Melbourne Street, but giving a large, active, generous lobby onto Collins Street as well, reflective of the address. And the north-facing facade that faces the water, getting a really open glass, articulated facade language that puts something with identity on the skyline and really makes the most of the most amazing views you're going to get out across the bay. So to wrap up, I'm reasonably well for time. Well, carbon is king at the moment. We're all talking about carbon. And in a low-carbon world, retention is not always appropriate, but we rarely have a blank slate. There's no reason why you have to hide from the light. Clearly, environmental is still king. Environment is still king inside and out. But lightweight glass, crisp facades are still possible and compatible, albeit getting harder and harder and pushing the technology more, are compatible with environmental aims. We strongly believe that there remains room and, in fact, a need for expressive and playful facades. In all this seriousness about combating climate change, there still needs to be room for buildings with identity and character. Working with existing fabric means character, not compromise. I think that's definitely a part that as designers we are embracing more and more, and we are finding that the buildings that integrate existing fabric into them are often more desirable to tenants, give more value to clients, not less. And it's always worth working with the unremarkable. This scheme here is a scheme we did in Gresham Street, again in London. The 1980s building on the left, not terrible, nothing special, given just an easy new lease of life, new performance, new environment on the right there. Well, the unfashionable, this is going back a few years. This is Empress State Building out in West London. In some ways quite a nasty 1960s building. Again, giving a new extension to the top, new facades, new environmental performance, all within existing constraints such as low floor-to-floor heights and fully let on completion. And when working with old buildings, respect the old, but don't be afraid of change. I think this is going to become increasingly relevant. It's certainly becoming more of the conversation here in Australia. I'm acutely aware of that. Working with the existing buildings, taking a flexible approach to that, and I think great things are possible. Okay, thank you very much.
Thanks, Ed. What an amazing set of projects and such a beautiful outcome on the Battersea Power Station. It looks like a facade engineer's dream, but I'm sure those heritage elements wouldn't have been out without their challenges. But what an amazing outcome. So up next, we have a panel discussion on Seafarers, conceptualizing, designing, fabricating, and installing the facade. And I'll introduce Oliver Ung to the stage, the moderator for the panel.
I think while we're waiting for this to be set up, we've got Gabriel from Rivoli as the developer, Falk from Fenders as the architect, Nicholas from Icon representing the facade, and Matt from BG&E Facades. That was in Melbourne, but we've kicked him off to Brisbane, but we dragged him back here for this. So thank you very much for coming. I thought it'd be good to talk about the Seafarers project because it's been going on for a while, and it's now probably, if you drive past it, you can see the facade coming up. It's quite a striking facade. Looks really good. I'm not saying that because on the job, but it does. And we've got the developer here, and it'd be nice to get a context from Gabriel on the challenges, all the things you had to do before we got on board. Obviously, when BG&E got on board, the facade's pretty much designed. It was the question of how do we detail it, how do we make it better, how do we make it constructible, how do we tick all the boxes. So maybe I'll start with Gabriel. Sorry, also just go back to the introduction. Gabriel is an architect with an architect. Falk's obviously an architect. Matt's an architect. I'm an architect. So Nicholas, you're
outnumbered.
You're on your own. Mechanical engineer, so you can see the varied, like Elissa was talking about, the varied disciplines that require to put a facade together. So Gabriel, striking facade, very interesting. Maybe give us a history on how it came about and how many years in planning.
Yeah. Well, the planning process has been a very lengthy period for us. So I'll give a bit of this juicy story, how we first started, right? When we first got on board, we already got a commercial scheme with a permit, and we bought off the land from the state government as a leasehold. So that was back in 2012. And when we first activated the project, we went through a bit of a land holding conversion from leasehold to freehold. So as we went through that process, I think we were pretty clear about the three key drivers for the site. One, we acknowledge that given the planning controls or the constraints on site that we are dealing with, we have a heritage shape, and we understand that as such, the urban design response would have to be in this tripartite format, whereby you would need to have a shed, you will need to have your podium, and you need to have your tower. That's one of the first driver. The second driver is probably seeing the opportunity, given the location of the site, that we've got probably 100 meters to the north of us of Orangery Way separating the site, and we've got Yarra River to the south. And what that presents is it allows us to design a building that you'll be able to see in the round. And suppose the third driver being, by the time we're ready to develop, a lot of the sites around us has already been built out. And it was always been known for the site as the missing link. So it was really important for us that whatever building outcome that we are developing, we need to make sure that it becomes an attractor, and also it creates this Guggenheim effect, whereby it's going to bring and link what's already being built around us. So I'll just show a couple of slides. So for those who have known, this is the end result. So it's a 19-story building, one-level basement, made out of two main key components. One being the a five-star hotel, One Hotel, which is an American brand, one of the world's most sustainable leading hotel brand. We've got 277 keys of the hotel, which is predominantly made up from ground floor up to level 10. And from level 10 onwards, we've got 114 of branded residents that stacks on top of it. Just going through some of the historical journey that we've been through. So when it first started, it was a scheme that we've got from Cox Architects, which was for a commercial building. Pretty simple building form, but what it informs us at that juncture of time is we understand that the building shape or the build form would have to create this so-called boomerang effect in terms of how the floor plate sort of skewed around to allow for some breathing space for the shed. As all development does, we'll go through the highest and best use. We started to explore the use of residential, two separate towers, whether residential on one side, hotel on the other. When FKA got brought on board in 2015, the first concept that they presented to us, I think it sort of reminds us of Guggenheim. So it's very sculptural. Obviously, that's not the most, we're not building a museum, so we can't do this. And effectively, throughout the 2 years, from 2015 through 2017, our first scheme that came about was really a curvy, wavy building that sort of like being stacked on top of each other. And that's really been inspired by the movement and the form of the river. Funny story being, we went through the process, got the support from Heritage Victoria. Unfortunately, it didn't really quite gel with DWOP at that period of time, and also with our local council. And since then, we've gone back to the drawing board in 2017 and started to relook at the scheme. That's when Nonda got brought on board and he started to look at something a bit more defined. And during that juncture of time, it was really important for us to understand that if you wanted a hotel and a residence, how do you actually delineate the build form so you can actually identify the use. So as such, some of the key moves that we did was, I think, at that juncture of time, Riverly pretty much understands that we want the hotel to be on the lower portion and we want the residential to be on top. And one of our briefs to the architects is we want to create a lot more corners, really trying to maximize the view line and the vistas, which is pretty much what then helps to inform and sculpt the build form. You see multiple iterations there. The last scheme that we've got here back in 2018, we've got our permit. Our first permit, there's still a lot of condition precedents that we needed to satisfy. Some of the key things that we were aspiring back then was there's a heritage crane. Everyone wanted to paint it like a bright burnt orange. Unfortunately, there is a process with heritage that you have to go through with paint scraping and all that, and we eventually ended up with its original paint color. And some other slides. These slides here, the design and evolution, it really speaks about, that's when we've got our hotel operator brought on board. And our hotel operator, through some consultations and all that, there's a condition of heritage permit where it requires us to deal with this conservatory, which was at the gable end of the shed, across this junction here. So there's multiple ideas that we started to carve, and eventually we ended up with something which is a lot more simplified. Again, optimization that we went through, all these ideas of exhaust character. This is the northern facade that we have, but one of the key drivers, right, as we developed the building, you always ended up with a huge envelope, and you started to need to realize, like, do you actually need this space? So the end result is we started carving off the facade where there are space that is nice to have, but not meaningful. Given the podium level, the depth of the floor plate is probably, I can't remember, probably 40 meters deep. And it means that we needed to create an atrium to the northern facade. So as such, right, from an efficiency perspective, trying to optimize the use of the floor plate, we managed to carve off the facade at the front to make it a lot more dynamic. That's it.
No, that's that's great. Maybe Falk, you want to add on to
Yes.
when you got involved and how you took that forward?
Thanks so much for inviting us here. It's such an amazing project, and as you heard from Gabriel, it's a very lengthy process. You have been involved for 10 years, so our office has been now since 2017, so which is 7 years. These projects, they do need the time to come to life, and since we can see now actually the scale coming up and the facades coming up, it's quite an exciting project we're very proud of. I might just to explain a bit I have to step back a bit as well, just to explain how our facade actually came about. There's possibly our two key drivers from our side is that the location itself is sort of is the nature of an island, and which is very unique for Melbourne. This is all the buildings from the city along the north bank. They stop at the pedestrian bridge there, and then this is sort of an isolated shed, which is the last one before the Charles Grimms Bridge. And it will be experienced from from pretty much all sides, and it's very unlikely that it will be built out. There's sort of a bit of dynamism happening here as well, is that everyone who will experience this building is likely to be in motion. There's the Wurundjeri way with cars coming around the long side of the facade itself to the north, but then go over the bridge, and it's sort of while driving around, the building just appears from a very long facade, and then it just changes to a very short one because it's an unusual long shape. Then there is the bike path to the northern side between the Yara and the shed, and then there's pedestrians. And then there's people in movement on the other side as well, on the southern bank, which they're stationary, but there's some F&B offerings. So that building is always experienced as a freestanding building, and which is a great offering, and it's doesn't happen too often. And then there's sort of another key point as well, that when Rivoli already had the permit when we got involved, and it was a permit for a commercial building, and commercial floor plates are slightly larger. And now the change in brief was to go to residential and hotel, which then we just reduced slightly the footprint. It has to do with, obviously, with light offerings for the different usages, which then gave us a bit of leverage to sculpture the facade and not just having a flat facade. What happens very often now is that if you build on sites, and especially in that economic environment, is that we are forced to maximize yields, and you end up with very flat facades, and quite often they only can be dealt with putting super graphics to the facade itself to make it interesting or give the building some identity. So these are all key points, which is always a great start to start with this building here. The footprint itself of the buildings or the floor plans are actually much simpler than what the building reads when you actually experience it. It's actually quite clear that there's 4 different layers, as Gabriel mentioned. Is that you have the retained shed itself, then there is setback layer to give some breathing space there, and then there's some levels of hotel, and then upper levels of accommodation. So these are then just a change in floor plans through the buildings has been to achieve these 2 large shapes which are interlock. This is then those 2 levels where they interlock, so we have two different usages on the same floor. There's level 9 and 10, and then it's just changing it over up the upper levels to its own single use of apartments. And as you can see, it's just the building is becoming narrower and narrower to the top itself. This is possibly, I don't know, maybe a month old. The buildings, the facade was still not all the way up there. But what actually can be explained quite well, how we have these 2 main shapes for the different usages. Then there is these 2 levels where they sort of describe an interlocking of the 2 shapes, and have these 2 different facade approaches. Now, the zigzag facade is possibly the dominant reference is the movement of Wardle, which we'll show right next to Yara, and it as well introduces reflective glazing from the surrounding buildings and from docklands, and then bringing that over to our side and over the heritage shed. I just put this photo in there. It was never intended to be seen from that perspective, but we just finished a building live on corner of Flinders and Spencer, built to rent, and we just had a site visit there. And Gabriel mentioned that some people ask him, it looks a bit like a ship. And I thought when we saw it actually from that perspective, it really does, like it's a container ship or like a cruise ships coming in and sitting there. So I thought it was an interesting perspective. What it just tells us, it is actually quite, the shed is 120 meter. The building over is 110 or so, and it is quite long facades we have to deal with here. And that type of breakup and the type of zigzag and the type of repetition, at one stage it plays with the repetition of the shed itself, which it's a very strong grid. But however, we put this new layer onto it and above there and bring the materiality from docklands over the shed. So we think it's quite successful. And as I said before, because of the movements around, they will be read very, very differently from any angle. Generally, at FFK, we're trying to bring as much as possible these sculpture work in here and into our buildings. And examples like this Eureka Tower or 108 is where you can actually sometimes use it as an orientation from, it doesn't matter where you come in from the city, because you know that the buildings appear differently, that you sort of know where you're arriving from. Gabriel mentioned it already, there was a bit of carving out of the main facade itself, which creates some interest and points down certain entry areas. We're not talking too much about the program within the building itself, because it's more about facades. But as you can see, it's quite respectful the way how we deal with the shed itself. It just keeps this, the short front of the heritage shed, which that's the right-hand side image is the arrival from the city. That's how people will experience it if you arrive, and the other carving out, just as Gabriel mentioned, that was for economical reasons and to create some more landscape space externally. Just a very pragmatic point now. So once the design was locked in, everyone was happy. You break it then up into different facade types, and you sort of work yourself through how actually each of these facades can be built. It's possibly we just want to mention two of those, which are the most interesting one, and that's possibly what we call FTO2, which is the one for the hotel itself. Technically, it's very simple. You might not agree. The idea is very simple, is that you have just two different panel type, curtain wall types, and they just, if you put curtain walls on a slab edge, they obviously are perpendicular, but if you now take each of these panels and you slightly skew them, then you get this effect of the zigzagging. And the easiest way how to build this is by having the projections of these single panels. You're actually not doing it in the stack joint, you actually do this within the panel itself. So you'd still deal the stack joints arm as a conventional stack joint, but it's the profiled version of these panels actually done within these panels. And then to create the depth of it is that is actually that there's two mullions behind each other to deepen one side of the panel. This is just when it starts then. All right, so some of them have windows in there, some of them openings, and each of the panels then have slightly differences, and then when we come into this fair where it's not that typical anymore, so okay, and let's just create more panels for non-typical ones, and it goes very quickly that you have many of those, but the main idea was always very simple, and it just gets then challenging if you come to these very sharp corners, and it's not just 45-degree corners. We try to create interest, and exactly what we were saying before is that the experience around the building it's very different from each angle. I personally think I've been 20 years in a business without a 3D CAD system. 15 years, 20 years ago, we would not have been able to do this. It is now, everything is just modeled in 3D. There's incredibly capable people now involved in to make these facades happening. At the forefront is Icon with an incredible dedicated team. And then there is the shop drawers from overseas who have incredibly helped to test actually out these junctions of single panels, and it was very helpful to actually have a detailed understanding of each of these junctions. It was always the idea that you read the function externally, as Gabriel mentioned before, and that you can see internally as well, is that the slides queuing is readable from the inside, which is great. And as you can see as well, is that this has to be handled then with a very adventurous concrete profile edges, which then takes each of these panels single-wise, so each panel had their own skewed zigzagging in there. These are the facades internally for the hotel room. So each hotel room would have 3 of those panels. And with the, it's just an example how actually with the shop drawers has helped to actually understand these corners, which very often we start to struggle to model, which means if you start struggle to model, they will have problems to build it. And then there is the other one, which is a bit more straightforward. That's the larger zigzags up at the top. For the residential ones, which is a more like a standard curtain wall system. However, it creates these in and outs every second level, and it creates a lot of roofs and sophites, which then need to be treated thermally and from a waterproofing point. It was a bit of a challenge. This is just one of those shapes, which again was helped with the 3D breakup. And then possibly one other facade to mention is on ground floor. Gabriel mentioned it's not the most amazing adjacent surrounding a building can have. So we tried to build a separation there. Then the zigzag form comes in again, but this time it's actually rotated. And this is made of galvanized grating. And so these gratings have planter boxes behind, and once all finished, that will hopefully turn in the next months or years, will turn into a large screen wall, which has been designed together with Oculus. I might just, if it's getting a bit more technical, but this is sort of gives you obviously a good idea how we came about.
Yeah, well, one of the interesting things about this is when we got involved, it was, I think we had one meeting and then we went into lockdown. So, for the next 3 years, we did it all online. I think I met Gabriel once. And
Just to add to the complexity of what the guys is dealing with, right? One additional layer of complexity that we've added to the project being the facade access component. You can see that the complexity of the build form and all that is it's not like you can have your BMS system drop down and clean the facade. It's like how would you manage the facade? And the complexity that we added is we traditionally a lot of time when people do facade access, one of the key things that they will want to do is we would need the residents to grant us access through their apartments in order to come out to the terraces to clean the facade. So that's one thing that we really make sure that we make a very clear point that is not possible. Facade access solutions will need to be on the basis that that entry to a residential apartment is not permitted. So that just added to that additional layer of complexity that probably people wouldn't be able to appreciate from just looking at this.
And that's right from the start as well. So before we go into the VMU, obviously, I'd like to know a lot about how Icon got about procuring the facades as well, because when you look at it, you go, it's expensive, isn't it?
Yeah, sure.
Complicated, but maybe start from when you were tendering the job and now you got the job, and then who are you looking at? How are you getting prices and whatnot, and then into delivery?
So I think the first thing to understand is the way Icon manage the facade is a direct procurement model, meaning that we don't use a subcontractor between us and the supplier. We go direct to a factory. So it's about choosing a supplier who is a good partner for us, someone who has the experience and the capability to build something like this, to draw all those 3D drawings. And part of that is we also choose all the material suppliers. So, we identified the glass that can work, what silicon, which powder coat we want, logistics, what fixings. We take ownership of all that in our business. In terms of tendering itself, it's pretty traditional. For this project in particular, we asked that all our tenderers gave us their concept. Like, how do they actually plan to deliver this? How do they plan to build this? There's a lot of small intricacies, like looking at this picture here on the left-hand side, like there's three-way joints everywhere. Do I press this one? Yep. Whoop. There we are. Like that detail there of two curtain walls crossing paths happens every 4 panels. So how do we achieve that and make that waterproof? That little piece of aluminium cladding underneath there, you can't access that on level 16. There's no boom tall enough to get you to level 16. So we had to install that cladding, or have a concept to install that cladding before the windows go in. So there was a lot of backwards and forwards with the suppliers at first to who has the most impressive concept. And then from there it moves into commercials and things like that. This particular project started with 7 tenderers. and the last three, there was sort of nothing between them. Their concepts were fantastic, their capabilities were fantastic, their facilities, incredible. And I think we sat there for 3 days in the office arguing about who it should be. On this particular project, we chose Fangda. They're a facility based in Dongguan, that's their factory, and their office is based in Shenzhen. And they were, we've partnered with them on multiple projects, each getting more and more complex. And this was the hardest one. So yeah, chose to go with them.
How did you control QA?
Great question. So we have a lot of quality control partners in China. So third parties who are based in the factories full time, inspecting every panel before it gets made. There's a lot of peer reviewing from other certifiers and drafters to make sure that the concept actually works and can be delivered. And a lot of inspections at the glass facilities to make sure that the quality of the product was good. That little opening on the left-hand side there is actually a automatic louver that wasn't available at the time, supplied by EBSA. It's an opposed opening louver, so it opens in 2 directions, and it was tested to 4284, and it had a tolerance of 0.5 mils on the glass. So we actually developed a template and took it to their factory and checked every single piece of glass before it came to Australia for us to install it.
Yeah. And Matt, have you given Nicholas enough grief yet?
I won't go into details, but overall it was, weren't too many issues. I think, as it's been highlighted, the complexity of design was really well captured by Fangda.
I think we all like figures, isn't it? So, from how many containers did that? Let's go through some figures here.
Well, so I'll just finish talking about this. So FTO1, we, sliding door, the cladding. We chose this particular VMU because it had a bit of everything, and it allowed us to give it a go and then see how it felt and how it fit together. FTO2, probably not a great angle of it because it looks a bit flat on this side, but that's that sawtooth facade or FTO2. That's pretty good. So, facts and figures. So behind me here, there's a whole bunch of figures. We had a rule with Fangda that we were not going to use any boxes to create corners. So every single corner on the job is a rocket mullion, and it created an enormous amount of dies. So 285 dies for this project. And there's some extremely low yield dies. In the northeast corner, there's a die that's used once on one panel. And you have to press 25 extrusions just to get that 3 meter length of aluminium. So from a sustainability point of view, not great, but it achieved a fantastic outcome. There is about 900 pages of shop drawings. There's an error up there that says 1,000 something fabrication drawings. That's wrong. It's meant to be 7,000 fabrication drawings. And each one of those drawings has my initials on it. So it was a very, very long and complicated process to design this project. We approached it as looking at FTO2 individually, FTO1 individually, and then where those systems merged, we fully 3D drew and worked out all those crazy intersections. A lot of stillages because of FTO2, because of the depth of the system. You'll see some photos in a moment. The stillages could only hold 2 panels at a time. So each of the lower floors was about 30 to 35 semis of product to deliver to site to fill the floors before we could install. Here's the zigzag facade, the start of it. Or I should say this is the sawtooth. Creating it, bringing it to life in its 3 different stages. Really tricky because it's very easy to do a straight slab edge, but when you have 200 little triangles that you have to get around, it can be quite complex. It looked a bit funny when we first started building it. Everyone was like, "Is that right? Did you make is it meant to be straight?" And so here are the stillages. You can see on the left-hand side, the panels are really deep to achieve that depth. And just heaps and heaps and heaps of them on every floor. Some of the concrete profiles that all these different shapes created. In terms of like difficulties of designing and delivering this project, you can see we use soffit brackets, which is pretty unconventional. We chose that because as you get up into the building, there was many different slab thicknesses and beams and things to deal with, set downs. And as you get up into the building into FTO1, the curtain wall was actually below the top of the slab. So there was no way for us to hook on normally. The FTO2 facade, there's our first panel. I'll come to the concept of that in a moment. But the FTO2 facade, at first it was really difficult to conceptualize like how it was going to come into real life. Like Bob said, if you start with a flat panel and then turn it a little bit, that gets you a zigzag. And then with the panel itself projecting, that's how you get these like two panels flat, or the glass surface is flat. So it's like a skinny panel, then a deep panel, skinny panel, then deep panel. And then that pattern also repeats itself vertically. So it's like a checkerboard of skinny and deep. Once we got our heads around that and how to assemble the panel, that wasn't too bad. But there was a consequence to this, which we didn't foresee as a builder, which is, I've got a better picture. So every time the panel projects, and it projects quite dramatically, about 250 millimeters, you can comfortably stand on that transom. It's not like a traditional window that was only 150 mil wide. It was like 450 plus a skirting is 550. And the panel was actually considered to be a floor. It wasn't a window anymore. It was an extension of the building. And with that came a lot more fire protection requirements. So we introduced wall wetters, which is pretty standard, but because all the panels are raked, the wall wetters couldn't get the throw to wet the windows. So every second window has a sprinkler behind it to be able to sufficiently protect the facade on the inside. Folk had a really good time with pelmets as well. Right. Yeah. Pelmets don't work well with a zigzag facade, but I think we came up with a good outcome in the end. That's a pretty cool one. Moving up into the building into FTO1, which is a zigzag facade, the biggest problem was every 4 panels you changed from a curtain wall to a window wall. So the curtain wall was on the expressed part, and then there'll be a window wall on the recessed part. The problem with that is different load paths. Curtain wall loads up, window wall loads down. So we actually ended up developing what we called a subhead bracket, which was inside the subhead of the window wall. We had 2 T-cleats in opposing directions, which the panels would hook onto. So all our window wall panels were actually loading up as well, and it avoided any sort of issues with differential movement, things like that. It did make it very difficult to install. We actually had to install the recessed components first, and then come and slide all the curtain walls in. There's some pictures of the FTO1 and FTO2.
Can I just add to it? Is a lot of these non-typical corners you can see. It is with that we just developed while I was going. So there was not, we couldn't foresee every single angle there, and we were just sort of guided by the icon crew or by the shop drawers, and it was a very collaborative process actually to come to the outcome here, because everyone there was all the dedication was there, which was very important to make it an amazing facade, and there was no shortcuts, which I think you can, at the final outcome, you can really see.
Yep. I tried to work out how many hours of meetings there were, like man hours of meetings. I gave up once we hit the thousands. So this is the FTO2 facade, so the hotel portion. So you understand how it's constructed. Every panel had this zigzag in it. There was a lot of discussion early days as to which side of the panel the zigzag would be on, and we ended up settling on that way. So you can see the rocket mullion in the inside is fixed together, so all the panels came out L-shaped, and that allowed us to install a lot easier because our male-female connection was just above my head here, and the legs were facing straight, so that each panel could still easily connect into one another. You can see the projection here. So every alternative panel was projected out. So that's how that came together, and this is the vertical snapshot of it as well. Cool. Once you get to FTO1, like with that X intersection, how we managed it was actually introducing a slab edge cover. So on the bottom portion of the curtain wall, that allowed the X to happen without us trying to change the direction of the facade. And I've got some images to explain that a bit better. But we had this slab edge cover with a travelling hook that would slide up and down. It would hook onto the subsill. The guys would come underneath and hook it on the brackets, and then we'd start installing the next level on top of it. The cladding was quite tricky. On the top cladding, the beaks, the slabs we weren't allowed to take any more out of the slab based on engineering, so we generated all the fall out of the cladding. And you can see this is the critical driver of why we needed a soffit bracket. The curtain wall was lower than the slab, so that we could get sufficient fall onto the cladding and so that it could hook on. The cladding on the far side or the external side, you would place it and pull it on because it was 2 meters away and you can't reach it. You can't access it to get out there and fix it. Remember, we're working behind handrails here with no access on the outside of the building. This image here is the famous subhead bracket. So you can see on the left-hand side, there's a bracket in the subhead and a bracket in the panel, and they would come together. You'd adjust them to where you needed to, and then someone with very small hands would put their hand through the where the snap bead is to tighten the bolt. And then the next panel would slide on, and so forth. Us and our Fangda and the installers, Complex Facades, we'd never done anything like this. It was not risky. I don't want to use the word risky, but it was something different. And it came down to the VMU, us all standing there like, is it going to work? Oh, I don't know. We've got to install the panel to find out. And we had some instructions of how to install it and how to put everything together. And these are the soffit claddings, and these circles are the facade access pockets. So in all the soffit claddings, well, not all of them, but in a large majority of them, you have these circles and there's eyelets inside of them. So when the abseilers come around, they can actually pull themselves underneath the building, underneath the beaks, to service the facade. Cool. These are the three-way intersections. You can see on the left-hand side, it's a window wall panel. It's doglegged up along the face of the slab, and then the curtain wall panel will butt into it, and then we'd have a subsill and a slab edge cover going in the opposing directions, making a really neat X. With a lot of the really complicated details on this job, yes, we did a PMU, but we also mocked up the unique details in the factories. We made tiny little curtain wall panels and stuck them together in the factory and hosed them down and saw if there's any improvement we could make to those junctions. I think there was, by memory, 16 of the system interfaces that were really complicated. This is just one of the fun intersections. You can see that we have a curtain wall, and then part of it, like the right-hand mullion, is attached to a bracket. The left-hand part of the panel uses the subhead bracket. The slab edge covers interfacing. The geometries were fantastic. Were really fun to play with. And in terms of how many types of panels there were in the hotel portion, it was pretty repetitive. It was sort of the same panels as it went. But once we got to the hotels, there's a lot of set downs. We had to constantly change between curtain wall and window wall. We had 3 different starter sills, 3 different subheads. Different back pans, depending if they were visible, if they weren't visible, different pelmet sizes. So in terms of repeated panel types in the residencies, I think it was something like 2%. Almost every single panel was a unique panel with some kind of different combination of things attached to it. So that's the left-hand side. We used this color code to tell us what we needed. And on the right-hand side was the concrete profile requirements that we would share to Folk. And we're like, we need you to do this to the slab. We need you to adjust it, put different size hobs everywhere for the different systems. And I think that was a really good process that we went through to sort all that out. Cool. Yeah.
Okay.
That's procurement.
The fun bit now.
Yeah, so I guess given the complexity of the design, it was important to verify the performance in a PMU. We did that for both the FTO1, FTO2 facade types. And given that they both had awning windows, we specified testing such as operating force, fall protection, snapshot, and also pull-out testing. The snapshot was, I guess, a mechanism that was derived from the vented facade analysis done by the wind engineer, just to make sure that, in a high wind event, that these windows would actually close and they wouldn't actually damage the internal partitions. So a specified rating was set for those, and then the window would close before it reached that pressure. The sliding doors, so considering they were pretty big and double glazed, there was a few issues in terms of their operation. So we had a look at what modifications we could make to the system, and we ended up switching out the handle and also swapping the external gasket to a brush seal, and that did the trick.
I think from a user point of view, they don't really care how complex their facade is, right? But if the sliding door doesn't work and if it's too noisy, cable's going to get the phone call. So
true.
It was interesting.
Just to paint some context, right? A lot of our purchasers for this development, some of them are in their twilight years and all that. So it just have to be this universal approach. Not everyone can handle moving a really heavy sliding door. So hence, during the inspection, it was made known this feels too heavy. What can we do? How do we rectify it? But at the same token, making sure that the acoustic performance is not being compromised. So yeah, I think Matt came out with a good solution. It's a combined effort that we got.
Yeah, that's a balancing act. And I think if you look at the code in terms of initial force and sustained force, sometimes it's not fit for purpose. I just chuck that in.
Another thing was, I guess early on we had discussions with Icon in regards to the initial JB3 modelling, which maybe somewhat oversimplified the design for the FTO2. The vertical sections were considered, I guess, as glazing, so we had to relook at that and defining the edge parameters where we could introduce or consider the build-up to be spandrel, which was a more realistic, result, and gave it better performance. And that was about all.
We might just run out of time.
So we're running out of time, but I know there's lunch waiting. So you want to do questions? Just one question, maybe. Yes, David.
No, Dave. Yep. Yep. This is the bane of my existence. I had to overlay all the brackets, find where the party walls were, and then put 2 brackets either side of the party wall. So it was just a massive effort to dodge the walls rather than be inside the walls. No. Once we were outside the walls, they were fine, and then it was like traditional smoke flashing details. But if it happened to hit the wall, which is something that we worked through the fire engineer, then we'd have to box it out with fire check. But made sure there was a lot of space. It was very hard.
Maybe one more question before if there's any more. Oh, right at the back there. Absolutely. At least the facade did. Don't know about the rest. All right. Thank you very much. Appreciate your time and your contributions. Hopefully this was useful.
Thank you.
Thanks.
Thank you.
Thanks to the Seafarers team. Just a quick reminder for the speakers from the second session, if you can come up for photos beside the stage. Otherwise, you're welcome to head to the break and make sure to check out the sponsorship booths as well. I'll introduce Mathew to the stage.
Hi, everybody. Not working yet? Working now? Good. All right, excellent. It's always good being after lunch. Everybody's always satisfied, hopefully. I might wait until a few more people come in. What do you reckon, Ed? Yeah? All right, good.
Thanks, Matt. Some very thoughtful references and details in the projects there. I understand bricklaying's a little bit of a dying art, so it's good to see Wardle keeping them interested and busy on lots of jobs. The next one up is Asia, the steel facade panel, presented by Michael Lette, who is the Market Development Manager from Lyons.
Thanks, everybody. Michael from Lyons, and today we're going to talk about our steel panels. As most of you guys probably know, Lyons is traditionally a 0.55 material. So most people that sit there and think of Lyons think of a thin gauge material and wonder why our panel systems can do what generally 0.55 can't do, due to the thickness of the material, but also the oil canning that follows. So Lyons, everyone's probably very familiar with this, and Matt basically showed before the Aramax profile. That's also part of the range that's missing on this at the moment. So I'm going to sit there and run through some videos of basically our panel system. The part that I've got here is, we're part of the Responsible Steel Initiative, so we're part of BlueScope. We're just a downstream division of BlueScope. And here's the video. So I asked marketing to put together a fairly short video. Marketing being marketing, they took it to 25 minutes, which then had to be chopped down. Otherwise, you guys would probably be falling asleep by now. But it's not that bad, but we'll catch up on time. There should be sound. Sound? 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 Sorry? Can we go back?
Azure adapts to your vision.
How do I start it? How do I
Perfect for
restart
low,
it? Can we restart it?
medium, and high-rise commercial and multi-residential buildings.
Restart it.
Offer
Because, cool. I think you might have to go back to, okay. Then it should start.
In the world of architectural design, innovation is key. Today, we introduce you to Azure, the next generation of steel wall cladding from Lyons. Azure is not just cladding, it's a premium facade solution designed and made in Australia. As a custom manufactured cassette-style walling solution, Azure offers unparalleled versatility for your projects. Whether you're working on external facades, internal feature walls, or striking feature blades, Azure adapts to your vision. It's perfect for low, medium, and high-rise commercial and multi-residential buildings, offering high performance in a large format, high-strength, yet lightweight panel system. At the heart of Azure is its innovative rain screen system design. Unlike many alternatives, Azure provides superior weather resistance without the need for additional sealing. Precision is our promise. Azure panels are manufactured using highly accurate robotic systems, ensuring tight tolerances and joint precision. This modular off-site production approach aligns perfectly with modern construction trends, including prefabrication and factory-built components. We understand that every project is unique. That's why Azure offers customizable sizes, shapes, and orientations to fit your exact specifications. But Azure's benefits go beyond aesthetics. Its design allows for quick and efficient on-site installation, reducing labour costs and time. Improved installation tolerances mean Azure can cope with site variations, minimising the risk of errors during assembly. And for your peace of mind, Azure comes with a Blue Scope warranty, assuring durability and performance for years to come. Azure harnesses the strength of steel. Manufactured using 1.2mm high-strength steel, Azure has been rigorously tested to meet Australian standards and NCC compliance,
That's at 108
including
Ks.
impact and cyclonic certifications. But we don't just provide a product, we offer a partnership. By engaging early with our Lysaght Design Solutions Group, you unlock practical support from design conception through to final installation and beyond. Our expert team provides early involvement to align project specifications with Azure's capabilities, advice on product selection and design detailing, assistance with project scheduling, comprehensive technical support throughout your project's lifecycle. The Azure advantage extends throughout the building lifecycle, from design flexibility and local manufacturing to efficient installation and long-term durability. Azure is more than cladding. It's a commitment to excellence. Azure by Lysaght. Inspiration to build better.
Okay, sorry for the long video. But the parts that I want to sit there and basically talk about, it talks about, you know, you're probably sitting there going, well, why is our panel any faster to install? Why is it any more accurate? Okay, the robotics that we use have a tolerance level of, when the factory tells me something's out of tolerance, it's between 0.02 and 0.5 of a millimetre. Okay, so that's how these guys are measuring this. So when you actually get panels, these are pre-made, generally off-site, so the more that we can do up front, the more we can actually get involved into the project, because it's, which I'm going to explain a little bit later. We won't go through this because this is pretty much what the video has already done. Modular, but the robotics is where it all basically fits. And the more that we can do more unique panels, and unique doesn't mean that it's exactly, it has to be exactly the same. If I can do that, I can have a machine produce a panel in 40 seconds. Okay, so I can get somewhere between 700 to 1,000 square meters done in a day from the factory. The site can't keep up with that, but I can sit there and deliver it faster than they can actually put this stuff up. We've got tested Nada Lab, so you would have seen that test. The panel that you see over here, and you can see the ding in it, that's a 4x4 piece of timber with a metal capping on it, shot through essentially a cannon, and it's at 108 k's an hour. And that's what the panel looks like after 108 k's. We do this for impact testing. We do this for projectile testing for hospitals and things like that in North Queensland, and for basically for any building that has to meet any of the cyclone codes. So it's all about early manufacture. I won't bore you with this, it was all through the video, but the quicker we can get in, the easier it is. So what I was saying about unique, so that's obviously concept, and then it goes through And as you can see, pretty much each one of those panels on a drawing looks like 1 metre, 1 metre, 1 metre. Unfortunately, architects and people that want to sit there and line up, designers that want to line up with specific joints, especially over long jobs. So at the moment, I've got a 20,000 square metre job in Perth over 5 to 7 railway stations. And when you suddenly move panels, it's out of sync further down. And what they don't understand is that they're suddenly starting to create a lot of unique panels, and the machine doesn't like as many uniques as it does to sit there and punch out 80 of exactly the same, or 100 of exactly the same, or 300 of exactly the same panel. So if we can sit there and get into design early with the designers, which we do, then I can sit there and work out ways that we can actually make this very, very economic. We then produce all of these drawings, so these drawings are all done by us. So this is something, again, that generally a lot of the industry is not used to. We then do all the fabrication drawings because obviously we're producing the panels. We then go through, do all the essentially shop drawings that show your design layouts, your installation directions, things like that, and then it's basically done for approval, and we sit there and produce the go button in the factory, and we produce these panels. That's just essentially showing in the first video, in the first one there, it's just top hat. Again, it's the same thing as the slide before. So this is a term that I try to use when we've had a lot of jobs that have been done by people who have never installed, let's call it high-end facades before. And in the Cross River Rail project, it was done by a roofer that had never done that type of facade system. All I asked him to do was to spend a lot of time in the early piece to sit there and work through making sure that we had all the details done. He took it slower in the beginning, and then like the dominoes effects, it takes a really, really long time to set up a dominoes train, but then it takes 2 seconds to sit there and run through. Our panels, the why they are quicker than the normal systems is that our panels are only fixed on 2 sides. That also helps with the oil canning. Yeah, so it's a double whammy there. So it's a plus feature. So we only fix essentially on the long legs. So it doesn't matter if the panel's going vertically, horizontally, or diagonally. It's always whatever the length of the panel is. That's the fixing legs, and we don't fix on the other 2 ends. They're actually free. So this is the project that I was speaking about in Perth. So we're essentially doing. Like I said, there's 20,000 square metres. We're doing all of the undersides here. We're doing all of the Safite platforms. We're doing all of the inside walls. Basically, these are all cranked. We've got a lot of panels that have got a lot of unique features that a lot of people didn't think that we could do in steel. So everything that the architect is used to from an aluminium point of view or solid LED, I can do in steel. And actually, I can do a lot more in steel in some cases. So here again, we've got all of these through here, up through there. So we've got the 5 stations on the Allure upgrade, which is the Armidale line grade. And then we've also got on to the Armidale station now and the Byford. So that takes it to a total of nearly 30,000 square metres of facade panels on a PTA, Perth Government rail station. So that's just some more images of the picture. We've got special colours in Copernicus and things like that, which is like one of the special colours. So colours are essentially colour-bond colours, but we do have a lot of specials, and we can do colour matches and things like that. So we're actually doing the brand new Audi 5-star dealership in Mairie in Perth as well. That is also being done in Azure. So that was all ticked off by the guys in Germany. So just really quickly, design. It's a very, very simple flat system. Manufacturing it's very, very specific. There is flexibility in the design. We do allow you to sit there and be able to move the panels. So if the guys need to install or to sit there and catch up or to reduce the joints. The installation, like I said, it comes pre-drilled. Everything comes, it's like an IKEA straight out of the box. You just basically take it out, put it on the wall. If you can put your subframe in place, this goes up really, really quickly. The yeah, the advantage is it's a sleek design. It's 100% made, so it's all using BlueScope steel made out of Port Kembla in New South Wales. It's essentially lightweight, so the system, I know people sit there and think that steel's quite heavy. Our 1.2 is similar, if not lighter, than a 3mm solid panel of the same size. And it's durable, as you can see from the impact test, and yeah, that's it. So that's where we've come from facades, but we're also starting to do internal finishes as well. So that's Monument Matte. And that's it.
I think as facade professionals, we can all appreciate a high quality rain screen facade. So thanks for that presentation, Michael. Up next, I'll bring up to the stage Oliver Turner, Operations Manager from Climate Ready Engineering, to present on the sustainable benefits of facade automation for shading systems.
Good afternoon, everybody. My name's Oliver Turner. I'm from a company called Climate Ready Engineering, and we specialise in shading automation. And today, I'm here to discuss the sustainability benefits of facade automation for shading systems. So when it comes to sustainability, I'll be breaking it up into three parts: social, environmental, and economical. And I'll be applying those facets to some real-world examples where we've, let's say, rolled out these systems on projects in the past and what we're currently working on. So when it comes to when it comes to achieving the levels of sustainability, there is a number of things that need to be considered. First one being integration. So the first thing you need to determine when you're looking at integration is the language or the protocol that you're going to be using. So I've listed a few of the protocols that are available on the market and that we generally use to integrate into, say, your BMS systems. And then you've got to then consider like the AV integration, which is the tenant's AV system, in order to again minimise the amount of integration required. So for us, again, there's a number of different AV protocols that we regularly use, and there isn't really many that are out there that we can't integrate into. A number of other elements that need to be considered are listed above. So HVAC integration obviously refers to the temperature, humidity, and air ventilation within a space, and really focusing on that tenant comfort. Energy management, obviously not wanting to overconsume overconsume in that building from a energy perspective, and our systems are able to really consider that consumption. From a fire system perspective, for example, you've got shades that are blocking an emergency exit. Now, in an emergency or a fire, you need those shades to retract. So being able to integrate those shades into a system that is smart enough to retract those shades at that point is a critical safety aspect. Wind override management is obviously a safety aspect. So if you've got external shades, then from a safety perspective, if it gets too windy, you need them to retract. Lighting control is obviously minimising the amount of artificial light that's used, so and maximising the amount of natural light. Lux sensor also refers to lighting, so we've got a number of sensors that can be installed on roof panels, and they take into account the relevant glare on that particular day. Now, the sun tracking and overshadowing is something that we pride ourselves on. So when you're considering sun tracking, there's two ways of looking at it. There's obviously passive sun tracking, which tracks the actual sun position every day, as opposed to active sun tracking, which is basically considering the movement of the sun based on a schedule. We obviously look at the actual sun position and pride ourselves on the modelling that we can do from a passive sun tracking perspective. Then you've got the overshadowing. So again, we've designed and develop models that will consider the buildings that are around the relevant building that we're working on to, again, maximise the amount of, let's say, glare or light that is coming inside a building, and not having the shades in a down position when the facade thinks that the sun is on the or the building thinks that the sun's on the facade, but it's actually not, because there's a building casting a shadow over our building. User override. So again, you don't need, or you don't want the local users having full control of the shades in that particular location. So it's about working with facilities and building managers to let's say, manage the local user control, giving also the users a level of customization from the graphics that they're using to control those shades is very very critical, and then customizing the amount of zones that each of the floors can have, and breaking up in a way that's logical for the tenants at that particular point. So if I go into the projects that we've worked on and rolled out this particular shading system, the first one is Bligh Street in Sydney. So CRE were involved in the design of the blind and the control system, and where these shades were located was in a double ventilated facade, and the way that we designed this control system had to consider the curved nature of the facade. So from a social sustainability perspective, one of the most important things was automating those shades, as well as having a sun tracking system that didn't have any local user override switches. So the emphasis was all on the system, and there wasn't there was a huge reliance on that, given that there were no switches on each of those floors. Obviously, if you've got a need to control those shades outside of the control system, then the admin on that particular floor can log into a portal and control those shades. From an economical sustainability perspective, we obviously reduced the amount of HVAC and lighting usage through the control system, and then we were able to preempt any complications with the shades through regular service and maintenance. From an environmental perspective, 1 Bligh Street was the first building in Sydney that was able to achieve a 6-star Green Star rating, and the shades played a very important part in achieving that level of performance for that building. Another important thing to consider from an environmental perspective to be able to achieve that rating was the fact that the intelligence for that automation was built into each of the controllers rather than a head end. What that means is if the network was to go down, the shades would still behave as they should in its, let's say, design. So obviously you still need power to run the shades, but from a network perspective, there was less of a risk on the system should the network go down, given that the intelligence was built into each of the controllers. Key Quarter, I'm sure a lot of you are aware of that particular building and the awards that it's won. It was obviously a high-end commercial space that had a huge focus on the view. So we had to maximise the amount of time that those shades were in the open position without obviously compromising the glare on the tenants' desks at that particular time. So we implemented a time response with override switches, and then we were able to integrate into each of the tenants' AV systems, that being Crestron and Dynalite. This is an example of the floor plate that was used for the graphic user interface. So we were able to overlay our controls on a 3D floor plate, and each of the different colours represented a different zone. So yeah, I guess just to give you a bit of an indication of what the floor plates look like. And this is the dashboard that or the facilities managers commonly are exposed to, and there's a number of different functionalities that can be used with this particular dashboard, from scheduling, let's say, the current status of the shades, and obviously the current conditions outside. From an economical perspective, so to give you an example, a 1 degree change in temperature makes a 3 to 4% impact on the energy usage. So we were able to demonstrate a reduction in temperature through the use of the shades and then achieve that level of saving for the facilities managers. Another important environmental aspect for this particular building was the fabric that was used here, and it was ocean-bound plastic. It was made from ocean-bound plastic that was then turned into a fabric that could be used for the shades in this particular building. Here's just a number of awards that particular building managed to win, which I guess gives you an indication of the quality of that building. 85 caster sheet. So for us, this was quite a unique project because we were asked to come and retrofit a new control system into that building. So what had happened was another contractor had installed the control system and it wasn't performing to the levels that it was originally designed for. So we were able to come in, retrofit, and sort of leave or do it in a way that really minimised the impact to the tenant. So we did that after hours, and basically that allowed us to, or we did it in a way where the system wasn't offline at any point. So we would come in, switch out the hardware overnight, and then switch on the new system before the tenants would arrive into their workspace. This is just an example of the graphic user interface in place, and also sort of demonstrates the amount of zones that we have to consider when designing the system. So each of those meeting rooms have their own switch, which then can control the blinds individually, or you can control them all at once. From an economical sustainability perspective, so we were able to reuse a lot of the existing hardware, that being or predominantly the cables, and then obviously upgraded the relevant hardware to achieve the performance that was required. These manual chain blinds were just an example of what was happening before. So the tenant had installed chain blinds because the existing automated system wasn't working as it should have. So that was a bit of an indicator to us that, yeah, something wasn't right at that point. So we were able to install the new system, remove those shades, and then prove to them that the new system was going to work as it should have. From an environmental perspective, so as I said earlier, we were able to reuse components from the original installation, whilst also being able to upgrade the system so it's future-proof and scalable. So, and then also achieving a certain level of Green Star and sustainability rating also through neighbours. One Sydney Harbour. So that's one we're just about to finish at the moment. It's easily our biggest project to date. We have 7,500 blinds in that particular precinct spread over 3 towers. So that's a high-end residential space. And from a social sustainability perspective, we had to integrate each of those shades into one home automation system, that being Crestron at One Sydney Harbour. Whilst also, I guess, maintaining all of our key, let's say, inputs, that being sun tracking, wind sensor safety mode, and then there was also an interesting thing here where the penthouse owners had a fire pit installed on in their apartments, and basically, if the fire pit was switched on, the shades had to retract. So, quite an important safety aspect for that particular building. From an economical perspective, we were able to save the tenant owners, or tenant owners, through a reduction in lighting and HVAC costs. From an environmental perspective, we designed a system that usually you have sort of 2 to 4 blind motors per controller, but in this instance we had 16 motors per controller, which saved hardware and wiring costs, which was big. The last project I want to discuss is Metro Martin Place. So we've gone from our biggest project, which was One Sydney Harbour, to our most technical. So Metro Martin Place had a bunch of trapezoidal and parallelogram shaped facade panels that we had to consider when designing the shades for this particular building. From a social sustainability perspective, the graphic user interface that we developed here was completely customized and had to offer a certain level of interactiveness for the client, that being Macquarie Bank. Here are a few more videos from the site. So that last one is a bottom-up blind that you don't really see many of, and something that we were quite proud of given the shape of the facade that the shades were being installed in. From an economical sustainability perspective, again, tying into the local meeting room AV integration, and again, being able to save the building managers costs when it comes to HVAC and lighting usage. From an environmental sustainability perspective, you can see here this time-lapse video gives you an indication of the overshadowing modelling that we did for this particular building. So as the shadow casts over the Macquarie building, the shades will obviously behave in a way that maximises the amount of glare coming through that particular window. And again, something that was all developed in-house and had to clearly consider the buildings surrounding that particular building. Here are a bunch of projects that we've worked on in the past, and we're also currently working on a couple of projects in the UK, in London, and we're also working with the same contractor that developed the control system for 8 Bishopsgate, which was discussed earlier in Ed's presentation. So that's something that we're quite proud of. So I'd just like to thank you all for your time this afternoon. If you'd like any more information about what we do, or just like to discuss anything that you've seen in the presentation, feel free to come and have a chat to us. Thank you very much.
Thanks, Oliver. It sounds like Climate Ready's done a lot of focus on efficient automated shading, and with some happy end users as a result. So next up we have a multidisciplinary focus on facade air tightness by the team from Mott MacDonald, including Kieran Rice, facade practice lead for Australia, Siobhan Sandhya, senior mechanical engineer, and Dmitry Ivanov, building physics lead for Australia. Maybe go up.
Right, good. The microphone's working. I'm just going to very quickly introduce the speakers. So I'm the facade practice lead for Mott's in Australia. Dmitry Ivanov is the building physics practice lead for Australia. And Siobhan Sandhya is a mechanical engineer with our team here in Melbourne. So we're organised at Mott's with engineering sciences, which is 7 disciplines, including facades, which is not the case in every practice. But what it does do is it gives us a good opportunity to work with our colleagues in building physics, computational design, acoustics, wind, etc. And one of the things that has interested me in Mott's is how we're able to drive multidisciplinary workflows in order to see if we can achieve better outcomes. We also have a long-standing commitment to trying to reduce carbon emissions in buildings. For example, we contributed to the Green Building Council of Australia Practical Guide to Upfront Carbon Reductions. We've got multiple other publications as well. And it's given us certain insights into where we can help to make the most impact. This is a typical breakdown of where carbon emissions occur across a building's life cycle. So most of you will, if not all of you, will be familiar with this. It goes from modules A to D. Module A is embodied carbon, it's product carbon. Module B is the use and replacement and maintenance. And when we talk about air tightness, the embodied carbon aspects are relatively negligible. So it doesn't actually add a lot of products to a building to achieve air tightness. It's more about process. But it does have impacts on module B6, which is operational energy and carbon use. And that's what we're going to explore a little bit during this presentation. So the basics of airtightness, design and testing. So when we were putting this presentation together, I went on AI and I asked them to give me an image for an airtightness building, and this is what I got. So it looks a little bit more like a haunted house than an airtight building to me. But airtightness, in essence, is the control of airflows from a building, so either from the inside to the outside or from the outside to the inside. So if we look at where we are on the journey towards airtightness in Australia compared to, for example, the UK, we can see that we're not quite as far along. In the UK in 2022, they introduced mandatory airtightness testing for all new buildings. And they set a target of 8 meters cubed per meter squared hours as an acceptable rate that you had to achieve. And of course, what happened was industry very rapidly upskilled in order to achieve those targets. So they now test every single building. And they found that the average result is more like 5 meters cubed per meter squared hour. So they're actually achieving better than the target. When you look at Australian buildings, residential buildings, we have a tested average for existing buildings of around 20 meters cubed per meter squared hours. So that's obviously a pretty poor result. And I think anyone who lives in an Australian building, and I assume that's most of us, will know what that means. It means buildings that are very hard to heat, buildings that are uncomfortable, both in the summer and in the winter. When you look at test results for average non-residential buildings, it's around 10 meters cubed per meter squared hour. Now, actually, the NCC sets a limit of about 5 meters cubed per meter squared hour, but it doesn't make testing mandatory. So in fact, what happens is the buildings are significantly more leaky than they're supposed to be. When you look at the products that we're putting on our buildings, for example, a typical curtain wall system, these will achieve around 0.3 to 0.4 meters cubed per meter squared hour when tested in a factory. So what we find is that the products that we're using are actually extremely high performance, but the way that we're using them is not getting the best out of their performance. And this is because of poor installation or poor design or a combination of both. Typically, the way we test for airtightness is relatively straightforward. It's called the blower door test. So what we do is we seal off the portion of building envelope that we want to test. We seal all the doors and the openings, and then we pressurize the area to the test pressure, which is typically 50 pascals. And then we measure over time how that pressure dissipates, with the assumption that it's dissipating through the building envelope. And that enables us to determine the air change rate, and there we can determine the air tightness. The impacts of air tightness. So obviously air tightness has an impact on energy and carbon use in the building, because if we control the airflows, we lose less energy through the envelope. It also has an impact on heating and cooling design loads, peak loads, which, as we'll see, has an impact on the plant sizing. It has an impact on air quality, so CO2 and oxygen levels inside an airtight building have to be carefully monitored, as we'll see. It also has impacts on moisture movement and condensation management. So if you create an airtight building, you have the risk that you will trap moisture within that building, in which case you have to manage the consequences of that. And finally, air quality. So if you're able to control the airflows into and out of a building, you have a much better control on the air quality inside that building. I'm going to hand over to Dmitry.
Thank you, Kieran. Greetings all. My name is Dmitry Ivanov. I'm a building physics lead in MODS. So our team did a bit of a quick case study around how we can evaluate the impact of air tightness on design thermal loads, meaning that how we can downsize the mechanical equipment thanks to the facade air tightness, and also how we can measure the improvement in annual energy costs and carbon expenditure. So to give a bit of background information about this study, I want to talk about how infiltration is typically treated in the standards. So unfortunately, it's actually not accounted for almost. So whenever you simulate a building according to NCC, it prescribes using a fixed profile of infiltration independent on the air tightness of the building. As you can see on the graph to the right, it's just a fixed 0.7 air change per hour whenever mechanical systems are not operating, and 0.35 whenever they are operating, independent on the performance. Green Star takes a step a bit further. It allows for textbook air change per hour values for different air tightness of the facades, but those values are textbook numbers from developed for London, and you still have this fixed profile. So to talk about what we actually did with that, so going back to physics, so how actually infiltration works. So it depends on only two forces. It's a wind pressure and buoyancy. And wind pressure, as we know, that, well, the higher the wind is, the more infiltration we have, and depending on the location of facade, we have exfiltration zones. And buoyancy is driven by the temperature difference between indoors and outdoors. So when considering those two forces, their nature is they're changing all the time during the year. So we have different wind directions, we have different wind speeds, and similar way we have different temperature throughout the year. So it becomes a very tricky thing to account for. So we did a bit of research, and actually good thing is that there are more advanced models in standard tools like IES and Energy Plus, which are used for energy simulations, which allow for these wind-driven and buoyancy-driven infiltration models. And as Kieran mentioned, typically air tightness is tested with the blower door tests. So, and there is a way to convert the blower door test results into these models. So that's exactly what we did for the case study. So we analyzed 4 building prototypes, which was high-rise residential building, typical commercial office, secondary school, and the hospital. What we found, that's a kind of a snapshot of the simulation results, and at the top you have results for 15 cubic meters per square meter, very leaky facade. And what you get from the models like that is that you have this fluctuation of infiltration. That's what you would expect, like physically. And when we input a more airtight facade, you can see that there is a drop in air change per hour during because of infiltration. So final 2 slides from me. So takeaways from this study and the results of this study. Actually, you can see to the right, there are bar charts with the reduction in design heating load. So that's how much you can downsize the mechanical system because of the air tightness. And the light green color is reduction from 50 cubic meters to 10, then darker to 5 and to 3.5. The takeaways are, you can see that different building typologies affected differently. So in this case, high-rise residential mid-office took more advantage from the air tightness of the building. And this is really a function of particular form factor of the building, amount of internal gates in the building, window to wall ratio, and also daily usage of the building. Also, we can see to the graph to the bottom is the reduction in cooling load, and you see that the cooling load is affected way less than the heating loads. So that's another takeaway, and it really talks about the climate dependency of the effectiveness of air tightness in the buildings. So in colder climates, we have more benefit because of that. When we look at the annual energy use, so you can see, again, results for the heating, and now if previously the savings were around 6%, now the savings can go up to 16%. So annual energy use is more affected by the effect of air tightness. Then we see that actually the cooling reduction is negative. So we have a penalty for improving air tightness. That's because infiltration works in a way similar to natural ventilation, where you have natural cooling. But if we sum up heating savings and cooling negative savings, we still get a benefit from air tightness. And again, different building types affected differently. So the key takeaways from this study, well, first thing is a good thing that there are ways to account for air tightness in this kind of analysis and to actually evaluate the benefits in both design of the systems and in the annual energy use. And the second one, that there is a potential sweet spot in air tightness from both cost perspective and from carbon perspective. That's all from me, and now over to Siobhan to talk about mechanical systems. Thank you.
Thanks, Dmitry. Hello, everyone. My name is Siobhan. I am a mechanical engineer, and I just wanted to touch on a few other important considerations to be aware of when we're talking about airtightness in our facades, primarily ventilation, as Kieran's touched on earlier. So obviously, the more airtight our facade is, the less air we're bringing into our space, but this also means the less fresh air we have for our occupants within. That can risk things like headaches, dizziness, and fatigue, but we can also introduce a risk of mold growth due to condensation and moisture buildup within our spaces. So for every airtight envelope, we need to equip it either with openable windows or a mechanical ventilation system. So you might then ask the question what the point is of designing for airtightness if we need to open our windows or introduce mech vent. And the point is that on one side, we have the uncontrolled movement of air, and the other, we have controlled management of air. So a leaky facade, we will introduce unpredictable amounts of air into our spaces, and they're coming in at uncontrolled temperatures and humidities. And where we do have a HVAC system in place, this will have to run over time to constantly compensate for this. This leads to higher running cost and higher energy. We also do have a key role that airtightness plays in air quality within our spaces. So especially when we're looking at events like bushfires, a good airtightness level has the ability to reduce the ingress of PM 2.5 and PM 10 particles, protecting our occupants within. So taking a step forward now and looking beyond just airtightness to the role that the facade will play when we're looking at the future of our buildings, particularly when it comes to electrification. So the question is, how would the facade impact a building services electrification? And actually, we do see significant savings in cost, spatials, and our carbon emissions. But to understand why, we need to take a quick look at the building services perspective. So as our industry moves towards electrification of buildings, we're talking typically about moving a heating plant from gas to electric heat pumps. So this is traditionally what you'd see as a gas heating plant. It takes about 30 meters squared of space. It's about 1,200 kilowatts of heating capacity. Now, this hasn't been a significant portion of a building's annual energy usage or cost in the past, and if we were to try and reduce our heating capacity from 1,200 to, say, 1,000, we wouldn't get much of a benefit in our spatials or our costs or our carbon. However, as we change, if we were to upgrade this heat plant to an electric, which is where the industry is going, we can see this is exactly the same capacity, 1,200 kilowatts, but we've now more than doubled our plant space. This is also significantly more expensive in terms of plant, and we're talking multiples. So in this case, if we were to find a way to reduce this 1,200 kilowatts to 1,000 kilowatts, that would save us significantly on plant costs, but also we're talking about dropping meters from our plant space, and that is where the facade can come in. Because as Dmitry's already illustrated, we do have a fantastic opportunity in facade performance where we have a high-performing facade that can significantly reduce our heating loads. And so what does all this mean for us? So we need to take a more holistic approach when we're looking at design of facade and MEP systems. And these early types of case studies can really benefit our cost-benefit analysis and help us choose the right approach to go forward. And also working collaboratively on these sort of systems can help us uncover opportunities that we've not had in the past, especially when it comes to moving forward with electrification. So now I'll just hand over to Kieran.
Thank you.
Thank you.
So a couple of slides to wrap up. So first of all, policy. So currently the NCC doesn't require air tightness testing, but it's expected that it will come pretty soon. And in the meantime, there are some major clients who have already mandated air tightness testing on all their new buildings. Health Infrastructure in Victoria, the Department of Defence, And of course, if you want to obtain a Green Star certification or a Passive House certification, you also have to conduct airtightness testing and demonstrate that you've achieved the target levels. So in a way, this is coming, and the industry has to be prepared to deliver it. The basics of airtightness testing. So it's essentially, if we consider that the products we're using are generally airtight in themselves, the airtightness is achieved by focusing on the jointing between these products and the interfaces between systems. Typically, the methodology that's used is relatively straightforward. It's tapes, it's sealants, it's air barriers, and it's a lot of quality control and testing. So in itself, it's not necessarily hugely expensive, but it's not something you can do as an afterthought. So you can't sort of decide halfway through the project that you're going to achieve airtightness testing. You need to set the project up at the start in order to get the result that you want. So this is the last slide. Who is responsible for delivering airtightness? So the answer is, of course, everyone. And it requires, I think, a collaborative effort by all the people who are either involved in the design of the facade or the delivery, construction of the facade, or the impact of the facade. So we've got the architect, the facade engineer, the facade supplier, the building services engineer, the sustainability consultant, etc. And I think the key thing is that you need to decide you're going to go for airtightness at the start. You need to have someone whose responsibility is to coordinate everyone's efforts to ensure that it's achieved. You need to make sure that you detail the design and also the quality control. You need to test during construction, so you don't want to reach the end of construction and start testing, because you will not achieve what you want to achieve. And that's it, really. I hope that was useful. Thank you.
Thank you to the McDonald team on that presentation on air tightness. We all know leaky buildings are a bit of a notorious Australian phenomenon. So I think we all know how important air tightness is, and that we should be pushing for more testing on all our projects. I do think your AI airtight building, Kieran, did look a little evil, but let's not let that be a reflection on the challenge of achieving air tightness. So up next, we have Sustainable Architectural Solutions with Powder Coating, presented by Simon Metcalf, the ANZ Marketing Manager from Asco Noble.
Good afternoon. Thank you all for your time. Today we will discuss a crucial aspect of architectural design and construction, the importance of external architectural grade coatings. These coatings play a pivotal role in ensuring both the physical integrity and aesthetic appeal of structures, and it is an imperative that we understand the significance of adhering to performance criteria in this realm. First and foremost, let us emphasise the notion of longevity. When we speak of longevity in the context of architectural coatings, we refer not only to the durability of the structure, but also its enduring beauty. An external architectural grade coating that meets performance criteria guarantees precisely this: a lifespan that withstands the test of time, both in terms of physical endurance and visual appeal. One of the key factors in achieving such longevity lies in the utilisation of a wide range of powder coating technologies tailored to specific applications. These technologies are not arbitrary. They are developed and refined in accordance with voluntary global standards set forth by organisations such as American Architectural Manufacturers Association, Australian Standards, and International Organisation of Standardisation. These standards serve as a beacon of excellence, guiding us towards coatings that are rigorously tested and proven to excel in real-world conditions. Consider, for instance, the environmental stresses to which architectural coatings are subjected: exposure to UV light, chemical pollutants, high salinity and humidity are just a few examples of the challenges that coatings must endure. Through adherence to global standards and testing protocols, we can subject our coatings to real-time exterior exposure, simulating the very conditions they will face in the field. This ensures that our coatings are not only resilient on paper, but in practice, offering dependable protection against the harshest elements. As a coatings manufacturer, we recognise the significance of translating real-time performance, real-time exposure into real-time warrantable performance. Our commitment extends beyond mere compliance and stands with encompassing a dedication to delivering coatings that exceed expectations. Furthermore, in the realm of architectural coatings, the Florida testing procedure stands as a universally accepted benchmark for assessing the robustness of colour and gloss retention. Indeed, the Florida climate presents a formidable array of stresses encompassing intense UV exposure, high humidity levels, soaring temperatures and chemical pollutants. Such conditions represent a rigorous trial for any coating system, demanding resilience and durability beyond the ordinary. The Florida test therefore offers a comprehensive evaluation of a coating's performance under these exacting conditions. Through meticulous observation, we gauge not only colour variation, but also the subtle nuances of gloss change over time. This holistic approach allows us to assess the long-term validity and viability of coatings, providing vital data to inform our decisions in architectural design and construction. ARMA 2604 and 2605. These standards, synonymous with super durability and hyper durability, respectively, offer multi-residential and commercial warranties of up to 25 and 30 years. It is the commitment to meeting these standards globally that allow Interpon to offer you warranties for any of our global accredited applicators. While only a 5-year warranty difference between ARMA 2604 and 2605 seems like a small amount, you can see from the testing regime of ARMA 2605 is twice that of 2604, and the warranty itself is only a true reflection of how long the coatings have been commercially tested rather than its actual ability for longevity. Here we can see why specification for commercial facades is important for a minimum of ARMA 2604 products, as your standard residential powders fade significantly quicker than its super durable alternative. In 1991, when powder-coated windows and curtain walls were installed in California, it was a novel concept, at a time when most US construction projects use liquid paint on aluminium. Given the projected lifespan of the building, the architects chose the most durable powder coating system available at the time, a super durable coating called Interpon D2000. Now the coating system continues to exceed all performance expectations, even in California's tough climate. Tests of the hospital building have shown that both colour and gloss significantly exceeds the product 15-year guarantee at the time. Why are we so proud? Because long-term protection is vital to high-value infrastructure, and California's Mission Hospital is testament to the quality of our architectural powder coatings. Not only can our coatings last the test of time, we have now developed new products for the installation and sustainability of the facade supply chain. Interpon D2525 Structura is a mire-resistant fine texture coating that comes with our Interpon D 25-year global warranty. The beauty is in its sustainability, is the mire resistance reducing transport and installation defects to almost zero. No more spray cans on site touching up or waiting to replace whole boards from scratching. We have continued this technology into our Stone Effect range. This revolutionary collection is designed to transform the aesthetic appeal of structures, offering a remarkable substitute for traditional materials such as concrete, Sydney sandstone, limestone, and brickwork. In a world where visual appeal meets functionality, our Stone Effects powders coatings redefine the standards of excellence. They not only elevate the visual allure of surfaces, but also embody the robustness and durability of an Interpon D2525 system. Firstly, these coatings boast highly weather-resistant properties, ensuring longevity and endurance against harsh environment elements. Secondly, they significantly reduce weight per square metre, thereby enhancing structural efficiency without compromising on aesthetics. Thirdly, Interpon D2525 Stone Effects offer a cost-effective solution, providing unparalleled value for your investment. Moreover, the ease of installation and replacement streamlines the construction process, saving time and resources. With a super durable formulation, these coatings come with our same global warranty of 25 years, offering peace of mind and reliability to our customers. Furthermore, embracing Interpon's Stone Effects contributes to a lower carbon footprint, aligning with sustainability goals and environmental stewardship. Some of our project track records. Here we see our stone effect powder used on the cladding in the West End Gate project in London. The Royal Children's Park Pool, the aluminium fins all powder coated in custom colours in our D2525 range. The Monash University campus, highlighting the super durability and the colours available in this range. The Chester and Ella in Brisbane. Cord residence in Brisbane as well, all on perforated panels. The Icon in St Kilda, classic with expanded mesh panels. The store in Newcastle, also unperforated. Next, we will discuss Interpon's environmental commitment with architectural powder coatings with our new EPDs. What is an EPD? An environmental product declaration basically signals manufacturers' commitment to measuring and reducing the environmental impact of products and services, and then manufacturer reports these impacts in a transparent way. One of the distinguishing factors of EPDs is their widespread recognition in the architectural industry. Amid the plethora of competing declarations, EPDs have emerged as the gold standard for environmentally conscious architects and designers. Their credibility and reliability make them a trusted tool for decision-making in sustainable building practices. Another key aspect of EPDs is their external verification. Unlike self-declared green labels, EPDs undergo rigorous scrutiny by independent third-party assessors. This external verification adds an extra layer of credibility, ensuring that the information provided is accurate and trustworthy. There are several types of declarations we use. Life cycle assessment is a systematic approach used to evaluate the environmental impacts of a product, process or service throughout its entire life cycle from raw material extraction to disposal. It considers factors such as resource use, energy consumption, emissions to air, water and soil, as well as potential impacts on human health and ecosystems. To make sure you compare apples to apples with EPDs, the life cycle assessment must conclude the same representative scopes, such as location, type, and unit. Also, publication and validity date, along with environmental impacts, such as global warming potential. The main life cycle stages that we consider for paints are the following. So, cradle to grave of the product manufacturing, and then the end life cycle. It calculates environmental performance of the product or process over its entire life cycle. Typically takes into consideration the full value chain from raw material extraction through manufacturing, product use, and until the end of life. Since the 2018 Environmental Product Declaration, significant improvements have been achieved. Reflecting a dedicated commitment to sustainability and environmental responsibility, here are the key enhancements. Relative energy consumption has been reduced by an impressive 28% since 2017. This signifies a substantial improvement in energy efficiency, contribution to a lower carbon footprint, and reduced environmental impact. Adoption of renewable electricity has seen remarkable progress. In 2017, no EU sites utilise renewable energy, whereas in the current scenario, renewable energy electricity is employed in 2 EU sites and currently being installed into North America and Australia. Overall, relative waste has been significantly reduced by 44% since 2017. This reduction demonstrates effective waste management practices and a commitment to minimising environmental waste. With our new EPD, we see the global warming potential of our polyester powder coatings are better than standard global equivalents. Important to mention that in both EPD raw materials, resin and titanium dioxide have the biggest impact, and we will see where our value chain efforts for these are investigated in a later slide. Our EPDs are used in the certification of green buildings. These certifications serve as valuable indicators of a building's environmental performance and its adherence to sustainable practices. Lastly, we'll explore AkzoNobel and Interpon's role in sustainable excellence. People, Planet, Paint encapsulates AkzoNobel's overarching commitment to sustainable development social responsibility, and environmental stewardship. By aligning its business practices with these core principles, AkzoNobel strives to create value for our stakeholders while contributing to a more sustainable and prosperous future for generations to come. Diving into our value chain in more granular detail, as you saw, we committed not only to reduce our own carbon footprint, but we have also the ambition to reduce our Scope 3 footprint by 50% in 2030. This means we want to reduce the footprint of our entire product cycle, including suppliers and customers. Our target is in line with the Paris Agreement, which aims to limit global warming to a maximum of 1.5 degrees pre-industrial levels. The Science Based Targets Initiative approved our objectives, which make us the first paints and coatings company obtaining this approval. Closer cooperation with our value chain partners is key to achieve our goals, and we are working together with both our suppliers as well as our customers to reducing our value chain emissions. Sorry. To assist with our customers in the reduction of Scope 3 efforts, our EPD has the following detailed carbon footprint data for all life cycle steps. Global warming potential is available in the EPD. However, detailed carbon footprint data of all our life cycle steps is available for all of our powder coating products. Our commitment to reducing carbon footprint is at the core of our sustainability efforts. Here's how our current offerings and innovative pipeline contribute to this goal. Readily available today, powder coatings, no VOCs, minimising harmful emissions and air pollutants. This not only ensures a safer working environment, but also reduces the carbon footprint associated with traditional solvent-based coatings. No waste. Our powder coatings can be reclaimed up to 100% of overspray, significantly reducing waste and promoting resource efficiency throughout the coating process. Thin film technology. By leveraging thin film technology, we enable reduced consumption per square metre, leading to lower material use and less environmental impact. Product selection. We offer a choice between polyesters and fluoropolymer coatings, allowing customers to select products that align with their sustainability goals. Polyester coatings, for example, typically have a lower carbon footprint compared to fluoropolymer coatings. For tomorrow, bio-based and recycled raw materials, improved circularity, and sustainability packaging. Apologies. And next generation low cure powders. We are developing next generation low cure powders that require low energy consumption during the curing process, further reducing the carbon footprint associated with powder coating application. By continually innovating and refining our products and processes, we are dedicated to advancing sustainability and helping our customers reduce their carbon footprint. Thank you very much. Together, we can build a more environmentally and responsible future. Thank you for your time.
Perfect timing, right on the bell. I'm curious to know whether you warrant steel to the same level as aluminium, so I might need to come find you later. So we have the last session for session 3, last presentation for session 3, porcelain cladding and unitized systems and complex geometries, presented by Bernat Miñana, the Managing Director from Frontec Australia. Welcome to the stage, Bernat.
Hi, can you hear me? Perfect. So thanks everyone for your time and attention. I appreciate being here. I'd like to acknowledge the traditional owners of the land, past, present, and emerging. And I'm going to introduce a bit what we do in Frontec. Let me check how it works. We got it. Okay, so Frontec are extruded porcelain panels made in Spain by Grupo Greco-Gres. Grupo Greco-Gres is a family business with a long tradition making ceramics dating back to 1940. For the ones that are familiar with the ceramic world in Spain, the ceramic hub is in the coast in Valencia, but we are in the center of Spain. We're near to Madrid because 80 years ago we were making bricks and tiles there, so we remain there until now. This is a bit of a presentation of our projects and our brand. This is the factory. Later, when we come to the environmental, we'll continue showing about that plant that is helping us reduce 45% of our electricity consumption. A bit of our systems and our showroom. Okay, the question we hear more often here in Australia whenever I go to make a presentation is Frontec terracotta or is Frontec ceramic? That somehow is like asking whether it is water or is moisture. So ceramic is a generic term that makes that every clay material that is put into a furnace and produces sintering is a ceramic. So the mug that you drink tea is ceramic, the cover that you have in your teeth is ceramic, and the cover of the space shuttle is ceramic, but there are different qualities of ceramic. So the quality of the ceramic under a technical point of view is defined by the quality of the sintering. Sintering means somehow melting or joining particles together in the best possible way. This is something that is not only used for ceramics. Some very hard melting metals that are very difficult to reach the point of fusion, they are grinded very thin, and combining temperature, pressure, and the minimum particle size, then you create a material that is sintered in the best possible way. So the quality of ceramic is linked to the degree of sintering. Here you have a very graphic definition of what is the sintering of the ceramic. So you will have particles, and then depending on how limited is the space in between particles, you'll have a better sintering or a lower quality sintering. So the higher is the sintering, the higher is the performance. And then we come to the water absorption. I'm sure that the ones of you that have been dealing with ceramics will have heard, oh no, this ceramic has a very low water absorption, and you think, yeah, it's good. I'm not planning to put it in the kitchen or something like this. Why is it so important? Yeah, it'll get stained. It's true that not having water absorption makes that the stain removal is much easier. But what the reason that is so widely used when we define the quality of the ceramic is because lower sintering, more water absorption, because it's a more porous material, so the water will penetrate. So when somebody's telling you how much water absorption a material has, basically is directly linked or how much space is in between the particles that you have sintered in the ceramic. So it's a very easy way. In Europe, that we have a longer tradition on ceramics, when we are trying to sell some ceramics, in English we'll classify in three terms. It's earthenware, stoneware, and porcelain. Earthenware and stoneware, in terms of the technical definition, they have a wide range. That is the range used by terracotta. You will find terracotta with 10% water absorption and terracotta that is close to porcelain. But it's a term that in ceramics we will not use. In ceramics, according to UN 14411, you have some groups. So the group A1A requires that the ceramic has a lower than 0.5 water absorption. That apart that how clean it is basically speaks that is a good sintering. And then you will have A1B, A2A, A2, and A2B. So next time that somebody tells you what kind of ceramic it is, if you want to have a technical reference, better go to the standard. Case studies. We do many projects clad on site, small residential, big residential, all kind of projects. But this afternoon, we're going to focus on unitized systems mostly and a bit on the complex geometries. This is a small dental hospital in New South Wales. The architects are Geocon and the contractor is Osiris Aluminum. And basically, it's our horizontal configuration on our proprietary system. So it's basically the simplest way of using our systems in unitized. So you have some unitized modules and the same blocks that you would glaze the glass. So in this case, you just fix our system with our tiles. If you guys get outside, you will see that we have a small mock-up with that. Not rocket science. Our systems are extremely easy, both as a configuration and for installation. So you have some top-bottom panel that is receiving the panels, and then you will have a continuous rail that will have some sliding clips. The sliding clips are quite wide. This helps us in having a huge performance, because for the facade consultants, you know that the performance of a cladding is directly linked to the surface that is clipping the ceramic and the performance of the ceramic. So we have a huge clip on a porcelain material. So basically it has a very high performance in terms of suction and resistance. Baguettes, the baguette's the same. I'm sure you all know that Australia is a very costly market for installation. So the installation is many times the money of our products. Our products are very quite price affordable. So everything made in Unitize makes the installation much faster. It's not a question of detailed installation. You can see in the pictures that the level of accuracy of the Unitize systems are very close to the levels of hand cladding on site, but definitely there's a big cost, especially in works that they need to be done in height. This project is Bondi Archibald in Bondi Junction. Is Urban Possible Can Finch were the architects, Parkview the builder, and the facade contractor is Ostec Façades. It's a vertical configuration with our proprietary system, but on their Unitize modules. You can see that in this case, there is edge protection and there are some mullions for decoration. Something that I'd like to point out that maybe is not so well known is that each one of these single panels can be replaced without a sequential movement. So you just point out what panel you want to change. The clips can be slide to both sides and the panel can be removed. I'm not going to go very deep in the technical because I only have 15 minutes here, but if any of you wants to know how it works, we have videos displaying how it works, we have examples, and it's quite easy to follow up. You can see that in the Unitize facades, there are being more and more elements incorporated. Traditionally, we're more glass units. Now you have all kinds of clip-ons, fins, accessories. They're becoming more and more complex. It's quite a good result. Then, St. Vincent Hospital is a builder lease partnership project. Kane Constructions are the builder, and CAS Façade. In this case, we share with the facade contractor our typical details, and they define the cladding solution by themselves. Frontec porcelain panels, one of the big advantages is like, imagine that you could engineer the perfect stone slab. So what would you like? That is light, so Frontec is hollow, so reduce the weight. What would you like? That it has coming with grooves and you don't need to groove every panel. Frontec panels by default come with grooves in the sides and holes in the other edges. So they are, imagine stone slabs that they are really easy to clad, so you can clad them with our system or with your system. The performance of the panel doesn't get affected by the system that you use. In this case, the architect wanted to have some triangular shapes into the facade. So you will see that porcelain panels can be cut until very sharp edges, very wedgy fillings, and the performance keeps on being quite good. There is a very low percentage of breakage during installation, and as far as the replacement is quite easy, it's something that is a win-win situation for the facade consultant, sorry, for the facade contractor, and for the owner. The final result also is quite good. This is Macquarie University student accommodation. It's maybe our most special, most iconic project in Australia up to date. It's an architect's design. FDC was the builder. Rise Aluminum was the facade contractor. We had early involvement in the project because it was a bit challenging the cladding of these areas. We somehow was a hardware competition because the architect was a bit a visionary because we produce rectangles. So because we produce rectangles, people think horizontal rectangle, vertical rectangle. But they realized that because it's a rectangle doesn't mean that you cannot cut it in any shape that you want. So the architect was the one to say, okay, good, let's go for Frontec. Then came the facade consultant. No, this cannot be done. Okay, so we show them how to put the brackets, how to install. Then came the builder. What do you have in your head? So we needed to do the visual mock-up, prepare everything. Currently, everybody is quite happy, and we have done a second project with Macquarie University. These big bulky structures, in fact, they are just shading structures. They are quite light. Everything is a galvanized frame that is fixed with a solution of subhead subseal. So all the galvanized frames came in flat stillages. So the installers will fix the subseal and the subhead. Everything goes up, down, level, tap, and then our panels are fixed with brackets, stainless steel brackets into the system. Here you have some details of the first VMU in the facade contractor place and the final result. We're quite happy about it. My previous colleague that was making the presentation helped me a lot, so I don't need to explain so much about the EPD, our Environmental Product Declaration. Frontec is as environmentally friendly as a ceramic can be. We have a huge energy reduction because our own solar plant, our own power plant in the factory. And this is the first moment that I'm gonna explain this publicly. Frontec Australia has reached a commitment, an internal commitment of planting 1 tree for every single square meter of Frontec that we sell. So whenever you put 1,000 square meters of Frontec in your facade, we will give you a certificate of the 1,000 trees that have been planted, where have been planted, and we will audit that process. The first project that we are involving is Naki Vale Refugee Camp in Uganda. Is a refugee camp of South Sudan refugees. They are living in very precarious conditions. We have to deal with the government because they don't have ownership of the land that they are occupying. So probably what we'll do is it will be a mix of trees that optimize the sequestering of carbon emissions, but we'll go also for trees that they produce fruit. So we will have both the function of carbon footprint, but also the social function that the people there can eat. Upcoming projects. So I'm just going to give you a hint of some of the projects that are coming. We'll show them in detail in the next Zak World of Façades in Sydney, but we are very proud of them. We'll try to show them even with a bit of more technical detail. So this is Dunedin Hospital in New Zealand by Warren and Mahoney. South Base is the builder, and SRG Global Façades is the facade contractor. These are very large panels, up to 3 meters in height, in a custom seismic performing configuration. We had a very successful and very enjoyable cooperation with SRG. They defined some modules that they need to perform with inter-slab movement of plus minus 25 millimeters, and they have been tested for impact resistance so that they are compliant with the big requirements in New Zealand. Next time we meet, guys, we'll show you many more details. This is the first Zak World of Façades for us, and we're doing our best in the 15 minutes. The ring's gonna sound fast. 33 Alfred Street, Johnton Pilcon Worker. The builder is Bill, the facade contractor is Osted Façades. It's a very small format. For the ones of you that are very familiar with modules, all of that is unitized. But please, any of you can see the joint in between the modules. So the thing is that they had to expand a bit the joint in between the tiles so that the expansion joint in between modules was not so visible. They developed, we like to perform as consultants for the facade companies. We don't know about facades, we know about our system. We know our tiles, what we can do and what we cannot do. So it's a project that we'll show you more details next time. We're pretty proud about it. The last project we're going to show today is Frankston Hospital. It's a Batesmart project, Lend-Lease the builder, again SRG. They're getting too much jobs, I think, but yeah. And it's a SRG design unitized modules combining both horizontal and vertical configurations. Again, we are very happy because, you know, engaging with facade contractors sometimes not so easy. They're happy, we're happy. So I hope that we can cooperate many more times. So I got still 18 seconds, so thank you very much to all of you for your attention. I hope I didn't make it very boring and my Spanglish was understandable. Hope to see you all again soon. Thank you very much.
Thanks, Bernat. I'm glad you clarified the definition of ceramic versus terracotta and porcelain. So, we're about to head to another networking break. Thanks, everybody. Okay, I think we might get started just so we can keep the conference on track. So the first presentation for session 4 will be design integration using parametric workflows. And I'd like to introduce to the stage from AECOM, Zak Hankin and Kenneth Chen. Please welcome to the stage.
So I'm Zak Hankin, Associate Director with AECOM, and as mentioned, we're talking about digital integration using parametric workflows, and we're basically using Melbourne Quarter Tower as the case study on this, and how the digital approach actually led to elevating safety in the solution that was provided, quality, and also design coordination improvements. So I'll run through a bit of an overview around all the companies that are involved, what the project achieves, the timeline that we've gone over, because it's been a number of years, and then some constraints around the site. I'll then mention about the roof form developed, the approach we took in coming to the design solution, and then moving into effectively the modular aspect to it and the computational design, so the parametric side of things. In terms of the design team, it's a Lend-Lease project, so developer and the building contractor are Lend-Lease. The architect is Woods Bagot. Now, in terms of services consultant, electrical and mechanical being quite a big thing in this roof, being able to fit smoke exhaust elements within the modules that were created. Services consultants, so hydraulics, fire protection, again, hydraulics a big part in the roof structure, and us acting as structural and acoustics. In terms of the construction team, it was a collaborative effort by obviously the building contractor, the steel fabricator, Arc Structural, shop detail, Planet Design, as well as the roofing contractor and skylight contractor. So with the approach that was taken, there was a lot of work done off-site with all parties involved prior to actually being delivered to site. Just in terms of the project, aiming for 6-star Green Star. It's a commercial tower, so large commercial office space, but also included some retail space down at the podium level. In terms of the project timeline, it really started quite a fair time ago, back in 2018, and it's only reached completion this year. So part of that was due to the project going on hold. COVID hit. So we'd just finished foundations, project went on hold, and it took quite a fair time before we actually started up again. In terms of this site, there are a number of constraints. As you can see here, we're working against rail, so no ability to effectively use that space for installation of the roof panels. We're interfacing with the aged building. We've also got the existing Sky Park, which we also need to extend, and we're building over road. So a lot of constraints that we're dealing with, which is why we went heavily down a modular approach. In terms of the roof form developed, the very first concepts of the job was rectangular, as you can see, but through town planning, the shadow line basically looked at cutting through a part of the building. And so in order to meet that requirement, the building actually grew out just slightly, as well as extending up. So the final roof basically followed this sweeping curve, wrapping down. And so in terms of what we obviously had that solar, the mass line that we couldn't go above, which was really highlighting a constraint. But in addition to that, to get the job working, we had to still meet the same NLA requirement underneath. And so we were pushing the floor areas as much as possible, which meant from a ceiling point of view, we basically had a defined sandwich that we could fit everything in terms of the roof structure. Just a bit about the process. Effectively went through all steps running around. So the base case was developed. We then went through thorough reviews. We had a whole series of collaboration workshops, and that's also with people out in the market. Came up with alternative concepts, assessed all the options, ranked them, and then beyond that, on selecting the preferred option, resolved all remaining coordination items and finalised the design. In terms of the key workshop that we had, there was pretty much 4 main ones through that process, focusing on different aspects. So roof and plant structure, the plant is right up the top and squeezed in, so a lot of heavy workshops and trying to get everything to fit in that. Working through the models, particularly with the BMU, and also mechanical and hydraulics and services within those plant areas. We also went to the market and got early engagement with roofing contractors and steelwork contractors, particularly with the solutions that we're trying to propose and work through, and obviously went through with the client group in order to present those options and select the preferred one. So running through a couple of the options, the first is effectively the base case on the left, which is really a stick frame type of build, lots of elements to build up in the air, a lot of time on the cranes, not really the preferred option, obviously not as safe, having people working at heights at the top of a tower. We then, looking through a more rationalised form, this was still stick built, but could achieve the requirement with a little less steel. But really where we sort of landed on was trying to go through the modular approach. And so dividing the roof into a series of modules, which were about 3.5 metres by 12 metres long, typically. And so they could be transported at once. And with that module pattern, holding all the structural steelwork, all the cladding, all the services, all fabricated off-site and coming as one unit and installed in place. Overall, we assessed all the options, and really the one with the modular stacked up for a number of options, but constructability, the number of different unique module types that are required, the overall steel tonnage, and also having that safer aspect without having people working at heights. So I've sort of mentioned a few of these already. Obviously modular and being constructed off-site, a better quality control that you can have in a controlled environment. Safety, obviously no people or less people working at heights, and also having the ability to have these modules installed with barriers before it's even lifted in place. And given the site constraints, less requirement to assemble parts on site and reducing the amount of time on the cranes. In terms of the complexities of the roof, the actual roof build-up that we needed to meet the requirements for an office, and so the acoustic build-up was quite substantial, consisting of a structural liner, a suspending element, followed by a dense board, insulation spaces for an air cavity, more insulation, more spaces, and the final cladding on top. So doing that up on the roof piecemeal would be near impossible, and having that all done down at ground level was the preferred solution. Also, with the office, this roof actually connected 7 levels altogether, and so that needed to be divided with internal partitions. And with those internal partitions, we had to basically deal with the roof movements with structural steel penetrating through these walls. So with that, we developed effectively a green bulkhead that was fixed with the roof, so that all the sealing around all the elements that penetrated that was effective, but still being able to get the movement required in the yellow zone that you can see there, and structure running through the middle of that to restrain those partitions below. So quite a complex detail overall. We also had a large BMU, which ran down the central part of the roof. And so that needed to be fit on and dealt with the modules and coordinated for all its clearances. And you can kind of see there on the right the final sort of position and track that runs down the centre of the roof. As I mentioned before, services was a big aspect, so we had large smoke exhaust elements to be incorporated within the modules, as well as different service wells for hydraulics. And then major feature of this roof was obviously the skylight, so getting that light penetration through to the office environment. So that's sort of showing, you know, in terms of these modules, we had steelwork, roofing contractor, glazing contractor, all working together to assemble those elements prior to delivery. I'll just show, so number of skylights around the roof and plenty of smoke exhaust at various aspects. Might pass over to Ken now.
Yep.
To run through the computational design parametric.
Thank you. So the parametric workflows that we used helped us create a centralized definition to create documentation models and analysis models. The models were generated mathematically, so a series of rules rather than manual positioning and CAD drawings. By having this mathematical procedure, it allowed us to make adjustments on a holistic scale without having to redo every detail to update anything. The softwares we used were Rhino and Grasshopper as the main scripting, and that fed into Spacecast through the use of Geometry Gym. And we also use Rhino inside Revit to create the Revit documentation model. On the top left, top right, that's the Revit model, and then on the bottom model is the Spacecast model. There are some abstractions that needed to be made for the analysis model. Typically, they're simplified versions of the documentation model, whereas the documentation model needed to incorporate the details of member sizes and offsets due to member thickness, width, height, to model physically the location of the model of the members, such that it could be later used as the basis for shop drawings. It was also important that the positioning were correct so that for coordination purposes, we could do clash detection, such as with facade, bulkheads, and other services. The overall geometry is defined by a series of overlapping circles and grid lines. Those circles and grids were then projected to the twisted roof plane. And with various offsets and subdivisions of lines, we create the BMU truss structure, which is the central spine that you see there. This is an overview of the key cladding panel geometries. Now, because the roof is a curved geometry and construction generally blends itself better to planar geometries, there were a series of rationalizations undertaken to simplify the roof geometry so that it would be more constructible. The roof consists mostly of two reference planes. One was the top cladding surface, and the other was for the structural top of primary steel surface. These two surfaces are not identical and they're not parallel. The differences between the two surfaces are accommodated by purlin offsets. Here are a few examples of how we create those reference surfaces.
they are mostly procedural geometry created by reference points. And then it also involved creating several working planes to define offsets and cladding thicknesses. On the bottom right, you'll see how the cladding thickness actually causes a misalignment with the grid line. And as you change the cladding thickness, this offset changes, which then triggers a lot of steel member dimensions to be changed. Doing this manually would take a very long time, even for any minor changes. So that's why having it parametrically scripted sped up the process. The creation of the prefabricated modules were created similarly with several subdivisions of lines and alignments of geometry. This also allowed us to iterate several options to get the glazing to its maximum size and iterate on the symmetry of the roof. Here is the overall structural model. Here's a zoom in of the prefabricated modules. You can see the purlin layer is slightly above the structural layer, and might not be that obvious, but there are variations in that gap, which was captured in the models. And here is the shop drawing model, which is quite similar to our documentation model. That helped us to eliminate as many coordination issues as possible earlier on before getting to the shop drawing model phase. Here's a construction photo of one of the modules. So the primary steel work with the purlins, and the triangle there is one of the smaller skylights. This is the cladding layer on top of it. A couple standoffs to create the cavity between the panels, the acoustic gap. The prefabricated modules were also pre-assembled at the factory, and that helped us to identify fitting issues earlier on, and it also allowed them to check that everything fit together before bringing it to site.
Just in that, you can also see effectively the limited amounts that had to be done on site. Obviously, the join between the modules had to have people on site doing that, but the rest of it was already done off-site.
This one lets you see the sense of scale for one of the bays. There was actually an event, Lend-Lease told me that over a weekend, someone had reported that the roof had collapsed, but it turned out to be because it was in partial construction and so steep. Someone reported that the tower roof had collapsed. On the right is one of the modules. This one's actually for the BMU truss that's been installed. You can see in this photo on the perimeter, there's a balustrade. As part of the modules, the balustrade comes pre-installed. And so as a safety and design element, it doesn't require people to then climb up on the roof to install the balustrades. A couple of views from the interior. Fit out of the internal spaces were done after the prefabricated modules were installed. And here's a view from South Bank. Thank you.
Thank you.
Thank you, Zach and Kenneth, for your presentation on what looks to be a very complex roof, but it's on a pretty steep incline, so is it a roof or a facade? I think we always debate that one. So the next presentation we have is on engineering, supply and assembly of bespoke building envelopes by Aitor Llorente, the area manager of LANIC. Thanks, Aitor.
Hello, everyone. Thank you for your time. I'm going to speak about LANIC. My name is Aitor, and LANIC is a Spanish company established nearly 50 years ago. During this period of time, we have completed a lot of complex projects, and we have gathered a lot of experience dealing with these complex projects, not only from the technical point of view, but also from the project management point of view, very tight deadlines. So we have gathered this knowledge that we would like to make use, hopefully by undertaking similar projects here in Australia. What we understand by bespoke envelopes is those ones which are, let's say, non-standard, that they have maybe free forms, curvatures, long spans, wherever that make them be non-standard, like also maybe with unusual cladding materials or unusual structural materials. Another relevant asset of LANIC is that we are a one-stop shop company, meaning that we have the capabilities to undertake all the project phases. We've got, on the one hand, our in-house engineering department that would be happy assisting yourselves, the architects and the engineers during the design phase. And as I've said, as we are capable of undertaking all the project phases, we may identify some issues related to transport or constructability that would be very interested to be identified at these early stages in order to address them properly and in order to have later a smooth project. It is also very important to underline that we've got a very strong project management skills. We have completed really challenging projects, for example, in the Middle East area. And it is very important because these technical, complicated facades and envelopes usually are prone to be also complicated from the project management point of view. In a lot of times, there are changes, a lot of stakeholders, a lot of changes because a lot of different inputs. And it's very important to get to tackle all these changes in the best manner in order to avoid disruption in the project. We've got our own factory in which we manufacture some structural elements. Some others we may outsource its manufacturing outside LANIC, and the very same thing for the cladding. We outsource its manufacturing to specialist companies. And as I've said, being a one-stop shop company, we also take charge of the assembly of the project. As I've said before, we are a Spanish company, but we operate all over the world. In fact, a vast majority of our turnover comes from abroad and not from Spain. That's really interesting because we gather a lot of know-how by dealing with clients here and there, different ways of working, and this expertise can be exported to some other projects. And we have completed several projects here in Australia, like, for example, this one down the street here in Collins Street in Melbourne CBD. We did this one designed by Boots Bagot and ACOM. The main contractor was built. Another project in New South Wales. This is Newcastle Interchange Station with Lane O'Rourke. This is a very nice and very fun of project in Adelaide, Burnside Village, a free-form glazed structure designed by Bakan Group, Arab, Hansen Janken. And this is a project I think that you are very familiar with. This is the Westgate Tunnel, and in this case we are doing the steel structure underneath these aluminum panels. What we proposed, the main issue with this structure is that this facade has a quite complicated geometry because it has double curvature all over its surface. So in order not to have any problem with tolerances, not matching properly the cladding with the structure, or having a very complicated substructure, we proposed a structure made out with a fully prefabricated structural elements in our factory with computer control machines. So we know that every structural element is going to fit properly, and the tolerances are going to be despicable, are going to be next to 0. We know that the tolerances in every given aluminum panel are going to be in the region of the tenths of a millimeter. So we get rid of this risk of cladding not matching properly with the structure. I will show you some other projects that we have completed in the past all over the world, so you can understand our capabilities. This is so far this is just a sketch. This was an auditorium, part of a larger scheme, an aquarium in Brazil. The architect was a quite famous architect in Brazil at the time, Mr. Rui Otake. And this sketch was all there was related to this project when Mr. Otake contacted us. He wanted to build this. This was meant to be his last grand project. Mr. Otake was already in his 70s when he designed that. And for him, this was meant to be his legacy to Brazilian architecture. I say this, he was really strict when it comes to aesthetics. So we assisted Mr. Otake throughout all the design process. Then there was a tender, and we were awarded with the supply and install of the project. In some other cases, we assist the engineers and the architects, and other companies awarded with the project. But in that case, we did all the project phases. As you can see, there are some zinc panels at the ends of the structure. There is a quite large glazed skylight in the center, and there are some steel beams cladded with aluminum, painted in red, on top of the glazed skylight, and also at the bottom. Also, you can see that the radius of curvature at some parts of the building are quite small, so we had to be very careful with facetation in order to avoid facetation, as you can see here. All these structural elements, the structure underneath, the zinc panels, the glazed skylight, and the beams are working all together and behaving as a traction ring, so the dimensioning of the structural element is very efficient. The depth of the structure underneath the zinc panels is very reduced. You can see also that the depth of these rectangular hollow section bars that form the skylight is very reduced. Also, it's just 100 millimeters and 60 millimeters wide. The beams are much more bulky, but that was just because of the wish of the architect, because of aesthetics. You may notice also that the section of the beams is not standard. It has this angle, it's twisted, again because of aesthetics. And as I've said, in order to avoid facetation, we had to break down these red steel ribs into a lot of small segments. There are more than 600 unique segments. And in order to avoid facetation in the cladded area, we had to use 3 layers of substructure, 3 layers of purlins. The first one that is depicted here, if you may notice, it's made of curved purlins. They are not flat ones, so imagine the huge number of different elements. The second layer is perpendicular to this one, and again it has curvature. And the third one is standard straight purlins. So this is the final outcome of the building, which is quite similar to the design intent. And I must say that Mr. Rui Otake was very satisfied and very happy with the outcome. So are we. This is another project we are undertaking right now. This is an airport in Central America, and we are assisting the Mexican architect in charge of it. This has a quite long span, more than 60 meters, with double curvature. And the cladding is made out of more than 1,000 different pyramids that you can see here. All of the pyramids, they've got different sizing because of the geometry of the roof, ranging from 1.5 meters up to 2 meters. And it's important also to notice that there is no any metal base at the bottom of the pyramid. It's just these 4 sides of the pyramid that vest all the performance of the building, meaning that these sites must take charge of the weatherproofness, acoustics, thermal, everything. Some of the sites are going to be glazed, some other ones are going to be opaque with different surface treatments. Some of them are going to have kind of a mirror effect. And again, it is very important, since there is no any base, any metal or any material at the base of the pyramid, the way in which these pyramids are fitted into this main structure is key. So we would use, or we are proposing to use, a very accurate prefabricated structural elements. This is another project in which, as you may see, there is no any right angle all over the surface of this facade. This is quite the opposite, or is not similar to one standard curtain wall. So our experience was highly valued and paid off in this project. This is some arenas built for 2016 Olympics in Brazil. We undertook the second skin facade made up of nearly 300 different glulam louvers that you can see here, ranging from 7 meters up to 15 meters. And there is the cladding is an expanded metal mesh. This is another very interesting project in Russia. This is a stadium which has more than 20,000 square meters. As you can see, the section of this facade is evolving all over its perimeter. In this central part, we've got the section is, this is single curvature, and here we've got double curvature at the end, so the section is evolving all over its perimeter. So imagine the vast amount of different structural and cladding elements in order to replicate this geometry faithfully and to vest waterproofness to it. You can see that it is quite challenging to outsource the manufacturing, to gather the materials, to transport and to sort them out in an efficient manner, all these 20,000 square meters, in order to complete the project successfully. Just as an example, the purlins in which the polycarbonate triangles are sitting, they've got all of them different orientation in order to replicate this curvature. So as these purlins have, as these polycarbonate triangles have different orientations, so they must have accordingly the purlins underneath, and the purlins are sitting on these wings, on these purling stools that you can see here. So each wing has a different twisted angle. So imagine the huge number of different structural elements that needed to be taken into consideration properly. Just to finish, because I have just 2 minutes left, 2 more projects which are not so daunting, not so big. It may seem that we are just interested, or we are just doing this kind of big projects like a stadium or whatever, but we are also doing, we have to make a living, and we also do some more smaller projects and down-to-earth projects, like for example this tensile structure, which is, let's say, much more smaller, just less than 600 square meters, a free-form tensile structure. Or again, this even smaller glass glazed canopy, nearly 250 square meters in front, which has a quite clever and elegant hidden connection between the steel and the glass. And this is pretty much what I wanted to show you. I would like also to address the fact that we are quite flexible when it comes to dealing with yourselves, relating the scope of works or the way we are assisting yourselves, providing this cost analysis, lead times, wherever you may need, in a lot of cases in a very friendly manner and non, let's say, formal manner. Just drop us a line and we will tell you, we would try to clarify your doubts. In some other occasions in a very much more formal manner. The very same thing with the main contractors. We always look for the most efficient and optimized approach to the project. So for example, in some cases it may make sense that the cladding is provided by a local company because it's more cost effective. We always look for the most reasonable solution for the project. As I've said, I'm based in Spain, but I come to Australia quite often. You've got our email there. We've got a stand down there, so please pass by if you want to get my business card. And I'm going to be this time in Melbourne until next Wednesday. So if some of you would like to, it would be my pleasure to pay you a visit tomorrow or Monday or whatever, because it's also very interesting for me to learn which are your needs in order to try to adapt ourselves to your needs, how usually you work with this kind of specialist companies, because at the end of the day, we would like to have a fruitful relationship. And I think I'm out of time. Thank you very much.
Thanks, Aitor. Good to know that Lanex's a one-stop shop. I know we can all appreciate that for a smooth program. I've also been reminded that there's networking drinks at the end of the day, so please do stick around. I know I'm hanging out for one, so please stay around and have a chat and catch up. So I'm also going to try and encourage the people loitering outside to come in for the final panel. I know you can hear me. Last but not least, we have the final panel of the day, present issues facing the facade industry. And I'm going to bring up the moderator, Nick Roach, Associate Principal at Arup, and the panel to start the presentation.
Fantastic. Now, there's going to be a little bit of, because everybody's getting sleepy at this end of the day, and we don't want you to fall asleep, there's going to be a little bit of crowd participation pending my ability to work the technology. So, perhaps if you haven't, there's not much good phone reception in here, so if you want to participate, maybe join the Wi-Fi, which, has everyone joined the Wi-Fi? If you haven't, the network is called Sofitel Events, and the password is SMOCEVENTS. SMOC Events. There we go. Well, fantastic. Well done. You guys are great. Okay, just in case you want to participate. Okay, I'll leave that there for a second. So, g'day, my name's Nick Roach from Arup. Bonjour. All of the Sofitel people today have been saying bonjour. From where I'm from South Australia. The way that the Ghana people in South Australia welcome you, they say Nina Mani, which literally translates to are you fat? Are you well? To which the common response is Mani I. So, Nina Mani. Of course, we're gathered here not on Ghana land, but the traditional people's lands of this area. And today we're going to talk about present issues facing the facade industry. Okay. First, though, I'd just like to introduce the panel. So we've got on our panel today me. I'm not on the panel, though. I'm just the one asking the questions. There's Rob Buck. So Rob, put your hand up, Rob, so that everybody can see you. So Rob is a facade consultant at Arup. So what we've tried to do is assemble a panel today of varied individuals, much like the WT partnership presentation at the beginning with the diagram of the tree and how the project manager wanted it, how the builder wanted it, how the facade or the engineer imagined it. We've got a facade consultant, architect, builder, and building surveyor or regulator. And so the facade consultant is Rob. So Rob leads the facade team, the Arup facade team in Victoria, and he brings a holistic approach to facade engineering, which is built on 20 years within the industry before he transitioned to becoming a consultant. Rob's delivered many different projects of various sizes across the world, ranging from high-spec facades to private homes, to World Cup stadiums and most types in between. Rob has recently moved to Melbourne with Arup from the UK, with his UK experience giving him an understanding of how Europe approaches challenges of climate change and ramifications in the industry following the Grenfell disaster. Second, we've got Natalie Rashidi. So Natalie's our architect on the panel today from Hassel, an associate architect who's got over 12 years of industry experience specialising in the delivery of complex building typologies in the health, education and institutional sectors, with a demonstrated history of managing projects from concept through to construction. She's led notable developments including the Eye and Ear Hospital redevelopment and the new Mount Barker Hospital in South Australia. Natalie is passionate about clients and stakeholder management, ensuring all project requirements are met while fostering strong and collaborative relationships, which is what I like to hear. Next, we've got Andrew Ciolini. Did I pronounce your last name right? Thank you, Andrew. So Andrew is a highly respected industry leader with over 35 years of experience in the construction industry, spanning private enterprise, public service and state government operations. He's the former State Building Surveyor of Victoria and currently serves as the priority lead for building surveyor resourcing at the VBA, the Victorian Building Authority. Andrew's experience includes 9 years as a structural design engineer and over 25 years as a building surveyor, managing compliance risks on major and complex projects. And last but not least, we've got Vincent Rikiki, sorry. He's our contractor on the board, on the panel, from Bessex Watpac, with over 20 years of experience in the construction industry. Vincent has worked with Tier 1 contractors, including Abbey Group, CPB, ProBuild, and now B6 Watpac as their design leader in Victoria and South Australia. Vince has worked on key projects, including the Regional Rail Packagee, Post-Entry Quarantine Facility, Victoria Police HQ, CSL Global HQ, CSL Banksia Vaccine Manufacturing Facility, and GWF Flour Processing Facility in Ballarat. So basically, if it's a project with acronyms in the name, Vince has done it. Vincent oversees the design management group in Bessex Watpac and ensures the highest level of rigour is applied to the way the business manages the design process. So, that's your panel. Thank you very much for joining us today. I'll take a seat. What we're going to do is we're going to try and now engage a little bit of crowd participation. Firstly, I think if I've got the control. There we go. What we're going to do is, if you've got questions for the panel, you can ask them, and all you have to do is log it through the Slido. And of course, at the very end, if I just allow it to be open. Yep, so you can ask me questions, and in theory, they'll pop up here on the screen. And if you like that question, you can vote it up. And if I like the question, I'll ask it. Okay, so yeah, jump onto Slido, use the QR, and you can start asking or getting your questions ready for the panel, which I'll ask at the very end. And if for some reason you can't get the technology to work, ask your friend. If that doesn't work, then please put your hand up and we can do a roving mic at the very end. Okay, so what we're going to discuss today is 3 questions, well, 3 sort of vague topics. We might stray a little bit off topic depending on what we want to talk about. But firstly, we're going to do this question, and this is a question for the crowd, and it leads into our first topic, and that is in novated design and construct or D&C projects, should the facade consultant be novated to the contractor? So jump onto Slido and answer that, and we can see the live, if it's working. If anyone's actually on it, then we'll have that there. But maybe what I'll do is, while people are attempting to do that, I'll start to talk to the panel. Rob, from the perspective of a facade consultant, what do you prefer and why?
Retained by the client.
So why is that? Why is that better, do you think?
To be honest with you, I'm mixed-minded about this. So I think I come from a design background, so I always like to get involved with design and solving problems, with real problems and real solutions. And I think you can only ever do that when you're with the contractor. I think otherwise you're just doing a policing role, and that's not a lot of fun. So personally, I enjoy working with the contractor, but I do understand that you're then under constraints. You may be limited about what that contractor can offer the client, and that may be putting you into conflict. And so you end up in this situation where the client retains a consultant, and then the contractor has a consultant, so that you can combine those 2 issues. Ideally, you're in a position with your contractor colleagues, and you work collaboratively, and they understand the value of the advice you're giving. and that you work with them to understand what are the key things that they need to do right. And generally, they understand those. And everyone wants to do a good job, and they want to walk away from that job knowing they have done a good job. And it could work really well, and I've seen it work really well.
Yeah. So have you worked on projects before where you were novated to the contractor, but then the client kind of approaches you directly and thinks that they can still do that? Has that happened?
Yeah, of course. And at the end of the day, there's a specification that's been accepted by the contractor, and that's what the contractor has accepted. So, there's always going to be nuances of how that the specification is interpreted. But you're playing a game whereby you have to achieve the desires of both your masters. At the end of the day, when the person who's paying you is your master, and obviously by the nature of you being on the contractor side of things, that tends to force your hand.
Yep. Well, this is a good segue into asking the contractor in the room. Vince, what do you think? Do you prefer having facade contractors under you, or are they just a pesky consultant that you wish you could relegate back to the client?
No, we'd prefer to have a consultant on our side novated to us, especially early on in the design phase. So, similar to what you were saying, we like to sort of be in control of the process of the level of design, the completeness of the design, and we normally have facade contractors engaged early. So that way, if we've got the facade consultant novated, we can work together, work through design solutions, work with you to firm up some of the more critical details, the bespoke details, and always with a sight on the budget and the program and safety and quality. So we like to have the consultant on our side, so we can at least have that bit more of control up front, go through a bit of the pain early with value management, as it always comes up, variations, sample reviews and approvals, and optioneering. But normally the way we like to do it is to collaborate early, and that way if the consultant's working with us and I suppose contracted by us, there's a bit more control by the contractor.
Yep. So you don't sort of see the consultant kind of getting in the way, and you just want to just get them out the way and go and build. You just let the facade subby get on with it.
No, we generally don't, because look, and I can't talk for all builders, but normally we understand that the architect, the facade consultant, has been on the journey for potentially 2-3 years with the client through planning. We accept there's probably some level of importance when it comes to certain facade types, certain setbacks, certain promises that have been made. So we try to work within the confines of that. So we prefer to work with the consultant. Obviously, our facade contractor is a big part of that, because they hold the key to the program, the budget, to safety and quality. But I tend to think that we can make it work.
Yep. Maybe I'll just follow on to Natalie. Quite often we do get, as consultants, facade consultants, we get engaged directly by the architect. Sometimes you don't get to choose; we're imposed upon you by the client. Do you prefer to have facade consultants engaged under you, or are you happy for them to be engaged directly to the client? Does it matter to you?
Yeah, I think it's kind of much of a muchness sometimes. Like, there's pros and cons of both situations. Ideally, obviously, if you're under us, or the facade consultant's under us, we have a lot of, I guess we can coordinate with them a lot more in more detail, so we have more control over the design. That's kind of the position that the architect wants to ultimately be in. But I can see the positives of also them being under the contractor, especially because when you're delivering or constructing a facade and then having that input in that process as well. So I think it can work in either way. There's just pros and cons in both situations.
Yep.
Yeah.
I think it's one of those things, when it works well, it works. It's when it's a situation where maybe the project's been underpriced and things have got to be challenged, and program is late, then being under the contractor your advice maybe is not taken with the same level of acceptance as all these other constraints. And then it becomes a problem whereby you're asked to sign things off at the end because things have been produced that you wouldn't have signed up to during the process.
Yep.
Whereas if you were client side and you were the policing role, then you couldn't go ahead.
Yep. That's a good segue onto another question I want to ask you, Vince, and that's about design and construct contracts. So as a consultant in the past, I've come across situations where a client has decided that they want a traditional contract, or a managing contract, so not design and construct, but then there might be elements of design and construct that's required to be completed as part of that. And Façade is quite often it's a common trade, which is design and construct with a performance specification. How do you manage that?
So I think a lot of the time, it's not easy. Like, you've generally got a design that's been progressed to a construct, fairly complete, whether it's IFC or just prior to IFC. And then there's a note in the contract that says, though, the Façade is design and construct. So it's difficult because, we bring on our contractors, they design their solution. It doesn't always fit into the footprint of the building. We might find that our solution requires a thicker wall section, or is heavier, or something else, and then that requires then interaction back with the architect, with the client, to say, well, potentially NLA or floor areas are going to be impacted. So there is a bit of, we can't just come in expecting to just provide a design and construct solution on the Façade without thinking about the bigger picture, because it's just not going to fit in. So that's one of the difficulties. And then it's also the fact that, similar to what I said earlier, the design team's been designing this facility for such a long time, worked through the brief, provide a compliant design, and then we have to make sure we're aware of what all those requirements are. So our subcontractor comes along and meets those thermal, acoustic, security requirements in whatever they provide. So it's a management thing. It's being just aware of, what we've inherited and what the peculiarities are with the brief, and making sure we adopt those in our design.
I might move on to F3P1 performance solution reports. And this is a good way to weave Andrew into the discussion from the VBA. It's very good having a VBA representative in the room. So if you do want to ask questions of Andrew, please jump onto the Slido and start, hammering Andrew with questions that you want to ask him. But I'm going to ask one first, Andrew, and that is, in your role at the VBA, do you review F3P1 reports? Is that something that someone else does at the VBA, or is it something that you generally leave to private certifiers themselves?
Yeah, so me personally, no, I don't. We do have a team of building audit that basically reviews building permits, so it's an oversight function. It's not every permit, and it's really risk-based around where we see the risks lie. Currently, it is more across the board compliance check, but that's becoming more risk-based as well. So rather than looking at all documentational items, it will be basically becoming more focused on various areas. Generally, for weatherproofing, it's been more a high-level check of, is there a performance solution, and not really interrogating the performance solution itself. But that's something we're starting to evolve. So I think I've been with the VBA 5 years, and from a technical aspect, fairly limited. So we've really looked at how we can build up the ability and capability of the regulator to provide that oversight. So now we've got structural engineers, fire engineers, mechanical engineers within our team. And so that now allows us to sort of look at designs more closely and see how they're being undertaken and whether there are issues, and how we look at educating industry around what's not being done right and how to do it right, and look at regulation and the framework to actually ensure that it's getting done appropriately.
For perhaps the remaining members of the panel, have you seen various approaches to F3P1 reports? Have you? I mean, you probably would have authored a few.
Yeah.
Yeah.
It does tend to vary, and
does everyone know what an F3P1 report is? Sorry, I should have explained that. We've just gone straight into bizarre facade terminology. So F3P1 is in the new building code. It's a performance requirement which relates to buildings being weather tight. And because there's no easy sort of deemed to satisfy solutions, there's a few. Building surveyors are now requesting that some other consultant validate that performance requirement is being met for the building, and that's done through performance solution reports. And what I was just asking Rob is, because it's new to the industry, we're seeing a little bit of variance in that, I think. And you were saying, before I rudely interrupted.
Yeah, I was saying that not all the time you see the performance solution report at detailed design stage. You know, sometimes it just carries all the way through, and then it's up to the contractor and their contractors or facade contractors on site to provide the certification. I think it's becoming more apparent that that's part of a role that needs to be undertaken. It's something that as facade engineers we've offered as an option, and it's only recently it's been taken up. There's a bit of uncertainty. You know, obviously we can offer that design stage F3P1 in terms of the fundamentals and how it works in principle. It's then incumbent of the contractor and their facade contractor to take on board those principles and design to that, and then provide their own report plus a certification. And I have seen an example where the original performance solution has been completely ignored. And
right. Yeah. Well, I've seen quite a bit of variance in it myself, and at one end of the spectrum, just a tick and flick exercise, and at the other end of the spectrum, a very detailed, in-depth, multi-stage architectural document review. The thing that I'm interested to understand, though, and from the VBA's perspective, perhaps Andrew, there is, of course, the professional engineers. I'm going to get the terminology wrong. I don't think is there a Professional Engineers Act? I might be getting that wrong.
Registration.
The registration requirement.
Yep.
Yeah. And there are different types of engineers that are required to be registered. So you've got structural engineer, mechanical engineer, fire engineer, and then of course there's an architectural registration process. But there's not really a facade. A facade registration of any kind. So who should be doing these reports?
Yeah, I think that's something you're alluding to, and something that Elissa mentioned in her presentation, that in terms of signing off these reports, even at the design stage, the performance-based stage, you have to be it says you have to state your registered engineer accreditation. And that's usually, and it could be a civil engineer, it could be a structural engineer, which it then provides a little bit of a mockery, because you may have an architect that spent 20 years in the business, not formally being able to sign it off.
It's an interesting one, because I suppose many years ago, before there were facade engineers and consultants, architects drew everything and knew how to waterproof, make waterproof or weather-tight designs. And so, it's, as far as I understand it, and Andrew, correct me if I'm wrong, but it's at the building certifier's discretion who they think is a qualified professional to make these performance solution reports.
Yeah, that's correct. And I think a lot of the stuff that we're talking about is probably symptomatic of performance solutions, full stop. So weatherproofing is one performance solution area. We're getting lots of reports. So there's been a greater emphasis on the process for performance solutions over the last 2 or 3 years. So the ABCB, the Australian Building Codes Board, have really sort of provided more guidance and more structure around that within the building code itself. But there's been a few growing pains around trying to actually implement it. And so then that's, invariably it comes through the building surveyors. So it's the building surveyors picking it up and asking for those, and then that sort of filters down to everyone else in the chain. Whereas it would be better if we had the education piece, everyone went along for the journey. But I think that consistency piece is the real key, that we've got an issue right across the board of what building surveyors are expecting and accepting. So there's some more work to be done in that space, and that definitely applies in the weatherproofing, because I think that's further behind in the process for the performance. So things like fire performance we've been doing for a long time, and getting more skilled and people understand that. But it's now venturing into all these other areas, and those questions are being asked now. Well, who's responsible for that? If you've got a registered party, quite easy, and it is back to the building surveyor for them to make an assessment of who's appropriately qualified, and that puts them, I think, under unfair pressure and scrutiny, because do they go through their CVs and look at it all, and then they're almost becoming a registration body on an individual basis, where they're actually having to have a look at individuals and say yes, you're okay. They have other options too. So if they don't feel confident, they can look at peer reviews and certification. So they basically get someone else to actually look at it and determine either do they have enough experience, or I'm going to review it myself and sort of say that that's okay.
It's an interesting topic of discussion, because going back to Oliver Ng's presentation, I picked up a statistic. Is Oliver still here? From BG? About 70% of building issues being relating to weather tightness, or 70% relating to the facades, and then 70% of those relating to weather tightness. So that strikes me as being the major concern of the building industry is weather tightness, but we don't have any qualifications or regulations around it. So basically what could happen, really, is anyone can call themselves a facade consultant, convince a building surveyor that they can write a F3P1 report, hand it to that building surveyor. It might be a tick and flick exercise. They might get a few dollars from it, but I don't know if we've gotten anything better, any better outcome for the building industry out of that. Would anybody like to further comment on that?
I think from our point of view, we want to try to manage our risk. So we do engage like an RF to produce the F3P1 report and sign off. A lot of the time we're building complex facades with 10, 15 different facade types, and to bring all our contractors together, we'd rather pay a consultant to help us confirm or provide their view that we have actually achieved a weather-tight facade. So the preference from us, from a risk point of view, is to engage someone who's, I suppose, accredited or has the experience, maybe not registered, but at least, it's better than, I suppose, a contractor trying to bring all these different facade types together and provide some sort of sign-off. So that's what we'd prefer, and that's what we'd, we'll try to keep doing.
And as a facade consultant, we're happy to do that part of the work. It's generally best if we were involved at the early part of the stage as well, so we're not asked to accept something that we probably wouldn't have gone down the route in the first place. As with everything, you're usually tied to a price and a number of visits, and that limits in terms of what you can sign off. And so unless there's some really heavy caveats saying these are the only spaces I witnessed, you then need to work with the contractor and have, if you've got a facade package manager that also is qualified in facades, that spends more time, or God forbid, a clerk of works that goes around and takes responsibility for those elements, and you work with that clerk of works on a regular basis, so that you understand, and he highlights this is a particular unusual detail. You need to get down here and check this out.
Yep. It's a good point. So the F3P1 reporting process, or it's really a design phase element, isn't it? And so we might do it really well and get the design right, but then it's over to you and your team, Vincent,
to get it right. That's right. Yeah,
to get it right, which is an excellent segue to our next topic. If I can get the clicker to work. There we go. Contractual responsibilities. Who is actually responsible for weatherproofing the interface? And before we jump into it, I just thought I'd show an example of what can happen. You know, we quite often review details in 2 dimensions in the facade world because it's easier to resolve some of these details in 2 dimensions. And we'll have something that might be resolved at an architectural level, certainly in 2 dimensions. And then contractors come along, and there are maybe a couple of contractors involved in this detail. You might have a window contractor who's doing the windows and the window jambs. And then, of course, they put dashed lines all over their drawing showing cladding or something else by others. And so there's a bit of an interface issue there. And on this particular example, you can see that the window subbies done their job very well. And they've come and finished their flashing right to the bottom of the column as per their detail. But of course, that interface and the bottom of the column and the cladding, there's a hole through there to the building. And so I suppose a lot of these things, Vince, you would have to solve on site. How do you deal with that? Because you've got 2 trades and they're both saying it's not my job, not my job.
Yes, it all comes back to, it's pretty simple, but, management up front when we're scoping our various packages, whether it's, windows, whether it's structure, whether it's, facade, anything, any trade involved in that detail. I suppose they've got to be set up properly from the start. We try to engage with the consultant team early to make sure that our scopes are correct and they're actually aligned properly with each contractor. And then, it comes back to the whole shop drawing process where, there's a few fail-safe steps through that to make sure that, you do pick up on those certain things. And then generally, if it's a large facade package, we'll have a facade manager who their only role is to manage facade.
Yep.
They're generally experts, they're generally ex-consultants, and they live and breathe facade. So, you do a few steps, and then obviously there's a day-to-day site inspections, bringing out, facade consultants and architects to come out and have a look. There's really it's all about QA in the end and management. There's no real sort of magic trick to all this.
No.
And look, if any one of those steps fail, you'll probably get something like that.
Yeah. I suppose your facade manager is effectively the last line of defence. And ideally, we'd resolve all of this in advance. When it doesn't go right, I don't know if this video will play. Someone at the back might have to just hit there you go, thank you. This is obviously what happens when it all goes wrong. This particular facade is, I think, just a window wall. And there's water flying through the split mullion. But actually, in this particular leak failure, it was really an interface issue. So it was an interface between effectively a head detail and that cladding and water getting into the system and then flowing through the mullions. So this is a good segue to, if I can again hit the clicker, maybe someone can advance the slide to the next one. There's a little bit more crowd participation here. If we can just skip past this one to the next slide. There we go. This is another question for you all. In your opinion, who's ultimately responsible for delivering a weatherproof facade? It's a word cloud, this one, so you can say anybody. Hopefully your answers will populate on the screen as we are discussing this. So, Rob, what do you think?
I'm glad you asked me this question. I've been thinking about it for a while and I wasn't too sure. But since coming to the presentation this morning, I think I realised who it is. And it's Spider-Man.
Always the facade consultant. That's interesting. Oh, facade contractor. Main contractor. This is not good. Natalie, what do you think? Do you think it's better if the architect's responsible? I mean, you guys draw everything. You spend way more time drawing all of these details than anyone else. Or perhaps that's not true.
I think that's the big issue because, I mean, being an architect, we're kind of very liable for quite a lot of things, and we do have extensive insurance. And I think that's something that with the industry changing, and it has been changing quite a while, these compliance overlays that are happening are getting a lot more onerous. And you can see that with the F3P1 and the changes in that. We can't sign off on an F3P1. It's not something that an architect can actually do because we're becoming less and less the expert in that. So a lot of our role is actually about coordination and working really closely with the facade contractor, working closely with the building surveyor, and then obviously the head contractor or facade contractor to get it across the line, because we just can't actually deliver that. So yeah, it is interesting because I still think there's a perception that the architect's very liable for these things and they're supposed to be managing everything and delivering these components, but the industry's changed quite a lot where it's becoming less and less our role and actually more towards the contractor to deliver these components. So
yeah.
I'm not surprised by
what do you think?
To be honest,
currently the main contractor is ultimately responsible for delivering a weatherproof facade.
I probably do agree. We do take especially.
Seriously though, do you think that there's over the last say 20 years, in your experience, do you think there has been more of a shift in trying to push that risk to the contractor, especially through that sort of design and construct style contract?
Yeah, I think it is. With clients not wanting to maybe spend all their dollars on consultancy fees up front, they want to get to a point 50-60% complete, especially from a facade point of view, and then put it onto the contractor to take the risk. And then obviously once we get into it, we engage our contractors, let contracts off whatever we have available, and then it's really developed the last 40-50% design. Yeah. So I think it's just the way it's going. Even with a fully designed facade solution, there's always going to be contractor input when it comes to, safety and quality and budget and program. So, it never goes away irrespective of the type of contract. So we want to be in control of that, because in the end, if it does leak, it's going to be on us. It's not really going to be on the architect or the facade consultant. Well, hopefully it gets to that. But,
so how do you manage that then? So that risk is being pushed down to you. So I suppose in the old days, the architect would have drawn everything. You would have built it in accordance with the architect's drawings. And then when it leaked, you just pointed at each other and said, no, you didn't build it right, or no, you didn't design it right. But if we're pushing a lot of this sort of finalisation of design onto you, how do you manage that risk?
Well, it's similar to what I was saying earlier. It's the collaboration with the design team and client early on. So if we're trying to work through some, technical questions or quite difficult junctions, we workshop that right from the start, and we make sure there are fees to actually allow everyone to do that and to come to meetings and to come to site and then inspect things. Is a perfect world. There's not always that solution there, but that's how we try to get onto it early, understand where the risk is, and then just workshop it out. It's a lot of workshops every week, but it's really the only way. And having the subcontractor on board as well, who's actually going to produce the facade, have them involved early as well. It's really not much more you can do there.
So, Rob,
I guess the thing is that it's when you're designing something, it's the 80-20 rule. That you can't design every interface, and a lot of that has then gone down to the contractor to resolve some of these issues. And it's quite clear some of those issues, it would take 80% of the time to resolve them because they're usually the complicated ones. So in terms of responsibility, at the end of the day, it is the contractor that has to take that responsibility. The architect and the facade engineer have to have understood the principles that it is possible that it could have been weather tight, but they won't have designed all the interfaces. The other thing that I've seen more often than not is that the packages are combined, and you then put maybe a contractor who's maybe on the window side of things to take responsibility for the interface to maybe the rain screen. And so you make clear responsibility judgments, and that their drawings need to show that, and it's clear. Alternatively, you just put it into one big package and send the responsibility to the next person.
Yeah, it does get murky, and then those different contracting models present issues as well, because if you're expecting a fully designed facade, one could argue contractually that the design team retains a large degree of that responsibility. Andrew, as a bit of it, well, now that you were a structural engineer in a past life and now you've moved on and now sit in more a regulatory role, what do you make sense of all this? Who do you think should be bearing the brunt of the risk? Are you surprised that everybody thinks it's the main contractor? Is that surprising to you? Or?
No, I'm not. I think, and it's because of the complexity, I think, because you've got that coordination. So there's not one obvious other than the facade engineer. And there even, we don't really have a true definition of what a facade engineer does, where they stop and where they start. So are they purely the cladding? Are they the cladding, the insulation, the internal linings? Are they all of that plus the structure? And because you've got all those things interacting, and a lot of parties that are responsible for all those different components, it's difficult to sort of say, other than the main contractor who's really pulling all those together and coordinating it. And I think the system works better if you've got the main contractor taking the responsibility and lead on that, and then they're driving good consultants, good people to actually feed them and manage their risks. And where they get poor experiences out of that, they don't pick up those consultants on the next job.
Mm-hmm.
But then you possibly get that the legal piece too, that ultimately the main contractor is responsible for everything, but they might be able to sort of point the finger at others in the chain to say, well, you provided us this, we followed that.
Yep.
That has hurt us, and so I think it's a complex one because these components are multifaceted, multidiscipline.
Yeah, it's a pressure cooker, isn't it? Because if like Rob was saying, if there was a clerk of works, that would significantly mitigate your risks. But if you priced in a full-time, facade clerk of works, if you want to call them that, your price that you present to the client who you're competitively trying to bid a job with, that might seem not competitive. So, so there's that tension between what is effectively, it's in your interest to try and reduce some of that time because that costs you less money, but there's that balancing that risk and,
Nick, I was advised that the cost of a clerk on works for a year is cheaper than 1 day in court.
Look, I'm sure it is. Those lawyers, they do charge a lot of money, yes. So we're kind of coming close to the end of our time. What I might do is I'll ask a couple of the questions that have populated through the Slido. There's a few that have come through there. In the meantime, also, if anyone does have a question, perhaps you can raise your hand and we might get a microphone to you. But I'll just ask one that's been voted up a couple of times. And this is for Andrew C. We've kind of already touched on this, but there are a few people in the crowd that have been asking, is the VBA looking to introduce a qualified facade engineer requirement on projects in Victoria like the New South Wales DPA?
Yeah, so the VBA themselves are the regulator. DTP, Department of Transport and Planning, are responsible for the policy, so they'd actually be looking at registration requirements under the Act and regulations. I think for me, because the VBA has just been doing some work on registrations for building surveyors and changing up how they look at it as well around accepting accreditation from industry organisations. And I think that's something that I like the model, because I think it provides that intermediary step too, that something like facade engineers, you could have your body that you were talking about earlier today, that you've got experts in the area that can actually look at the qualifications experience of individuals and basically say, give a level of confidence to building surveyors and to others in the system that from an industry organisation perspective, you believe they've got the ability to work well in that space.
Yep.
It's definitely something the VBA is looking at for other current registration categories to expand that into industry ability to assess and accredit individuals. I don't know whether it'll go the next step to outside of that, but then having said that, we've got engineers that are registered. It's a matter of can we say we have subcategories within that, and there's also the work that's being done through Engineers Australia at the moment for an area of practice. I think that's the first of step as well. That basically you're defining what it is, what that area of practice is. You've got the industry organisation accepting that and defining it, and so that really is then the first step to registration.
Thank you. Are there any questions in the crowd? Have we got time for maybe one or two questions, Ahmed, or have we run out of time? Maybe one. One in-person question. Otherwise, I'll ask one more question from the Slido. There's some here that are on different topics. I'm not going to read those out because they're not related to this discussion. No hands up. Oh, we have a hand up.
Why isn't there an obligation for collaboration?
An obligation for collaboration.
Right across the whole supply chain. So why doesn't the developer oblige with the consultants, oblige with the head contractor, oblige with the facade contractor to actually collaborate together? Why isn't there an obligation for that? Because you're all talking around who takes responsibility and blame. And a lot of people up there are putting main contractor. The reason that's up there is because you're the facilitator. You're the person that's actually the hub of the thing that happens. Your responsibility there is to take all of the inputs and make sure that the outcome is correct. You know, a facade clerk, you know, one year of that person doing the work for you to confirm that everything's correct saves everybody in that supply chain every dollar that they cost across the board. So the question is, why isn't there collaboration? Why isn't there an obligation for that for everybody? Because at the moment it's all set up to be passed down.
Natalie.
I was going to just speak to that quickly because I think there is an obligation. I think we probably are touching on the very difficulties of what we're dealing with, but I think one of the comments just there is everyone is obliged to create a waterproofing facade. We are all obliged to do that. I mean, as an architect, it's part of our job and our role to do it. It's just, I guess, the complexities that come with code now, the differences in contracts that we're dealing with, budgets, facade systems. I mean, we've even got new innovative facade systems, so the kind of whole construction environment's ever changing. So I think that it is still everyone's responsibility. It's just that I guess the nuances potentially now do tend to fall on the contractor, but it is our job to support that and provide a good outcome so that we get high quality buildings, really.
I think any closing comments on that? Yeah.
I was going to say, I think it's in all our best interests, especially ours, you know, to collaborate right from the start, or else, you know, if you keep someone out, including the client, you know, you don't get the end result. You know, you get a solution that's not fit for purpose, that potentially is not watertight. So I think there is collaboration. I suppose contractor likes to take a bit more control over that, because in the end there's programs and dollars and safety and quality involved in it. But in the end, we try to bring everyone together and collaborate as long as we need to.
Yep.
And I guess although I did say originally it was Spider-Man, that was based on Kieran's presentation where they were pointing to everyone. So yeah, it's coming back that it is everyone's responsibility. But at the end of the day, it is a design and construct contract. The responsibility has been put onto the construction team, and for them to have the necessary skills and resources to be able to manage it.
So from both a design and an implementation perspective. Yeah.
If it's a traditional build, slightly different.
Mm. Mm. And perhaps it's as the professionals who are engaged by the client before, potentially, it's our obligation to make sure that the client understands that there needs to be sufficient rigour placed around it, perhaps.
Yeah, and enough money to be able to do it properly.
Yep. Okay. Thank you for everyone who's asked all the questions on the Slido, and thank you to all of our speakers. If you can give them a round of applause. and we'll hand it back to you guys because we're standing between all of you and a beer. So.
Nick and the panel, I really enjoyed the conversation about building up holistic capability and education around F3P1, everyone's favourite four-letter word. We definitely need to improve on those insurance risk numbers. So I'm going to ask Ahmed to wrap up the conference. We must also thank for another great Zak World of Façades event.
Yeah. Thank you, Kathryn. A round of applause for Kathryn. I think she hosted the event excellently. Thank you, Kathryn. As I said this morning, we've recorded this event, so we'll share a YouTube link with you a week from now. Should be in your inbox, and you can view today's presentations. I hope you enjoyed today's events. We have got a networking reception now, courtesy of friends at NorthGlass. So I'll see you out over there. And hopefully next time, February 2026, we aim to return back to Melbourne. I think we have a surprise also planned for 2026 if all goes well. So I think we should have a larger event and hopefully something new also, which we are planning. So until next time, hope to see you all at least at the next Sydney event in February. Take care. Have a good evening, all of you. Thank you.